Hello there. What you should know before you take the course: you should have a basic understanding of database concepts. You should have a basic understanding of SQL, which is also referred to as structural query language. Who should take the course? The course is an absolute beginner's course, so anyone who is new to database administration, data analyst, data scientist. What will you learn on the course? The course is a practical hands-on course. We'll start off by installing PostgreSQL. Then we'll learn how to load a sample database. We'll create a database. We'll create a table. We'll learn how to insert data into a table. We'll learn how to update existing records in a table. We'll learn how to delete records in a table. We will learn how to get data from multiple tables using table joins. We'll learn how to back up and restore database. We'll learn how to manage roles. We'll learn how to create table spaces. We'll also learn how to use various types of operators. We'll learn how to use aggregate and analytic functions, and we'll learn how to use views and triggers. So these are some of the stuff you will learn in the course. The format of the course is video based, and it is approximately 11.5 hours long. Thanks for watching. Hello and welcome to this lecture. What is PostgreSQL? PostgreSQL is also pronounced as Postgres. So if you hear people saying Postgres, they mean PostgreSQL. This basically is a relational database management system, just like Oracle or Microsoft SQL Server, or things like MySQL or MySQL. So it has basically the same features and functionalities of a relational database management system. It also complies to ANSI. ANSI basically is the American National Standard Institute for SQL, which is structural query language. So it also conforms to this standard. So the SQL you use for the Postgres database also follows the ANSI standard. So there are certain ways you write SQL statements that is applicable to all relational databases. Postgres is a general purpose database management system, so you can use it basically for a variety of things. It is also object relational, so it's known as an object relational database management system. It is free and open source. By open source, that means people can contribute to make it better. It is also platform independent. What that means is that you can install it on a Windows platform, Mac platform, a Unix platform. So it's platform independent. It's not pegged to one platform. So you can use it across multiple platforms. It is stable and requires minimum maintenance. So most applications that uses the Postgres database, you don't really need to spend a lot of time in the maintenance because the database itself is quite stable. The database has large storage. It also has a good performance. It's fast. It is extensible. Basically what that means is that you can define your own data types, index types. You can also create your own custom plugins. The support for the Postgres is quite substantial. There is an active community that you can post questions to and also receive answers from. So that is it for this lecture. The key thing here is to note that the Postgres database is a relational database management system, just like Oracle and Microsoft SQL Server. It is free and open source. It is platform independent. And the SQL you use to query the database also follows the ANSI standard. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I'll be showing you a few companies that have built products, solutions, websites, and tools using the Postgres database. I will start with the biopharm sector. So in the biopharm sector, we've got these few companies listed as using the Postgres database. So we've got companies like American Chemical Society, BASF, Agricultural Product Division, and we've got the Greenet Tech Inc. So these are just a few companies listed as using the Postgres database in the biopharm sector. Next, let's have a look at the e-commerce sector and see who's using the Postgres database. So we've got companies like CD Baby, Champion Products, Etsy.com. We've got Flight Aware, Flight Stats, Red Sheriff, Whitepages.com. So these are companies listed as using the Postgres database. Next, we'll look at the education sector. In the education sector, we've got these institutions listed as using the Postgres database. All these information here have been obtained from the postgres.org website. So if you go to that website, look for featured users, you see all these listed there. Next, let's look at the finance and the gaming sector and see who is using the Postgres database. So in the finance, we've got three companies listed here. Among them is the Trust Commerce. In the gaming, we've got Moby Games listed as using the Postgres database. Next, we are going to have a look at who's using the Postgres database in the government sector. So in government, we've got all these listed as using the Postgres database. Among them are the City of Garden Grove, that's in California. We've got the National Weather Service. We've got United Nations Children's Fund. We've got the U.S. Agency for International Development, U.S. Department of Labor, U.S. General Services Administration, U.S. State Department. Some key government departments here using the Postgres database. Well, we're going to now move on to the healthcare sector, manufacturing, and see who's using the Postgres database. So in healthcare, we've got calorieking.com, and we've got things like Shannon Medical Center. Manufacturing, we've got exo2.net Corp using the Postgres database. And in the media sector, we've got a few listed here, among which are Macworld, Penny Arcade, the Washington Post, and the Greenpeace. Greenpeace is quite important here. I mean, it's well known, so to know that they use Postgres is interesting. Next, we'll move on to open source projects. There are some open source projects that actually use the Postgres database. So in the open source projects area, we've got things like Debian, FreshPorts, GForge, the LAMP. LAMP basically is a LAMP stack, which includes Linux, Apache, PHP, and a few others. And we've got the SourceForge as well, which is quite popular for various types of downloads. So they also use the Postgres database. So next we'll look at the retail sector. We've got a few listed here in the retail sector, things like Safeway, Sutaya, the Rockport Company, among a few. They are listed as using the Postgres database. Let's move on to technology. We've got Apple, Fujitsu, Omnity, Red Hat, Cyrus IT, Sun Microsystem, among others, using the Postgres database. Also some telecom companies as well. Among the telecom companies using the Postgres, we've got Cisco, Juniper Networks, NTT Data, Optus, Rambler Internet Holdings, Skype, and Telstra. So these are the telecoms companies listed on the Postgres website as using their product or using the Postgres database. So that's it for this lecture. In this lecture, we went through a list from various sectors of various types of companies that actually have created products around the Postgres database. If you want to find out more, just head over to postgres.org and /featured users. That will give you a list of who's using the Postgres database. Most of what I've shown you here in this lecture was actually obtained from the Postgres website. Thanks for watching, and bye for now. Hello and welcome. In this lecture, I'll be showing you some minimum requirements that has to be met before PostgreSQL can be installed on your computer. So these are the minimum requirements, regardless whether if you're using a Windows, a Linux, or a Mac. So these are the operating systems that you can install PostgreSQL if you are on a Windows. So it doesn't matter if you're on a 32-bit or a 64-bit Windows operating system. This B here basically means bit. I just left out the I and the T to create some space. So if you've got Windows 7, 8, or 10, then your machine should be ready to accept the installation. Also, if you have Windows 2008 server, Windows 2012 server, you need a minimum of 1 gigahertz of processor speed. This is just the absolute minimum. You need at least 1 gigabyte of RAM. You need at least a gigabyte of hard disk space. You need an account that has an administrator role that you can use to perform the installation. However, if you've got an account that's got an admin role or privilege, you can usually right click on the installation file and select run as admin. For Linux, if you are running a Linux 32 or 64-bit, these are the operating systems you can use. You can use a CentOS 6.x and 7, Ubuntu 14.04, Debian 7 and 8, Oracle Enterprise Linux 6 and 7, and again, a minimum of 1 gigahertz processor speed is required, 1 gigabyte RAM. You need to have a super user privilege on an account. You need that before you can perform the installation. If you are on a Mac, you can install PostgreSQL on OS X Server 10.8, 10.9, and 10.10. You need a minimum 1 gigahertz processor power or speed, 1 gigabyte RAM or memory. You also need a super user account with super user privileges to perform the installation. So these are the bare minimum requirements if you're running Windows, Linux, or Mac and you wish to install PostgreSQL. These are the absolutely bare minimum requirements. So that is it. Thanks for watching. Bye for now. Hello there. In this video, I'll be showing you how to install PostgreSQL on your local system. Postgres was developed for Unix-like platforms. However, it has been designed to be portable. What that means is that it can run on multiple platforms such as Mac OS, Solaris, and Windows. I will be illustrating by installing Postgres on a Windows-based platform. Let's take a look at the steps that we are going to follow to complete the installation of PostgreSQL. So we are going to start off by downloading PostgreSQL installer for Windows. If you're installing on Windows, you do that via an installer. So once we've downloaded it, we'll then install PostgreSQL and we'll then verify the installation. If you are running Windows 8 or Windows 10, you will need to install PostgreSQL on an account that has administrative privileges. So let's begin by downloading the PostgreSQL installer for Windows, and the link is displayed on the screen. So if you head over to that link, and then we can begin the download of the installer. So once you've navigated to the installer download page, there is a link that says download the installer certified by Enterprise DB for all supported PostgreSQL versions. So click on the link and select. There should be an option here for cookies. You can click OK to agree, and then you select your version. Select the latest version that you can see. The latest version is usually displayed on top. As of the time of recording this video, the version is 10.5, so I'm going to click on that. And next you got to select your operating system. So I'm going to click on the drop down and select my operating system. I am running a Windows 64-bit, so I click on that, and then you have the link to download. So just click on the download now and it will begin the download. So that's my download there. It has started. I just give it a few minutes to complete the download. So the download has finished. So I'm just going to double click on the link here to run the installation. You may get a user account control pop-up if you're running a Windows operating system. Just click yes to accept that, and that will allow the installation to begin. So the installation is being processed at the moment. So we just let it go through the steps for processing and initializing the application. You'll be presented with a setup wizard. So click on next, and you are presented with a default installation directory. You can accept that, or you can specify your own installation directory. I would recommend you accept the suggested location that Postgres has specified. Just click next, and then you have this select component option. So make sure you accept all the boxes that have been checked. What that means is that it will install all the options here checked: PostgreSQL Server, the pgadmin 4, Stack Builder, command line tool. Just accept all and click next, and it tells you a data directory. it has specified a data directory for you. You can either change that or accept the default. I would accept the default. Click next. Next, you are given an option for a password. So you have to provide a password for the database super user for the Postgres database. So specify a password that you can remember. So this password here that you're setting up now is going to be the password for the database super user and service account. So once you've set that up, click on next, and it's specified a port. Please select the port number the server should listen to. The server has to listen to a specific port, so you have to specify one. By default, a port 5432 has been suggested for you. Please leave it as the default port and click next. And then you are asked for a database cluster if you want to set up a cluster. I would advise you leave the default, which is default local. Leave that as the default and just click next. Click next again, and then click next again. And we just wait for the installation to run through. The installation may take a few minutes to complete. The installation has now completed. You can uncheck this box here for the stack builder. The stack builder basically can be used to download and install additional tools, which includes drivers and applications that will complement your PostgreSQL installation. So I've unchecked that because that is not necessary at this stage. When you're done, just click on the finish button. Let's verify the installation. There are several ways to verify the installation. For example, you can try to connect to the PostgreSQL database server from any client application, for example, PSQL or pgadmin. However, the quickest way to verify the installation is through the pgadmin application. So let me show you how to access that. To access the pgadmin application, you do that from the programs menu and you click on the PostgreSQL folder. I'm just going to click to expand that, and within that we've got this pgadmin 4, which is an administrative tool for administering PostgreSQL database and its various objects. So click on that to launch it. The pg4 is an admin tool for managing PostgreSQL. So let's under this browser here, let's click on the plus sign, and under servers we've got PostgreSQL 10. Click on that and let's try. It's trying to connect to the server. It says you're currently running version 3.2 of pgadmin. However, the current version is 3.3. Please click here for more information if you want to do that. So let's expand the server. You can click to update it if you wish, but I'm just going to exit out of that for now. And you can notice here it's giving you option to enter the password. So this would have been the password that you would have entered when you were trying to run during the installation process. So if you enter that password in there, it should let you connect to the server. You've got the option to save, but for security reasons, I don't think that's a good practice. So once you've entered that, click OK. And it says, you can see here on the bottom here, it says server connected, which means you have successfully connected and verified the installation. Once you have connected, and if everything is fine, the pgadmin will display all the objects that belongs to the server. So if I expand where it's called databases, you'll be able to see all the various objects that belongs to the server. You can see all these are all objects, and we're able to verify that because the installation has been a success. To see the properties of each of the objects here, you can just click on the object. For example, if I click on databases, you can see it shows that this is a Postgres database. The owner is this, and then you can click on other objects as well, login groups, and so on. So that concludes the installation of PostgreSQL. So congratulations if you have successfully installed the PostgreSQL database server on your local system. If you had any problem during the installation, please feel free to let me know. I'll do my best to help. Thanks for watching, and bye for now. Hello there. In this video, I will be showing you a couple of ways to connect to a PostgreSQL database. The first is via an interactive SQL shell, which is a terminal. It's called PSQL. And the second option is by a GUI. GUI basically is a graphical user interface using the PG admin tool. Let's try and connect to a PostgreSQL database using the PSQL tool. The PSQL is an interactive terminal program provided by PostgreSQL. So you can do a lot with it. For example, you can execute SQL statements, you can manage database objects, and so on. So let's try and play around with the tool and connect to the database. The first thing we need to do is launch the PSQL program, and you launch that from the PostgreSQL folder. So if you expand the folder and if you scroll down, you should see the SQL shell, which is PSQL. So if you click to launch the shell, so this is the shell. So the first thing you need to do basically is provide answers in different steps just by pressing tab or enter on your keyboard. So if you press enter, it will give you the name of the database. You press enter again, it will give you the port it is listening to. You press enter again, it will give you the username. Press enter and it will prompt you for a password. So you enter the password that you specified during the installation of PostgreSQL. Once you enter the password, if it's correct, it will give you this screen, and you can see you've got the hash symbol next to the Postgres, which means it is waiting for some instructions. So what I'm going to do, I'm going to type in a very simple SQL statement to determine the version of PostgreSQL. So you just type in select and then you do a space, type in version. So make sure you wrap the version number in parentheses, opening and closing, and then you terminate it with a semicolon. Press enter. It will give you the version. So you can see here, this simple statement has given me the version of PostgreSQL. So you can see from here, this statement has returned one row. So we've successfully connected to the PostgreSQL database. To exit out of the program, all you need to do is hit Ctrl and C, and you will get a prompt asking you to terminate. Just hit yes and press enter, and that will terminate the program. So let's take a look at a second method we can use to connect to a PostgreSQL database using the pgadmin tool. This tool is a GUI application. That means it is a graphical user interface that you can see things in a graphical way. To access the pgadmin tool, you need to open up the PostgreSQL folder by expanding it, and you should see the pgadmin4 tool. Just click to launch the tool. It's an administrative tool, so we'll give it a few minutes to fully launch. So this is what the pgadmin tool looks like. When you launch it, you have to select an object in the tree view. This is the tree view, so you click on the plus to expand it. You can see a red cross there, which means you have not connected to the server. So if you just click on it, it will give you this pop-up box to enter your password to connect to the server. If you don't want to enter the password each time, you could click on save, but I wouldn't recommend that. It's not really a good practice, although it's okay if you're working in your own environment, but it's good to develop good practices right from the start. So I'm not going to save the password. I'm just going to enter the password I entered during the installation of the database. So I'll click OK, and you can see here it tells me the server is connected, so I can now access the database objects. You can see if I expand that, you can see all the various objects belonging to the database. We can quickly run a very basic query to test that we can communicate with the database. So in this view tree here, under databases, make sure you've got the Postgres database selected, and then under tools, click on the query tool. The query tool is where you'll execute your query. So let's type in a simple query. So I'll do select, I'll do a space, I'll type in version, and then wrap it round parentheses, and then I will add a semicolon. So this, if you just press this here, this little symbol that looks like a lightning ball, and that will execute the query for you. All right, so it has now executed the query. So if you put your mouse over the output here, you can see the output that was returned, which is this text displayed there. So we've successfully been able to determine the version of the Postgres database from a very simple query. To exit the pgadmin tool, you just click on the X, and it will ask you a prompt. Are you sure you want to leave? Just say leave, and that exits the application. You can also connect to a PostgreSQL database from other applications. So any applications that supports the ODBC driver or the JDBC driver can be used to connect to a Postgres database server. In addition, if you develop an application that uses an appropriate driver, the application can connect to the PostgreSQL database server using that driver. So let me quickly explain what ODBC and JDBC is. ODBC stands for Open Database Connectivity. It is an open standard application programming interface, which is API, that is used for accessing a database. JDBC stands for Java Database Connectivity, which is an application programming interface as well, API, for programming language Java. There's a programming language called Java. So it defines how a client can access a database. So it's basically a Java-based data access technology used for Java database connectivity. In this video, you have learned how to connect to Postgres database server by using different client tools, which included PSQL and pgadmin tool. Okay, I also briefly introduce you to ODBC and JDBC. So these are APIs that can be used to connect to Postgres database from other applications. Thanks for watching and bye for now. Hello there. In this video, we are going to download and load a sample PostgreSQL database. I have already downloaded the database for simplicity, and the database is basically in a zipped format. So I've got the database in a folder here, so I'm just going to click on it. So this is the database. It will be available for you to download under the resource area for this lecture. It's in a zipped format, so you need to have a software extraction tool to extract the database. So you can use WinRAR, you can use WinZip, or any software extraction tool you have available. You can use that to extract the database content. So let me walk you through the steps we are going to take to download and load the sample PostgreSQL database. So we're going to start off by extracting the zipped database. We're going to extract it to a .tar format. Once we've done that, we're going to create a folder on the C drive or any drive you wish, and then we'll place the extracted tar format into that folder, and we will create a new database using the PSQL tool. We need to create a database to restore the sample database into. Once we've created a new database, we'll then have to load that sample database using a command line tool. If you're on Windows, you use the command prompt. If you're on a Mac, you can use the terminal. Once we've loaded that, we'll then verify the loaded sample database by running just a basic query to make sure everything works. So let's begin by extracting the database. I'm just going to click on this folder here, and the software extraction tool I have is called WinRAR, which is actually free to use. So I'm just going to right click and click on extract here, and it will extract the content. You can see now it has extracted the content. You can see this is the extracted content. If I right click and click on properties, you can see that it is now a .tar format. All right. So what I need to do is now go into my C drive. Let me right click and copy this, and I'll quickly go to my C drive, and on my C drive I will create a folder called temp just by right clicking and going on folder, and I'll call this folder temp, and inside this temp folder I'm just going to right click and paste the tar formatted file. So this is the extracted database in the tar format. I've placed it into a folder on my C drive called temp. Next thing we need to do is create a database using the PSQL tool. So within the PostgreSQL folder, just click to expand that, and then click on the SQL shell, which is the PSQL. And what we need to do is create a new database. So just press enter to just provide some answers until you get the prompt to log in. All right, so we've got the username. Now you need to enter your password. So enter the password you entered during the installation of the database. Once you've entered the password, you need to create a new database. And the way you do that, you type in the command create, you do a space followed by the word database. Okay, you do a space followed by the name of the database, and the database is going to be called DVD rental. Okay, DVD rental, that is the name of the database. And then you end that with a semicolon. You press enter. You may get a prompt to enter the password. If you do get the prompt, just enter the password. If you don't get the prompt, it will return back to the command line, which means it has created the database. So once you get that create database, that means the database has now been created. The next thing we need to do is load the sample database from the temporary file that we extracted it to. So to do that, we need to open our command line tool if you're using Windows, or you can use the terminal if you are on a Mac. That's my command prompt. I'm just going to right click and click run as administrator, and that will open up a terminal window. So this is my command prompt here. So the first thing I want to do is just navigate to the C drive. So I'll do that by typing cd ... and that will navigate backwards. I'll do cd again ... and press enter, and that will give me the C drive. So I've now navigated to the C drive. The next thing I want to do is locate where my PostgreSQL was installed and add that to the path. So what I need to do is open up my folder and go to my programs menu and locate, it's usually in program files. So that's my PostgreSQL folder here. So I'm just going to click on that and then click inside that and then click in the bin. So this is what we want. So what you do, highlight this path here for the bin directly, just copy that, and then we go back into our command prompt, just type in cd, and then you paste the path into it and press enter. You can see now we are now referencing the bin directory from the Postgres installation. So I'm just going to type in CLS to clear the screen so that I only have the path I want. The next thing I want to do is to use the PGRestore tool to load data into the DVD rental database. So this is the tool here. I pasted in this here. So you have PG_restore. You do the --U. That basically specifies Postgres user to log in to the PostgreSQL database. That's what that is. And then we have the DVD rental. Okay, and that is a path to the extracted sample database. So just press enter, and that will ask you for a password to the database. So you just enter the password to the server and press enter. You may get some errors. So if your console or your terminal is clear and it returns to this command here, that means it would have loaded the database. So if we launch the pgadmin GUI tool, we can use that to check the database that was loaded. So open up the GUI tool by locating it inside your PostgreSQL folder. So that's my PostgreSQL folder, and I'm just going to click on pgadmin4, and that's my pgadmin4 tool here. So this is the tool here. So it tells you here under databases is giving me 4 here. So if I expand that I've already expanded it. You can see the DVD rental database. So if I expand that, you can see all the objects belonging to that database. If I come here and on the schemas, we've got the public schema, and these are all the objects of the schema. If I click here, you can see the tables. These are all the tables. There are 15 tables in this sample database. So if I want, I can do a quick test by going on the tools here and opening the query window. It's saying no object selected. I need to select an object. So I select the schema and come here and do query, and it will reference that schema. You can see here it's got DVD rental. That means it's referencing that database. So I should be able to execute a query against any of the database tables. So I'm just going to pick this table called actor. So I will type in select and star from the table called actor. I'm using the asterisk because I want it to select to return all the records from that table. I then press this symbol here, and you can see the output here. It tells me successfully it has returned 200 rows from this table. So this is a verification that we have successfully loaded the sample database. In this video, we downloaded and loaded a sample PostgreSQL database. We started off by extracting the zipped database into a .tar format. We created a temp folder on the C drive and placed the extracted tar format into that database. We then created a new database in PostgreSQL using PSQL. You have to create a database in order to load the sample database into. So we did that. We then loaded the sample database using the command line tool, and we were able to verify the loaded sample database by running a very basic query on one of the tables in the database. Thanks for watching. If you had any problems during the loading of the database, please feel free to contact me. I'll be more than happy to help. Thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I will be showing you how to download the latest version of PostgreSQL for Windows. We are going to be downloading the latest version for Windows. We are going to head over to this link here to begin the download. https://www.postgresql.org. So let's head over to that location. So this is the site for PostgreSQL. So once you're here, make sure you're on the download page by clicking on this download button. And once you've clicked on the download button, it will give you various options. We are interested in the Windows option, so we're going to click on Windows. Click Windows, and that will give you this page. We want to download the installer to make it easier for us, so click download the installer, and that will take you to the installer page. And the first thing you need to do is select your version. We want to use the latest, so I'm going to click on the drop down, and this is the latest, so I'm going to click 9.6.2. The next thing we need to do is select our operating system. So I am running Windows, so I'm just going to select this, and it will be Windows x86 followed by your bit. If you're running 32, you click 32. If you're running 64, you click on this Windows x86-64. I'm running 32, so I'm going to click on this option. If you're not sure if you're running 32 or 64 bit, the way you find out is go to your start menu, right click on my computer, go properties, and there's an option here that says system type. Within the system type, it will tell you if it's a 32-bit or 64-bit operating system. So I've already made my selection, which is a 32-bit. So I'm going to click download now. So I'm just wait for a few minutes for the download to start. So that's my download. It has started. It is 156 megabytes in size. So please make sure you've got enough space on your disk to accommodate this file. The download has completed. So if I click on this little arrow here and click show in folder, it will take me to the location of the downloaded file. So my file has been downloaded into my downloads directory. So in the next lecture, this is where I'm going to install the software from. So that is it for this lecture. In this lecture, we learned how to download PostgreSQL for Windows. Many thanks for your patience and thanks for watching. Bye. Hello and welcome. In this lecture, I will be showing you how to install PostgreSQL for Windows. Please note that if you are running Windows 8 or Windows 10, you will need to create a Windows user account that has administrator role or privilege. You then need to use that user account you've created to run the installation. For example, you can create an account for the installation called Postgres and make sure it's got local admin privileges and use that account to run the PostgreSQL installation files. I will be installing on a Windows 7 machine, so I don't need to create a special account for that. So locate your downloaded files. Mine was saved to my download folder, which is this folder here. So all I need to do is just run the installation. So I just right click on the file and select run as administrator to begin the installation process. So it will initialize the files, which can take a while. The processing power on your local computer basically will determine how long the installation will take. But on an average, it take more than 5-10 minutes. So once you're done, once it's initialized, you should get this screen come up. Click on next. You are presented with an installation directory and there is a suggestive location here. I would recommend you accept that. If you don't want that, you can click here and select a location where you want it installed, but I will strongly advise you just accept it, especially as this is a test environment. Click next. Again, you're prompted for a location for the data directory. A location has been put in there for you. You can accept that or select your own. I will advise you accept the location that has been suggested for you. Click on next. This is important. You need to enter a password and also retype the password. This password you will need to enter each time you try to connect to the database. Very important you enter a password that you can remember. I have entered the password and I've also retyped the password. So enter one you can remember and click next. This is auto-populated. If you've already got the PostgreSQL installed and then that may be the reason why this is not populated, because it tends to use this port number. So if you haven't got it installed and this port number is not available, then you need to do some troubleshooting, because this port has to be available for PostgreSQL. So this is usually auto populated for you. Click on the next button. Again, this should be auto populated. Accept the default locale. Click next. It says setup is now ready to begin installing PostgreSQL on your computer. Click next. And this process can take a few minutes, again depending on the processing power of your local computer, so please be patient. Once the installation is complete, you will get a screen like this come up. You can uncheck this. This stack builder basically enables you to install other stuff that you may need for the PostgreSQL installation. But because this is a test environment, I'll just uncheck that and click finish. So we have successfully completed the installation of PostgreSQL. Thank you for your time, and bye for now. Hello and welcome. In this lecture, I'm going to show you how you can verify the PostgreSQL installation for Windows. So a very quick way to verify the installation is just to see if we can access the default database. So click on your start menu, click all programs, and within the all program there should be one for Postgres. So look for the PostgreSQL 9.6 folder, click to expand it, and click to open up pgadmin 4. That is the admin console that you can use to administer the PostgreSQL database. Please be patient. This can sometimes take a little while to open up. Okay, so mine is just about to open up now. When the pgadmin 4 tool opens up, this is what you'll see. So to verify the installation was successful, we should be able to connect to the servers. So click on this plus button here to expand it. If you can see this, if you can expand it, that means the installation has been successful. However, if you click on this plus sign here, it will give you a window asking for your password. This will be the password that you set during the installation. So just enter that password in there, and then you can click OK. You can save the password if you wish, but I don't recommend it, so that you don't form a habit of doing that. That can be a security risk in a production environment. But if you're on a test environment, it doesn't really matter, but it's good to cultivate good habits even if it's a test environment. Once you've entered your password, click OK, and if it works okay, you should get a different screen here. So this is the dashboard. You should get a message that pops up to tell you that you have connected to the server. That briefly pops up, then disappears. So this is a server. So if you can expand the databases, and this is a default database that was added. It tells you here databases 1. So if you can expand that, that means the installation has been verified and successful, because you can access aspects of the database. So while you've got the databases selected, you can flick through different aspects here. This is a dashboard area. You can click on the properties. It shows you a different view for the properties. It tells you the name of the database and give you some other information there. And if you click on the SQL here, it gives you the SQL that was used to create the database. If we click on statistics, again, give you different views here, so you can read through, and then click on dependencies. If there's any dependencies, it will show the dependencies. So let me just click on the dashboard. So if you can access all these and move things around, your installation has been successful and verified. So that's it for this lecture. Thanks for watching, and bye for now. Hello and welcome. In this lecture, I am going to do my best to guide you as to how you can install PostgreSQL on a Mac. I haven't got a Mac to show you, but I will do my best to guide you as to how you can do this. The installation should be slightly different just because of the format. However, you'll be using the same graphical user tool that I used to show you the installation on a Windows-based computer. So we're going to start by going to the website. So the website is https://www.postgresql.org. So we're going to head over there to download the file. So this is the home page for the PostgreSQL. So if you click on this download tab here, you will have different options. So if you are on a Mac, you need to click on the Mac OS, click on that option. And then what you need to download the installer. You see this option here that says download the installer. This is what you need. So click on that, and that will take you to the installer page. So where you've got select your version, you select the version of your Mac. For example, if the version of the PostgreSQL, so select the latest version, which is usually at the top. So select that one, and then for your operating system, click on the drop down arrow and select, there's only one option for Mac, just select Mac OS X, and then there's an option to download. So you can click on the download, and that should download to your Mac folder or download that. I've just clicked on the download, even though I'm not on a Mac, and this is the file. So it packages it as a DMG file, which is a disk image file. So to extract the installer, you basically simply have to mount the disk image and copy the installer to the desired location, or you can run it directly from the disk image. Please note that by default, Mac OS X ships with shared memory settings that might be too low for running the PostgreSQL. However, the installer will detect this and, if possible, reconfigure the shared memory, and then may prompt you to reboot the system and rerun the installation. So if you get that happen, don't be surprised. So that's basically it. So just run this DMG file and just follow the screen instructions. So that's it. Thanks for watching. Any issues, please let me know. Bye for now. Hello and welcome. In this lecture, I will show you different ways to connect to a PostgreSQL database. You can connect using an interactive terminal program, which is also the shell, the SQL shell, or also known as PSQL. Or you can use the graphical tool, which is known as pgadmin. So that is the graphical admin tool. So those are the two ways you can connect to a PostgreSQL database. So both the SQL shell, which houses the PSQL, and the pgadmin GUI are installed when the Postgres database is installed. So let's go over to our program menu and explore both options of connecting to the data. To launch PostgreSQL, you click on the Start menu, go to All Programs, click on the PostgreSQL 9.6 folder, click to expand, and this is the SQL shell which houses the PostgreSQL. So click to launch, and when you open it, this is what you get. If you press enter, it will also add the database name. This shows you that the server is localhost, so it's a local installation. So press enter, it will give you the database. So it tells you the database name is Postgres. That's the default database that comes pre-installed when PostgreSQL is installed. If you press enter again, it will give you the port number, which is 5432. And if you press enter, it will give you the username that is used to connect to the database. So this is the username called Postgres. If you press enter, it will prompt you for a password. The password it's asking for is the password you would have set during the installation of the database. So just type that password in. So I'm just going to type mine and press enter. If it is right, it will connect to the database, and you get this warning here with some instructions here saying blah blah blah. But if you can see this flashing cursor, it means that you have successfully connected to the database, and this means the database is just waiting for some instructions. So as it is, you can execute a SQL query. Once you've got that flashing cursor there. So that's how you connect to the database using the SQL shell or the PostgreSQL. So I'm just going to exit out of that. The second option is to use the pgadmin tool. This is also located in the same directory as the SQL shell. So click on Start, All Programs, go to Postgres, click on that, and this is what we want, pgadmin 4. That's the current version. If you click on that, it will launch the pgadmin tool, and the latest version of that tool is version 4. Please be patient with this tool. It can sometimes take a while to open up. Once the tool opens up, we can connect to the database by expanding the servers here where it's got servers. Click on the plus sign to expand, and you've got the PostgreSQL 9.6. So click on that. It will give you an option to enter your password. So I'm just going to click expand that. There you go. So this should pop up. It says connect to server, and the username it's using to connect is Postgres. So you need to type in the password you set during the installation. So I'm just going to pop my password in there and click OK. And if everything checks out, you can see here it says server connected. Once you're connected, it tells you you are connected, and we can now access the database. So these are at the moment we've only got one database. That's why it's got one there, which is the default database installed with the PostgreSQL database, which is this one here. That's our default database. So basically those are the two main ways you can connect to a PostgreSQL database. Another way to actually interrogate or interact with the database is via the query. So if we click on the tools here and go to select the database first, make sure you got the database selected, and then click on tools and click on the query tool, and that should bring up the query editor. So just write a simple query that will interact with the database. So you just type in select, followed by the version. You're looking for the version, and then parentheses and a semicolon. And then you click on this arrow there to execute the query, and it will show the result in the output here. So this is the output for the query. It tells you the version is PostgreSQL 9.6 and give you some information about the build and so on. So this tells you, you can expand this. By the way, you can see I've just dragged it to expand it along to reveal more information. So it gives you the version and tells you it's compiled by Visual C++ and the rest of it. So that's one way of also interacting with the database. So thank you so much for watching. In this lecture, we've learned how to connect to PostgreSQL database server by using different methods. Thanks for watching, and bye for now. Hello and welcome. In this lecture, I'll be showing you how to load a sample database into PostgreSQL. The sample database we are going to use is called a DVD rental database. This is a sample database taken from the Sakila sample database from the MySQL site. So this is the database I'm referring to. So basically I made some slight modifications to it to make things a lot easier for you. It's called a DVD rental. I've already extracted it here. So this is the extraction. This will be included in the resource page for this lecture, so you can just download it and follow along. This database should be more than enough for us to learn and practice using PostgreSQL. The database itself contains many objects. It has 15 tables, 1 trigger, 7 views, 8 functions, 1 domain. It also has 13 sequences. So once you've got the file downloaded, this file here, which is going to be available for you to download inside your resource page for this lecture. Once you've got that downloaded, what I need you to do is go to your local drive and say your local C drive if you're on the Windows, okay, and create a temp folder. So create a folder called temp, as I've done here, and add that file to it. So on your C drive, make sure you have a folder called temp and just add the DVD rental zipped or extracted file, the actual compressed file. Don't extract it, just make sure you add the compressed file into that temp directory. You can see 2 other files. These are not related to this lectures. These are other files that I can delete this actually because they're not related to this course. So you should only have this compressed file called DVD rental inside this temp directory, which is housed in the root of the C drive. Once you've got that done, launch the admin tool, which is I've already got it open here, which is the PG admin tool. You can launch that from the all programs, go to PostgreSQL and click on PG admin 4. So I've already got the tool selected. Make sure you've got the next thing we need to do, because we are going to load a database, we need to create a new database. So to do that, you right click on where it's got databases and go create database. So we are going to create a new database called DVD rental. So we need to give the database a name. I'm just going to call it DVD rental. I've got it all in lowercase, but it's up to you, it doesn't really matter. And the owner will be this user here called Postgres. And then in the comment, you can say whatever you want. I'll just say DVD rentals. Okay, and just click save. And by clicking save, that should install the database. So if I right click and refresh this now, this figure should change. You see it's already changed to 2, which means we have now successfully created a database called DVD rental. Now we can load the sample database. To do that, you just right click on where it says DVD rental, right click on that, and there's an option to restore. Click on restore. All right, you get this saying please configure the PostgreSQL binary path. All right, so what we need to do is configure the path for that. So click OK and click on your file option, go to preferences and look for path. This is what it's complaining about. Under path, click on binary path. And inside the binary path, we need to go to where we installed the software. So we installed in program files, and there should be, click on Postgres and click inside that folder, click on the bin directory and click to get the path. So this is the path it's asking for. Copy that and paste it in there and say OK. If it's happy with that, there should be no complaint. So what you need to do now, we can go back and restore the database. So click on DVD rental, click on restore, and that error should no longer occur. Okay, format, select format is going to be custom or tar. Click on that. File name, we need to select where it is, the location. These 3 dots here gives you, enables you to browse the location of where the files are. Okay, alternatively, you can manually insert the location of the file. So we're just going to go to where we've got the file stored. It's in a temp folder, this temp folder here. Because sometimes it's slow. Now it's opened up. Sometimes that can be slow to open. So we click on that, the C drive, and it's inside the temp folder. It says it can't find any files. Okay, so I'm going to click cancel. Sometimes it can have problem locating the files. So I'm just going to go manually and get the location, which is in the temp folder, DVD rental, and then just cancel out of that. If you click, what you need to do is just do a slash and add DVD rental. That's it. And just get the path from there, copy and paste it in here, and that should be it. You can leave the other option blank. Role name, you don't really need that. Or you can just select Postgres, which is the user that has the privilege to install the software. So click on this restore button here, and if everything goes to plan, it tells you here restore job created, restoring backup on the server, gives you all kinds of information regarding the backup. It tells you successfully completed. So we have successfully restored the database. So we can quickly check the database. This is the database here. If you click on this schema to expand it, The tables will be located inside the schema, and the name of the schema is public. Click to expand that, and then we can see all the objects for the database. So these are the tables. These are the trigger sequences. Let's focus on the tables here. Let's expand that. We should see 15 tables. It tells you there 15 tables. So we've got all our tables loaded. So we are good to go for the rest of the course. We've got our lab sorted, and we can progress with the rest of the course. So if you've successfully loaded the database, well done. If you've got any issues, please do not hesitate to let me know. Many thanks, and bye for now. Hello and welcome to this lecture. In this lecture, we are going to look at the server service. When you install Postgres for the first time, you usually will have a corresponding Postgres server service. It is also referred to as the Postgres server. So let's open up our admin panel so we can take a look. So to open up the admin, go start and look for the Postgres server, the folder. So you see a folder here called Postgres 9.6. Click to expand and click to open the pgadmin 4, and that will launch the admin panel. This can sometimes take a while to launch, but it shouldn't take too long, hopefully. So once the pgadmin opens, we can click on the plus sign here to expand the servers. So you can see the list of servers. So just expand that. And you are prompted for a password. So this will be the password set when you install the Postgres database. So type in the password. You get prompted for this password each time. If you don't want to get prompted, you can click to save, but that is not a good practice, especially in a production live environment. But if it's a test environment like we are doing now, you can do that, but it's good to cultivate good habits, regardless if you're in a live or test environment. So click OK, and that will give you access to all the databases and objects of the Postgres. So when you install an instance of Postgres, you also have a corresponding Postgres server service, which is also the Postgres server. So you can see the list of servers here. We've got the Postgres. This is actually the Postgres server. You can install multiple Postgres servers on a physical server using different ports and also having different locations to store the data. So it is possible to install multiple Postgres servers on a physical server, provided you use different ports and also store the data in different locations. So if you want to see more, just click on this Postgres here option here, and then click on properties, and you can see a more detailed view of the server service. So it gives you some information here. It tells you the name, the server type, PostgreSQL, the version, gives you the version, and it tells you the port number it's installed to. 5432 is the default, and tells you connected, true. And let's have a look. And here maintenance tells you that, username, SSL mode, give you optional prefer. So these are some information you can access from the property option when you select the Postgres option here. And the server also has some databases here. So if I expand the databases here, you can see it's got 2 here, which means there are 2 databases listed. The one is called the DVD rental, which is a sample database that we loaded on. And this Postgres database is the default database that comes when you install an instance of the Postgres relational database system. So the key thing here in this lecture is to note that the Postgres server service is also known as the Postgres server, okay, which is this one here, and that comes installed when you install an instance of the Postgres relational database system. So that is it for this lecture on the server service. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, we'll be exploring a database. A database basically is a container of other objects such as tables, views, functions, indexes, and so on. You can usually create as many databases as you want inside a Postgres server. So a database is a container of other objects, which includes objects like tables, views, functions, indexes, and other objects as well. So let's go over to our admin panel and have a look at the database and its related objects. I have already logged in to the pgadmin4. If you are not logged in, you can log in via go to all programs and select the Postgres folder and then click to launch the pgadmin4. Once you launch it and you try to access the database or the server, it will prompt you for a password. Just enter the password you set during the installation of the Postgres database. So the databases on this Postgres server at the moment are two. We've got this DVD rental that we loaded, and we've got the Postgres database. This comes built in when you install an instance of the Postgres server. It also installs a Postgres database. So what I'm going to do, I'm going to expand this DVD rental database so we can have a look at some of its related objects. So all these here are all related objects for a database in the Postgres server. So I'm just going to expand this here, the schema here. So within the schema, there is also the public. Let's expand that, and then we can take a look at some other related objects like a table. We've mentioned the table. So these are the tables for this database. If I expand that, you can see it says there are 15 tables for that database. And also you've got things like functions. You've got various types of functions for this. These are functions doing different things. We've also got sequences. So if if you're trying to add a record, you want them to be in sequence and so on. And then you've got views. Views are like tables, are like virtual tables. So these are all related objects of a database. So the database itself is a container of other objects, and these here, anything under this, this is the database. All these here are all container objects for the database. So that's basically what a database is. That's it for this lecture. Many thanks for watching. Bye for now. Hello and welcome to this lecture. A table is basically used to store data for a database. So any data that is stored in a database is usually stored inside a table. In a database, you can create as many tables as possible. Open up your PostgreSQL 4 tool. I've already logged into mine, and I'm just going to explore some of the tables inside this DVD rental database. So I've got the DVD rental database expanded, and I'm just going to expand the schema. And from within the schema, we've got the public expanded, and there is some tables here. So I'm just going to expand the tables. So these are all the tables here for the DVD rental database. And data for a database is usually stored in table. What I'm going to do, I'm going to run a very quick query so you can see how the table data is structured. So I'm going to run a quick query to see all the columns and rows for this table here called actor. So to do that, I'm just going to right click and click on query tool. And the query tool is the tool you need. It's a built-in tool that you need to interrogate data from the database. So this is a tool here. So I'm just going to write a quick statement here. Do select. So I'm now using SQL to communicate with the database. I'm just select star meaning all from the database. The table is actor, and you have to put a semicolon at the end to indicate that's the end of the statement. So what this statement is saying is that I want to retrieve all the data that has been stored in this table here called actor. So if I click on this thing here that looks like a lightning bolt, and that will execute the statement, and it will show the output in this window here. So it tells you here the total query time, tells you the time it took basically. So this is the structure. So this is how a table stores data in columns and rows. So you can see the columns here going this way, and you can see the rows here. These are all the rows going vertically and the columns going horizontally. So you can see this is all the data from this table here called actor. By using the asterisk sign, it retrieves all the data from the columns and the rows relating to that table. So this is basically how a table stores its data in columns and rows. And a database stores all its data inside tables. They have various tables, and the tables also can have some relationship between each other. So we've got a table called actor. There may be some kind of relationship via one of the columns to other tables within the same database. So that is it for this lecture on tables. Many thanks for watching, and bye for now. Hello and welcome to this lecture. What is a schema? A schema is a logical container of tables and other objects inside a database. Each Postgres database can have multiple schemas. A schema is useful in a production environment in that you can assign permissions to different IT professionals to perform various tasks within a specific schema. I have signed into the PostgreSQL 4, and here on the database section, we've got a database called DVD rental. And if you notice here, we've got the schema. It says here there's only one schema, and that schema, you can see the symbol here is a public schema. If I right click, we can look at the properties of that schema. It gives you the name, which is public, and tells you who owns the schema. And there's also a comment here, it tells you standard public schema, which means everyone has access to this schema. However, in a production environment, you can create several schemas, and within that schema, you can have various database objects inside that schema. For example, you can create a schema called finance and assign permissions to those who only work in the finance department. You don't really want to make that type of schema public for everyone to see because it contains sensitive information. For example, people's salaries and other financial related information. So schemas are quite important because you can use schema to group related objects and then just assign permissions to that schema. You could also have a schema, for example, for IT professionals, and as again, you assign specific permissions to those who can perform tasks within that schema. Even within a schema, you can still lock things down if you wish to. You can, for example, you can create a schema called finance, and within that finance schema, you can also lock certain tables or limit the access to certain tables from people who work in that finance department. But schemas are good in that they help, they act as a logical container to hold various database related objects. So that is it for this project on schema. Just know that the schema is a logical container that holds tables and other objects inside a database, and it is possible to assign permissions to schema so you can restrict who has access to the objects inside a schema. Many thanks for watching, and bye for now. Hello and welcome to this lecture. What is a table space? A table space is basically a storage location where the actual data that is underlying the database objects can be kept. It basically provides a layer of abstraction between the physical and the logical data, and also serves to allocate storage for all relational database managed segments. We know that data in a database is actually stored in tables. In the actual tables, they are actually stored in table spaces. By default, Postgres has two table spaces. The two default table spaces provided by Postgres when the relational database management system is installed are the PG default and the PG global. So these are used. The first one, which is the PG default, is used for storing users' data, this PG default, while the PG underscore global is used for storing system data. So PG underscore default stores users related data, and PG underscore global stores system related data. So we can take a look at the default table spaces. If you log into the PG admin 4, I've already logged in, but if you're not sure how to log in, just go to Start, All Programs, click on the Postgres folder, and just click to open the PG admin 4. Once you click on the database, it will prompt you for a password. Just enter the password you set during the installation. So let's have a look at the default table spaces. So under here, you've got table spaces. You can see there it's got two, which means there are 2 table spaces. These come as default when you install the Postgres server. So let me expand so you can see them. So you can see the first one is called PG_default. This is used to store user related data. So any data relating to the users is stored in this table space, while the second is PG_global. This table space stores any data relating to the system. So these 2 come as default when you install the Postgres server. So that is it for this lecture on table space. Thanks for watching. Bye for now. Hello and welcome to this lecture. What is a view? Views are basically virtual tables that are used to basically help simplify complex queries. They can also be used as a kind of security to protect certain records from others. So views basically are treated just like a table, so you can execute or run queries on a view just as you would on a table. You can use views to hide information or protect certain parts of a table from others to see. So you can create views from a table. The sample database, which is this DVD rental, has some views. So let's take a look at them. So we're going to expand the schema here. From the schema, if I scroll down, you see we've got 7 views here for that table, for that database. So if I click to expand, you can see these are different views. For example, we've also got if I look, notice here we've got a view called actor info. Let me click to expand that. So views basically have same characteristics as a table. So you've got columns and you can also have rows. Okay, so these are all the, so you can query, basically you can query a view just as you would a table. So let's quickly query this view here. We've got a view here called actor info. So let me right click and select the query tool, and it should launch the query tool shortly. And when it launches, I'm just going to quickly query this view. So you query them the same way you would query a table. So I'm going to just do a simple query here. Just select star. Star means I want all the rows and columns from that view to be returned. Select star from. You always have to use from to specify where the data is coming from. So the data is coming from the name of the view is called actor underscore info, and then place a semicolon at the end of the statement. So this is the name of the view here. If I execute it by pressing this here, it should give me an output here. Okay, so basically this is, it tells me here 200 rows retrieved from this query. So it basically behaves the same way as a table. It's basically a virtual table. So you run query, you can run queries on views just as you would a table. If I click on this table, I've got tables here. I've also got a table called actor. Okay, and you see here I've got a view here called actor underscore info. So views are virtual tables, and they're quite useful in that you can use them to simplify complex queries. Okay, and also you can use them as a security measure to hide certain records from certain people or certain parts of the organization. So that's basically what views are. Many thanks for watching. Bye for now. Hello and welcome to this lecture on functions. What are functions? Functions in Postgres are basically a block of reusable SQL code. The code can also return a scalar value of a list of records. It also can return composite objects. Let's take a look at some functions that have been created inside our sample database. We've got a sample database here called DVD rental. So if I expand the schema, we can see inside the schema there are functions. So we've got 8 functions for this database. So let me expand that. And they do different things. So they're basically SQL code that can be reused over and over again. So these are all the various types of functions created for this sample database. So you can create your own functions as well. So let's have a look at one of them here. This one here says get_customer balance. That's the name of the function. So to explore the function, I'm just going to right click on the properties of one of them. This one here that says get_customer_balance. And I go properties. And within the properties, we can have a look at several things. So let's start with the definition. So click on this definition tab. And if I just expand this, you can see more about the function, how the function was written. So you've got the arguments for the function, the types of arguments the function takes is in there, the type of value it returns, it tells you it's numeric, the language is PGSQL, and this is the actual code, okay, that generates the function or activates the function. So this is the actual code. These are basically SQL statements. So that is the definition. Let's look at the options here, what we've got in the options. All this estimated cost 100. Let's look at arguments. So you can look at different aspects of the function to see how it was created and what it does. So these are the data type. The data type is integer, which means it's a number. You've got timestamp without the time zone. You've got arguments p_customer ID, p_effective date. Let's look at the parameters. There's no parameters set. What about security? No obvious security issues here. Then look at the SQL. It tells you nothing has changed since it was created. So no modification has changed. So the SQL part of it has nothing new to explain because nothing has changed from the when it was defined. So I can just click cancel out of it. So you can do the same with the others just to look through to see how it has been set up. So the key thing to take away basically is that a function is a reusable block of code. If there are specific tasks that you perform repetitively over time, you can build that into a function and just execute that function to perform that task. You can also delete a function as well by dropping them. For example, if you no longer need it, just right click and there's an option to delete or drop a function. And you can also create a function as well using this tab and using the create function tab. So different things you can do. You can create scripts from them. You can using the create script, or if you just want to read data, you can use the select script to extract SQL from the functions and just read data from the database. So several things you can do with a function tab. So that's basically it for this lecture on functions. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I'm going to explain what a cost and operators are in Postgres. I'll start with a cost. Cost basically enables you to convert one data type into another data type. When you perform conversions using cost, it's usually done in combination with functions. So you use functions in combination with cost to perform conversions. Postgres has default cost, but you can create your own custom cost that will override the default ones created by Postgres. Operators in Postgres basically is a symbolic function. So Postgres allows you to define custom operators. Looking at our sample database, we have an option for cost. As you can see, there is none at the moment, so no cost has been created. So if we had created a cost, this is where it will be. Also functions, also the operators are a kind of symbolic function. So if you need to create or define your own custom operators, you also can do them, and they will be housed within the schema. So you've got the functions tab here, so you can create your operator, which are a kind of symbolic function. So just to wrap up for this lecture, cost basically enables you to convert one data type into another data type, while operator is basically a symbolic function. So in Postgres, it allows you to define your own custom operators. When you are using cost for conversions, you use it in combination with functions. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'm going to briefly explain what sequences are. Sequences are used to manage auto increment columns. That is, columns that have auto increments on them. This is usually identified with ID columns, columns that have to be unique. We are going to look at our sample database and see the sequences that have been created for that database. Please log into your pgadmin 4. I've already logged in, and select the option for the sample database, which is DVD rental. Click on the plus sign to expand it. And if we expand it further, go to where the schemas are, expand the schema, and we should see the sequences. This database has 13 sequences. So let me expand that to see. So these are the various sequences that have been created for this database. So let me take a look at one of them so we can see how sequences actually works. Normally when you create sequences, you can see the naming convention. You have to name it with the underscore. You have to have a seq to indicate that it is a sequence. So let me click on this one here, the first one here, actor underscore actor ID sequence. So obviously there's a table here called actor, and that table, there's been a sequence created for that table. So I'm going to right click on this one here and select the properties. So if we go to the property, it tells you what the name of the sequence is. If we look at the definition, it tells you Normally, when you create a sequence, you have to set a maximum value. So here, this is a maximum value, and it tells you here, this is the current value for this sequence. So for example, if I was to insert another data into this, into this table, and I use the ID, it will increase it by 1. So it will now turn that into 201. So it's a column that auto increases. So if I insert a record for, say, actor ID, it will automatically change that value to 201. So let's look at the security on that. Nothing special. Look at the SQL, nothing has changed. So I'm going to cancel that, and I'm going to see if I can create a script. If you want to create a sequence, this is the syntax. You just click on create sequence, and it gives you the option. You have to name the sequence, the owner, the schema, and then you have to define the sequence. You specify the increment. How is the sequence going to increase? Is it going to increase by 1, by 2, and so on? So these are all the parameters you set when you create a sequence. So I'm going to right click and go where it's got create script. I'm just going to create the script. This is a script that would generate for you if you want to create a sequence. So let me just break it down a bit so you can see. So this is what the sequence looks. This is basically how you create a sequence. This is the SQL for it. You start with the word create sequence, and then this public here indicates the schema, which is this schema here, and this here is the name of the sequence, okay, which is actor _ actor ID sequence. The sequence will increase by 1. So if you want to insert records into a table called actor, that sequence, the ID column, will automatically increase to the next value. If, for example, the first record that you created has an ID of 1, the sequence will, when you create another record, the sequence will automatically give it an ID of 2, and so on. And this increment means it increases by 1. So if you add another record, that record will assume the next value. For example, if the record is 4, it will assume 5. The next added will be 6, and so on. Also here is, notice that it says start 200, which means that the current record for that table is 200. That means there are 200 records in that table. So if I was to add another record, it will increase by 1. That means the next record will now be 201. So there's an increment value, there's a minimum value, and this is the maximum value, which is the amount of sequences that can be created. This is the value of the, and then you have a cache. Normally you can have a sequence in cache and use that. All right, so it tells you who owns the sequence, and if you want to alter and make modifications, you can use the alter sequence command to make modifications. So this here basically is the query you use to create a sequence. So it's basically the same thing as when you write, if you do create sequence, and in the definition, all this here listed here is basically what this SQL is doing. Sequences are useful also in a live production environment. If you've got several people updating the same record or adding new records, you don't want the records to be out of sync. So by using a sequence for a column, when one adds a record, it automatically, attaches a sequence value and increases that record. So sequences are quite useful to keep records in sync. So that's it for this lecture on sequences. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'll be explaining briefly what the concept of extensions are in Postgres. Basically, in Postgres, extensions are used to wrap other objects into a single unit. The main purpose of extensions basically is to make it easier to maintain. So by wrapping other objects into a single unit, it's easier to maintain them. The types of objects you can wrap up into a single unit as an extension includes cast, indexes, functions, and other objects. I have logged into my pgadmin4 and going to take a look at the built-in extensions that has come pre-installed with the instance of Postgres database, and also the sample database we loaded has also got an instance of an extension. So I'm just going to expand the databases. We've got two databases listed, so I'll click on the plus sign. We'll take a look at the sample database we loaded, which is this DVD rental. So I just expand that, and you can see we've got one extension, and the extension is a PLPGSQL. So if I go to the properties, we can see the name, that's the ID, the owner. Let's look at the SQL. This is the SQL basically used to create it. This is the schema it belongs to, pg_catalog. Let's look at the stats. Dependencies, non-dependents. Okay. It's got some dependents here. There is a function that's dependent on that, and we've got these functions all dependent on that. So there is some dependence, but no dependencies. So extensions basically are used to wrap other objects to make it easier to maintain. So we've got one extension here in PLPGSQL. So let's have a look at the default database that was installed, which is this Postgres. If I expand that, it has two extensions. So let's have a look at what the extensions are. We've got the PLGSQL, which we've looked at an instance in the sample database, and we've got one called admin pack. So I'm going to right click and go properties, so we can look at the properties. That's the name. And it tells you what it does. It's for administrative functions for Postgres. So a lot has been wrapped into this admin pack. We can look at the definition. Just tells you the version. Look at the SQL. Nothing has changed. If we come here, right click. If you want to create a new extension, you use that with the create command, and click on create extension, and that will give you all the options and parameters to add. Again, you can delete or drop a extension, you can cascade, you can create a script from it. So if we wanted to create a script from it, it should also generate a script. So this is a script. I'm just going to bring it down a bit, so you can see this is basically a script that's been used to create this extension called admin pack. So that's it for this lecture on extension. Extensions basically is a concept where you wrap other objects into a single unit, making them much easier to manage. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'll be going through some basic database concepts. We'll begin with the database, what a database is. A database basically is a collection of organized information or data that is stored in a table. A table, on the other hand, stores information in rows and columns. So a table will store usually a collection of related data entries in columns and rows. This table here is similar to what a database table is. So the columns are horizontal. For example, this word terminology can be referred to as a column, and this word meaning can be referred to as a column. The rows, these rows are going vertical. So these database, table, columns, all these are referred to as row. So basically, this is how the table is structured in a database table. So you've got the columns going horizontal and the rows going vertically. Each row in a database table is referred to as a record. A schema is a collection of database objects. I will show you examples of this later on in the course. So any item is referred to as an object in a database. A database is an object, a table is an object, a view is an object. So these are all objects. So a collection of database objects housed in a container is referred to as a schema. Primary key. A primary key is a unique identifier, such as your driving license number or your health insurance record. Is a unique identifier that is used to identify unique records. So no two people can have the same records. So you are able to enforce that using a primary key. A foreign key, on the other hand, is like a primary key, but not exactly. It is used to reference a primary key in another table. For example, if table A has a primary key and table B has a primary key too, so you can have the primary key from table 2 acting as a foreign key in table 1. Likewise, you can have the primary key in table 2 acting as a foreign key in table 1, or vice versa. So a foreign key usually is used to reference another primary key in another table, but primary keys are unique per table. You can't have two primary keys in one table. There are two other concepts I want to illustrate with you. We've got the relational database. A relational database is a database with related tables. Also, we've got the concept of relational database management system. It's referred to as RDBMS for short. It is the software that manages the databases. So examples of the relational database management systems are Oracle, Microsoft SQL Server, MySQL. There is a lot more, but I've just restricted my examples to these three. So these are the basic database concepts that you will come across when working with SQL. Hello and welcome to this lecture. In this lecture, you will learn about the data types in Postgres. We're only going to cover the basic data type. And the data types includes the Boolean, which is a Boolean value, character, number, temporal, array, and special types. A Boolean data type can hold one of three possible values. So it can either be true, false, or null. Null meaning there is no value. So when you insert data into a Boolean column, Postgres will convert it into a Boolean value, which could be yes for true, or false, or N for no. So if the value is a 1, it will be a yes or a true. If the value is a 0, it will be a no or a false value. A null value means you don't know what the value is. So null doesn't mean, it just means empty. You don't know it. There are three main types of character data type. So you've got the char, you've got the varchar, and you've got the text. So the char data type basically is a fixed length character with blank padded. So what that means, if you insert a string is a text. If you insert a string that is shorter than the length of the column, Postgres will pad the spaces to make up for the other. The n here refers to the character. So you can have, maybe if you've got 4 characters there, what you're saying is that you want the column to take 4 characters. If you only enter 2 characters out of the 4, Postgres will pad the other spaces to make up the 4 characters. That's what that means. However, if the character is longer than the length you have specified, for example, if I specified 4 characters and I insert or try to insert 5, Postgres will complain because the character limit has been exceeded. The next is the varchar. The varchar, the n here represents the number of characters that you pass in there for it to accept. Varchar basically is a variable length character string, so it can accept strings or text or variable length. You can store up to n number of characters with variable length characters, so you can store any amount with this variable length character. The n value, it's variable. So you can store up to n characters with the variable length character strings. Postgres does not pad any spaces when the stored string is shorter than the length of the column. Unlike the char, if, for example, I specify 255 characters and you only enter, say, 10 characters, Postgres does not bother to pad the other spaces as it does with the char type. The next is the text. So the text also is a variable length character and it accepts strings. If you notice, I have not put an n value here because with the text type, you don't need to specify the length, of the character. So basically, theoretically, a text has an unlimited length of characters. So you can enter an unlimited number of text you want in that field if you wish to. The number data type. Postgres provides 2 distinct type of numbers. The first is integers, and there are 3 types of integers. So you have the small integer, which basically is a 2-byte signed integer. And then you've got the integer itself. This is a 4-byte integer. And then you've got the serial. The serial basically is the same as integer, except that in Postgres, it generates and populates values into a column automatically for you. So if you're creating a table, for example, and you have an ID column and you want it to auto-populate, you'll have to use the serial data type. The next type of number data type is the floating point number. There are 3 main types of floating point numbers. You've got the float, and the floating point number whose precision at least n represent the number and has up to 8 bytes. The next is the real or float 8. This is a double precision or 8-byte point number. The float can also have up to a maximum of 8 bytes, but it must have at least an n value. Then we have the numeric or numeric PS. This is a real number with P digits and S number, which is, these are precision numbers. So we have the P digits with S numbers after the decimal points. The next type of data type is the temporal data type. This data type stores things like date and time related data. There are 5 main temporal data types in Postgres. So I'll start with the first one, which is a date. The date basically stores date values. And then we have the time that stores time of the day value. We've got the timestamp that stores the date and the time. And then we've got the interval. The interval stores periods of time. And we've got the timestamp. This stores both timestamps and the time zone data. The timestamp is a Postgres extension to the temporal data type. The next data type is the special data type. So besides the primitive data types, Postgres also provides several data types related to the geometric and network. So the first is the box. Basically, this is a rectangular box type of data. And then you've got the line. So some of these are used with geometric or network related. And then you've got the line, which is a set of points. And then you've got point, which is a geometric pair of numbers. And then you've got the one seg, which is a line segment. Then you've got polygon, which is a closed geometric. You've got the inet, which is an IP4 address. This is a network related. And then you've got the MAC address, basically refers to the MAC address on a network card. The final data type I'm going to talk about is the arrays data type. An array basically allows you to store an array of strings. You could also store an array of integers and so on. Array basically are multiple variables. So a variable can store one value. An array can store multiple variables as one value. So you can store an array as strings, you can store an array of integers, and so on. Just remember that an array contains several variables. Where a variable stores one value, an array can store multiple values as one array. So that is it for this lecture on data types. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to use the Postgres unique constraint to ensure that the value in a column or a group of columns is unique to a table. So there are times where you want to ensure that certain columns have unique data across the table. For example, you may want the email addresses to be unique, the username to be unique, or the employee ID to be unique. For example, if you are dealing with social security numbers, you don't want two people to have the same social security numbers and so on. So you ensure that by using unique constraint. Say for example, we're trying to create a table. Normally when you create or you implement unique constraint, it is better to do that at the table creation stage. So when you're creating a table, for example, I'm creating a table called person. These are the columns. And you can see here on that email, I've implemented a unique, I've added unique, which means I want every record in this column to be unique. So you can apply unique constraint to multiple columns within a table. So let me show you how this works by actually creating this table. I've already added a script to my query tool, and I'm going to create a table inside the fruit database, this database here. So this is the script to create a table, and I've added a unique constraint to the email column. So let me go ahead and run the script to create a table. Okay, there's some error. Okay, now I've created a table. What it was, I had other scripts inside this editor, and he was getting confused with which one I was trying to run. So now it has created the table. So now it's time to insert records into the table. So this is the script I've written to insert a record into the table. So I'm just going to highlight it here. So I'm going to insert this record into the table we've just created. These are the columns of the table. This is the name, and that's the email address. The email address is where I've applied the unique constraint. So let me run that. If I run that, it tells me query successful. So I now have a data with someone called this, with these details on the table. So let me quickly do a select statement on the table. I'll do select star from person. All right, so let me just refresh the table list. Okay, so I've got a table called person. So I'm just going to highlight. When you have several scripts in the editor, it's probably best to highlight the script you're trying to use. Sometimes the editor can get confused, even though you've got a semicolon to indicate that the statement ends there. So I'm just going to run this so you can see. So this is our table. It contains one record. It's got John, Doe, and so on. All right, so that's the record for that table. Quick thing I want you to notice, although it's not part of this constraint, is that if you notice here, the primary key for this table, I've given it, it's got data type of serial. So when I was creating the table, when I was doing the insert, I didn't have to automatically add the one number. When you're using the serial data type, it automatically populates this primary key or this integer value. All right, so it's done that for me. Anyway, that's not what this is about. So this is about unique constraint. All right, so I've added one record. So let's assume I want to add a second record. I've now got someone called John. I want to add Jack. Okay, I want to add Jack to the table. Notice I'm going to use the same email address as I've used for Doe, because they've both got the same initials, haven't they? This guy is John Doe, this guy is Jack Doe. So they've both got same initials, but there's going to be an error because I've implemented a unique constraint. So let me run that. You can see the error. Duplicate key value violates the unique constraint person email key. All right, so it tells you here the email j.doe@bluelime.com already exists. Okay, so that is the constraint working. So it will not allow duplicate entries in a column or duplicate data. So to get around this, I can just change this to 2 and make this j2 dot. Let me insert that, and hopefully that should work. You can see it has not worked. If I do a select on the database, on the table, I should have 2 records in there. I've got a John Doe and a Jack Doe. You can see the email addresses are different because they are now unique. So that's how you implement a unique constraint. Thank you for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I will be introducing you to the where clause. The where clause basically is used to act as a filter to filter rows that are returned from a select statement. Without the where clause in a statement, it can return all the data you have specified. So the where clause acts as a filter to filter out the records that are returned from a select query statement based on certain conditions or criteria you have specified inside the where clause. So let's look at how you write a where clause. So the syntax basically is this. After your select statement, after you key in this keyword, you've done your column select if you're selecting specific column. If not, if you're selecting all the column, then you can replace the column names with asterisks. You specify the name of the table and then the where clause. The where clause usually appears after the from. Okay, so you must place it after the table name, which is after the from keyword. Then you place the where clause. Inside the where clause, you specify the conditions that must be met for the returned data from the query. All right, say for example, you can specify that you want to return data from column 1, column 2 from this table where maybe the first name begins with this or certain conditions matches a certain criteria. So the where clause will be acting as a condition. If the condition you specified in the where clause is met, then the relevant data is returned. So let's illustrate how this where clause is used. So I've logged into my pgadmin 4. And these are the tables from this DVD rental database, the sample database here. And I'm just going to pick a table to work on. I've got a table here called customer. So let me quickly right click on this table and go to the properties so we can see the properties of the table. So this should reveal things like the columns of the table. So if I click here now, we can see these are all the columns of the table. So let me run a quick query on the table. I'm just going to right click and go query tool. I'll wait for the query tool to launch and then I'll write a very quick select statement. So I'm going to do select star from customer, which is this table here. And that should, if I execute this, that will give me, it will return all the data. You can see 599 rows retrieved. All right. So say for example, I don't want all this data retrieved. It has received 599 rows. And if I don't want all 599 rows returned, I can apply a filter. Okay, and the filter will reduce the amount of records returned. At the moment, it has returned 599 rows. You can see here saying 599. So I want to apply a filter here. So to do that, I'm going to get rid of this semicolon there and type in the where clause. So this is a where clause that will act as a filter. Then I need to specify the condition for the where clause. So I'm going to say where the store underscore ID. Notice here we've got store ID 1, some of them are store ID 2. So I'm going to say where the store ID is equals to 2. I've now applied a filter. So the data that's going to be returned from this query should be less than 599 records, because I'm using this filter here to restrict it. So I only want to return data that matches the store ID number 2. Anywhere where the store ID is 2, those are the data I want returned. So notice I've used an equals to here. Equals to is known as a comparison operator. So that's what we use to compare. Okay, so if I run this now, just watch out, it should return less than 599. So let me execute that. Look out here, it says 273 rows retrieved. So we've been able to filter the rows that have been returned using this query here. So the where clause here acts as a filter, and you can specify any condition inside the where clause. So whatever condition you specify in the where clause, when the query is executed, it will compare that condition, and based on the condition you've specified, it will return the data that matches that criteria. So that's how you use a where clause to act as a filter. Thanks for watching, and bye for now. The where clause is also important when you are deleting records. So you can use the where clause to act as a filter so you don't delete all the records from a table. Inside the where clause, you can specify what you want to delete or what you want to update. Very important, the where clause. Bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to query data from all the columns within a table. To query data from a table is quite easy if you want to query all the data. The syntax you use is this, very basic and simple. You just type in the select keyword followed by the asterisk symbol. The asterisk symbol basically means retrieve all the columns and all the rows from a table. You need to specify from keyword, which indicates where you're getting the data from. So let's go ahead and do that. Let's log into our PG admin tool. So go to all programs. If you're on the Windows, click on the Postgres folder and click on PG admin 4. If you're on a Mac, look for the PG admin 4 icon and click to launch. Once it launches, we need to connect to the database and then begin writing the query. Once it launches, click on the plus sign on the left here to expand the server. It tells you you've only got the one server. Click on the plus sign here and you should get a prompt to sign in. So enter your password. This will be the password set during the Postgres installation. Ooh, looks like I've got mine wrong. Let me try again. Okay, this time it tells you server connected on the bottom there. So let me expand the databases. The database we are going to use for this lecture is the sample DVD rental database, this one here. So I'm going to click on the plus sign. If I click on the plus sign, it should tell me here database connected on the bottom right. So I'm connected to the database. You can see the dashboard here. I need to expand the schema. We've only got the one schema, which is public. So I'll click on the plus sign and that should reveal all the objects within that database. So the tables, this is what I'm interested in. Let's expand the tables. So these are all the tables for this sample database here, and I'm going to go for the customers table this time. So I want to query all the data from this table. Before I do that, I just want to check the properties of the table. I'm just going to right click on the table and go properties. and it's trying to retrieve data from the server. Let's give it a few minutes to do that. Okay, so it tells us here, name of the table is customer, the owner of the table is Postgres, schema is public, the table space where it stores this data is PG_default. So let's check the columns here. We can see these are all the columns of the table, and I want to retrieve data from all this column. I'm not going to be specific of which column I want the data from. I want the data from all the columns. So I want all the columns and all the records. So I'm just going to click exit. Next thing I want to do is access the query tool. So I'm going to right click on this table here called customer and click on query tool, and that will launch the tool I can use to write the query. So give it a few minutes. We now have our query tool here. I'm just going to drag that. The output will be displayed in this area here. So to build the query, you type in select. SQL is case insensitive, so you can write select in lowercase if you wish. Doesn't really matter. So I do select followed by the asterisk. Asterisk indicates that I want everything, all the columns, all the records from the columns and rows. And then I specify the name of the table. I like to write the keywords in capitals so that they stand out. And if you notice also, the keywords are also colored, makes them stand out. So from is where I'll specify the name of the table, which is customer, and then a semicolon. Semicolon is important, always good in case you have several statements inside the editor window. The semicolon indicates the end of one statement. So it's a good practice to always end your statements with a semicolon. So what this query is saying basically is get all the records from the customers table. This asterisk means retrieve all records from all columns. So let's execute that by clicking on this lightning bolt here. And it's trying to do that. And it tells you here 599 rows retrieved. So this is everything from this table called customers. All right. So you can see all the columns on top, and these are all the records, okay, from this table. It's 669, it says. Okay, so we've got everything, all the data that's ever been saved into this table. We have captured it using this simple statement. So basically, this is how you use the select statement to retrieve data from a column. If you use it with the select and the star, it gets every data from the table and displays it in the output. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to query data from specific columns within a database table. The syntax we are going to use is this. Basically, we use the select keyword followed by the column names, and then we select the name of the table and enter it into the from field. So this here is the structure or how we would write a select statement to query data from specific columns within a table. We are going to be querying data from our sample database, which is the DVD rental sample database. So let's go ahead and open up our admin tool and begin. So let's launch our admin tool. Go to your start, all programs. If you're on a Windows, if you're on a Mac, look for the Postgres folder and make sure you click to open the pgadmin 4 and give that a few minutes to launch, and then we can try and connect to the Postgres server and access the database. So give it a few minutes, it should load. Once it loads, you need to expand the server option within the browser here. Click the plus. And once you expand, you need to click on this and you should have a prompt that you have to enter your password. So click on the plus sign, it will give you this prompt here. So enter the password. The password will be the password you would have set during the Postgres installation. So just enter that password in there. Once you've entered it, click OK. And you should now, it tells you server connected just on the bottom. So once you're connected to the server, you have access to all the databases and the objects. So I'm going to expand this databases option here. It says we have 2 databases. So we'll give it time to expand. The database we're going to interrogate or query is this sample database here called DVD rental. So click on the plus sign to expand the database objects. All right, so it tells you here database connected. So we need to expand the schema area and expand the public schema and get access to one thing that is good practice is before you query data from a table, it's always good to check the table structure. So these are the tables for the DVD rental here, and the table we are going to query for this lecture is going to be, let's just pick a table. I'm going to query this table here called city. So I want to check the structure first so that I see how many columns it's got and so on. So I'm going to right click on the city here table and go properties. So when the property page opens up, it gives me the name of the table. It's called city. Tells me who owns the table. It's owned by this user here. The schema is public. Table space is this. So let's check the columns. This table has 4 columns. This is the data. These are the data types. So we've got city ID, city, country ID, and last update. So what I'd be interested in from this table is the city column and the country ID. So I want the city and the country ID. So those are the 2 columns I want to query data from this table. So let me begin by writing the query for that. So I'm going to right click on this city here and click on the query tool. And that will give me the editor where I can write my query. So this is where I'm going to write my query. So I've already decided that there are 2 columns I need. I need the city. Let me expand these columns here so we can see them. So I need the city column and the country ID. So this is how I would specify the select query. To select, SQL is case insensitive, so you can make it uppercase or lowercase, it will still work. So I'll just select the columns. So the first column will be city, comma, followed by country ID. Country underscore ID. And then the next will be the from. From will be the name of the table is called city. And this is basically the select statement completed. So I'm querying data from specific columns here. The columns from this city table here is the city, which is this column here, and the country ID, which is this one. Rather than get all the data, I only want specific columns. And I've ended the statement with a semicolon. Notice the keywords here are highlighted, so you know that they are keywords, the select and the from. Now I'm going to execute the query and the output should show here. So click on this, that looks like a lightning bolt, or you can press F5 and it should execute the query. And so this is how it tells you total query runtime 600 rows retrieve. So this is basically the city and this is the country ID. All right, it tells you here, it shows the data type it shows you the data type and then the name of the columns. So that's the city here. This for example, this is a city called Abu Dhabi and the country ID is got 101. And if I scroll down, we can just pick another country. We've got Dallas here. We've got 103. City, these are all cities. And then these are the country IDs. So basically, this is how you retrieve specific data from a table by selecting specific columns, and then you query the data from those columns. So that's it for this lecture. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to remove duplicate records using the distinct keyword. There may be times where a select statement may return several or multiple duplicate records, and you may want to reduce the duplicates. And the way you achieve that is by including the distinct keyword in your select statement. Let's have a look at the syntax to create a distinct statement. So this is what you do basically. You include the keyword distinct inside your select statement, followed by the column names you want to apply the distinct to. And obviously you still have to use a from to indicate the tables coming from. You can order the data after the distinct has been applied, and you can order by either in ascending order or descending order. So let's have a look at how this works. So log into your pgadmin4. I've already logged in, and once you've logged in, select the DVD rental database. Just click on the plus sign to expand the database objects, and it should tell you the database is connected. Expand the schema and click on the public schema. Let's expand the tables. So these are all the tables for that sample database, 15 of them in total. Before we go ahead and remove the duplicates, I want to run a quick query that will show the duplicate entries. So the table I'm going to go for here is this table called inventory. So if I click on the plus sign, you can see all the columns from that table. There's only 1, 2, 3, 4. The column I am interested in is this column here called film ID. So right click on the name of the table and go query tool. It will launch the query editor. So I'm going to write just a very simple select statement, and I'm going to select just one column here, which is this film ID column. So I'm going to select film ID, film underscore ID. From the table name is called inventory, and a semicolon to end the statement. So now let me execute by clicking on this icon here that looks like a lightning bolt. If I click on that, it will output the query. So you can see all these duplicates here. These are all duplicate entries. You can see 1, 1, 1, 2. So there's a lot of duplicate entries. You see several 4s and so on. So this is what I want to get rid of. And the way I do that is to add a distinct keyword to the select statement. So I just come here and type in distinct. Oh, I got it wrong. Just remove the I, remove the, that's it. You can see the color has changed as well because it's a keyword. If I now execute this query, these duplicates will be gone. It will only show me one instance of each. All right, so I'll execute that again, and you should see that the duplicates are gone. What I want to do also is I want to order it. So I include an order by. I'm going to order by the film ID. And I'm going to order it in ascending order. That is from A to Z. If I run this again, it will filter the data. You can see now the data has been returned and it's filtered, and there's no duplicates. You can see I've got 1, 2, 3, 4, and so on, but the duplicate entries have been removed. So that's basically how you use the distinct keyword to get rid of duplicate records in a table. So that's it for this lecture. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to sort data returned by a select statement. So we are going to use the order by clause inside our select statement to activate the sorting of the data returned. This is what the syntax will look like. So the format basically will start with a select keyword. We will select specific columns from a table and then apply the order by clause in order to sort the data returned from the select query. So let's launch our PGAdmin4 tool by going to all programs. If you're on the Windows, click on the Postgres folder and then PGAdmin4. If you're on a Mac, also locate the PGAdmin4 icon and click to launch the icon. Once the tool launches, let's connect to the server by clicking on the server plus here. And then if you click on the Postgres server, it should give you an option to log in. So click on the plus sign and we just need to enter the password. So the password will be the password set during the installation of Postgres. So I'm connected. It tells you here server connected on the bottom right. So let's access the database. We have two databases here. The database we are going to run this query on is the DVD rental database. So I'm going to expand that. It tells you here database connected. So let me expand the schema and then the public schema. And let's look for the table. And these are the tables for that database. We got 15 tables, and the table I'm going to query here is the country table. I'll go for the customer. Sorry. I'm going to query the customers table. So if I expand that, you can see all the columns from this customer table. Let me just expand this a bit so you can see. So these are all the columns from the customer table. I'm going to select specific columns here. I'm going to select the first name and the last name column only. So let me open the query window by right clicking on the table name and clicking on query tool. That will launch the query editor from where we can build the query. So this is a query editor. The query will be outputted in this area here. I'm just going to drag that down a bit to create some more room. All right, so let's write the query here. The query I'm going to write will be a select. I'll start with the first name column. Always specify the column the way it's been defined. So I'm going to do first name underscore name. You use a comma to separate the column names. And then I've got the last name here, and I'll type in last underscore name, and then I'll specify the from. Always good to write your keywords in capitals to make them stand out. The editor here also gives them a specific color to make them stand out. So in the from field is where you specify the name of the table, which is customer. And that is basically it. I'm not going to include an order by yet. The reason being, I want to execute this query so you can see the difference when the data is sorted and when the data is not sorted. So I'm going to click on this icon here to execute. As you can see, this is the output from the query here. The data is not sorted in any way. You can see here the first name here, you got say Jared, you see Linda, you got Elizabeth, you've got Dorothy. So there's the data is not kind of like, it's not ordered in a way. So it is returned the way the data was entered into the table. So we can change that by adding an order by clause. So the way it is now, without using an order by clause, it sorts it in ascending order. So now I want to be specific and apply an order by clause. So to do that, when you are adding an order by to your statement to filter data, it's usually the last thing you add to the statement. So I'm just going to add an order by. I do order by. I'm going to order by the last name column here. So you can order by first name or last name. It doesn't really matter, but I'm going to order by last name. So I'll do last name. Underscore name. And then I want it in a descending order. When you use the order by, you have to specify how you're ordering the data that is returned by the select statement, either in a descending order or ascending. This is the current structure here of the output. You can see Ellie, Smith, there's no order here. You can see the A appears here, Anderson, and you can see J there. So by the time we run this query again, after adding the order by, this last name will be structured in the way it is sorted. You'll see a more structured ordering of this column here. So keep an eye on this column here. All right, so let's execute the query again. And we just see, as you can see, we've ordered the data in a descending order. That is from Z to A, if you will. You can see here, it displays young first, Y, and then if I scroll down, you can see, you probably see if there's any A, it will be right at the bottom. Let's scroll down. You can see these are the A's because of the way I have ordered the data. All right, so if you're ordering in descending order, it will take the format of Z to A. If you're ordering in ascending order, it will be from A to Z. So if I change this, for example, from descending to ascending and run this again, it should change the structure. You can see now the ordering is different. Is from ascending means A to Z. You can see that now A appears first and so on. So that's how you sort data returned by a select statement. So if you don't specify the order by, the default is ascending. So when you are ascending, it sorts the data from A to Z. If you're using descending, it sorts the return data from Z to A. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I will be introducing you to the Postgres order by clause. When you query data from a table, Postgres normally returns the rows in the order that the data were inserted into the table. In order to sort the result set, you use the order by clause inside the select statement. So basically, the order by clause allows you to sort the rows returned from a select statement, and it does this in ascending or a descending order based on the criteria you have specified. So the main purpose of the order by clause is to sort the data that has been returned from a select statement, and you can specify the way in which the order is returned or it is sorted. By default, it is sorted in ascending order, but you can change that by specifying your preference inside a select statement. So let's look at the syntax. So the syntax is this. This is how you would include an order by clause inside your select statement in order to sort the data that is returned from the query in a particular order. So you start with the select statement. So you're selecting, say, column 1, column 2 from the table. This is the table you're selecting it from. And then you specify the order by. The order by is usually comes after is the last thing you add in a statement. So you usually specify the order by clause after the select statement, the from, and then you specify the order by. And when you order by, you can specify the column you want to order by. So you can order by a specific column. Here in this syntax here, we're saying we're ordering the first column in ascending order, and we're ordering the second column in descending order. So that's how you specify the syntax when you want to sort data returned from a select statement. If when you write a select statement and you don't specify an order by default, the data that is returned from a select statement is sorted in ascending order. So if you don't specify an order by, it would automatically sort the data in ascending order. In other words, it will order the data in the order in which the data was inserted into the table. For example, if Joe Bloggs was inserted into the table before Anna Smith, then when the query is returned, it will return Joe Bloggs before Anna Smith, unless you specify an order by to sort the data. So when you are ordering data or sorting data, you can sort it by multiple columns. If you're sorting by multiple columns, you need to separate each of the column by a comma, just as you would here when you are selecting columns to retrieve data from. So if you are ordering by several columns, make sure you separate each of the column by a comma. So the key purpose of using the order by clause is to help you sort or filter the rows returned from a select statement. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to divide rows into groups by using the group by clause. The group by clause is used to divide the rows returned from a select statement into groups. Using the group by clause, you can apply aggregate functions to the columns. For example, you can apply aggregate functions like the sum to calculate the sum of the items, or you can add the count aggregate function to the columns. With the count, it enables you to get the number of items in a group. So let's look at the syntax for implementing a group by clause. So it's always implemented with a select statement. So you got the select, then you followed by the column name, then the aggregate function, and inside the parentheses for the aggregate function, you specify the column you are applying the aggregate function to. Then you select the table name from the from field, and then you apply a group by column. You then group the column by the column name after the aggregate function has been applied. What are aggregate functions? Aggregate functions are basically used to perform calculations on data. Aggregate function mostly returns a single value based on calculations from the columns. So the data returned by an aggregate function is a single value, but calculated from the values in a column. Let's have a quick look at a brief table showing some aggregate functions. So this is a brief table here of some common aggregate functions and their description. So we've got the AVG or average. It's used to return average value. The count returns the number of rows. The max returns the largest value. The mean returns the smallest value. The sum returns the sum. The first and the last returns the first and the last values. So let me show you an illustration of how a group by clause works. So I'm going to use this DVD rental database, and this database has got 15 tables, and I'm going to use one of them to illustrate. The table I'm interested in here is the payment table. So let's take a look at the columns. These are the columns in the table. So you've got the payment ID, customer ID, staff ID, rental ID, amount, and payment date. You don't always have to use an aggregate function with a group by. You can use the group by clause without applying an aggregate function. So I'm going to show you an example where you don't have to use an aggregate function. So let me open up the query tool, and I'm going to pick a few columns from this table here. So I'll start with a select statement. Type in the select keyword, followed by, I'm going to pick the customer ID. Comma, and then I'm going to, actually, I'm just only going to pick one column from now, and then type in the from field. The from will be payment. Then I'm going to apply a group by. I'm going to group it by the customer ID. Underscore ID. So what this query will do, it will get data from the payment table and group the result by the customer ID. So let's run the query so we can see. Ooh, I've got an error there. The reason being, you can see these dotted lines. It means that it doesn't recognize that column. I've got it wrong. It should be customer underscore ID. So let me rectify that. All right, and then semicolon. Now it should work. Ooh, still doesn't work. Okay. Okay, the query has finally worked. For some reason, I got the underscore wrong. Anyway, so this is it. This query here, as I've used it to get the data from the payment table and grouped the result by the customer ID. So this is the kind of thing that an aggregate function will do as well, because when an aggregate function is applied, it will return a single value, as you've seen here, but you don't always have to use the aggregate function with a group by clause, as I have illustrated in this example. I'm going to amend this query and add an aggregate function. The group by clause is always useful when it is used in conjunction with an aggregate function. For example, to get how much a customer has been paid, you can use the group by clause to divide the payment table into groups. For each group, you can calculate the total amount of money by using the sum aggregate function. So let's do that. I'm just going to amend this query. So I'll leave the column as a customer ID, and after the column, I'm going to apply an aggregate function called sum, and I'm going to do the sum on the amount. This table has an amount column, which is this here. This amount column is what I'm applying the aggregate function to. So let me execute this query. Ooh, made some error there. Amount. Okay, it thinks I've got the amount wrong. Yeah, what I should have done is put a comma after the first column here to indicate that I'm adding another column. So let's try again. Okay, that's much better. As you can see, the group by clause sorts the result set by customer ID and also adds up the amount that belongs to the same customer. So whenever the customer ID changes, it adds up the row to the returned result set. You can also use an order by with a group by clause. So what I can do, I can add an order by just at the bottom here. I'll get rid of that semicolon, come here and type in order by, and I'm going to order by the aggregate function and then the amount, and I'm going to do that in descending order. Okay, so watch out for this result output. It should change. I'm going to click on that. As you can see, the format has changed. So by adding the order by clause with the group by clause, it sorts the groups as well. You can also use the group by with the count function. So I'm going to modify this query slightly to use the count function. This payment table here has a staff ID. So what I'm going to do, I'm going to change this customer ID to staff ID. And I'm going to apply a count function. And the column I'm going to apply the aggregate function to is the payment ID. So I'm going to change that and add a payment ID. And I'm going to group the result by the staff ID. And I'll get rid of the order by and put a semicolon to end the statement. So to count the number of transactions each staff has been processing, you group the payments table based on the staff ID, and then you use the count function to get the number of transactions as this query indicates. All right, so let me run that and then we can see the output. So that's it. The group by clause sorts the result set by the staff ID. So it keeps a running total of the rows, and whenever the staff ID changes, it adds the rows to the returned result set. So that's it for this lecture on using the group by clause. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the having clause to eliminate groups of rows that do not satisfy a specified condition. The group by clause is usually used in conjunction with the group by clause. It is used to filter group rows that do not satisfy a specified condition. Let's have a look at the syntax to see how you would implement an having clause. So basically this is how you would implement it, usually after the group by. So you start with the select keyword, followed by the column name, and then the aggregate function you want to use. And inside the parentheses, the aggregate function the column you want to apply the aggregate function to. And then you specify the table name in the from field. And then you apply the group by what column you're grouping it by. And then you apply the having condition. The having condition always comes after the group by. The having clause sets the condition for the group rows created by the group by clause. Although you can use the having clause with the group by clause in conjunction, in Postgres you can use the having clause without the group by clause. So let me show you an illustration of how the having clause is used. Before I do that, I've got a query here I just want to run. Basically this query is just showing the group by clause. So I've got the select keyword. I'm using the customer ID from this payment table here. And I've got the sum aggregate function that I'm applying to this column called amount from the payment table, and I'm grouping it by the customer ID. So let me run that so you can see what it looks like before I add an having clause. So this is what the query looks like at the moment. I'm going to add the having clause in order to implement or set some conditions. So after the ID here, I'm going to take off the semicolon and then implement the having clause. Inside the having clause is where I'm going to specify some conditions. So I'm saying having sum, and I'm going to use the amount column. So this is a condition I've set. So after the group by has been applied using the customer ID, I've set extra condition using the having clause with the sum aggregate function. So it's going to apply to any amount greater than 200. So we should have a much reduced output. So let me run that and you can see the result. You can see we've only, so this, by using the having clause, only conditions that match this criteria have been displayed. You can see this amount here, these two amounts match this, they're greater than 200. So this is an example of how you can use the having clause. Many thanks for watching and bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to truncate and drop a table. Truncate basically means you remove all the data from the table. You strip the table of its data. And drop basically means delete. When you drop a table, you are deleting it or removing it from the database. So truncate removes all the data from a table, while a drop will delete the table from the database. So the syntax you will write to truncate a table will be this. You start with the word truncate, followed by the word table, and then the name of the table. If you were to drop a table, you start with the word drop, followed by the word table, and then the table name. Let's see how this works. I've logged into my PG4 admin tool, and I am going to delete and I'm going to drop and truncate a table from the fruits database, this database here called fruits. And the table I am going to truncate and drop is this table here called person. So I'm going to right click and go to query tool, and that would take me directly to the table. And what I'll start with the word truncate. I'll type in T-R-U-N, truncate, followed by the word table, followed by the name of the table. Name of the table is called person. All right, so before I do that, I want to do a quick select statement so that we can see what data is in there. All right, so I'm just going to highlight this and execute. So we've got two records or two rows of data in this table here. All right, so I'm going to truncate. When I truncate, it should get rid of the data. So I'm highlighting and I execute. It says it's done that. So let me run the select statement again. And the table should be stripped of data. So it has successfully stripped that table of its data. So that's basically what a truncate does. All right, now let's try and drop this table. We want to remove the table from the database. So to remove the table, I'm just going to replace the word truncate with drop. Now, if I execute this, it should delete the table. All right, so if I try and run this query again, if I refresh the table list here, it should change from 3 to 2. It has changed to 2. If I try and run this query again, it will tell me that table does not exist. Error, person does not exist. So that's how you truncate and drop a table. Thanks for watching. Bye for now. Hello and welcome to this section. I'll be introducing you to the PostgreSQL stored procedures. What are stored procedures? Stored procedures are basically a set of SQL statements that can be given a name and stored on the relational database management system as a group, and can be reused whenever it is required. They can also be shared by multiple application or programs. PostgreSQL basically uses stored procedures for developing functions. So they allow you to extend the functionality of the database with user-defined functions. So user-defined functions are also represented as stored procedures. You can use stored procedures to define various types of functions. For example, you can use it to create triggers or custom aggregate functions. Let's take a look at the advantages of using stored procedures in Postgres. The first is basically reduced network traffic. So basically, a stored procedure reduces the number of round trips between application and database servers. So basically, all the SQL statements are wrapped inside functions stored in the PostgreSQL database server. So the application only has to issue a function call to get the result back, instead of sending multiple SQL statements and waiting for the result between each call. It wraps everything and makes the round trips between the application and the database server. It reduces that and therefore reduces the network traffic. It also increases the application performance because user-defined functions basically are pre-compiled and already stored in the database server. So it makes it a lot easier for the application to reference it. Also, stored procedures are reusable. So you can reuse it in many applications or programs. Once you've developed a function, you can reuse it in any application. Once it's created, that's it. You can reuse it anytime. So let's also take a look at some disadvantages. So some disadvantages of using stored procedures include slow software development. So it is slow in software development. This is because it requires specialized skills that many developers do not possess. So there's probably not enough developers with skills to support that in software development. So as a result, that can impact on the software development time. It also makes it difficult to manage versions and also hard to debug. Makes it hard to debug and manage the versions. Another disadvantage is that it may not be portable to other database management systems like MySQL or Microsoft SQL Server and so on. So these are some of the key disadvantages of using stored procedures in PostgreSQL. So in this lecture, I introduced you to PostgreSQL stored procedures, which in a way are basically a bunch or set of SQL statements that are stored in your database. They are also user-defined functions. So they are functions that are defined by the user, and you can use them to create triggers, custom aggregate functions, and other stuff. So the key thing to note is that they are basically user-defined functions that are stored in the database. Many thanks for watching, and bye for now. Hello and welcome to the introduction to this section, which is the Postgres CRUD operations. CRUD basically is an acronym for create, read, update, and delete. A lot of the times, the operations you will perform on a Postgres database will be to create, to read, to update, and to delete. You also obviously need to add records, and you do that with the insert command as well. But CRUD stands for create, read, update, and delete. So we'll be performing these operations in this section. Thanks for watching. Hello and welcome to this lecture. In this lecture, you'll learn how to create a database using the PG4 admin tool. To access the admin tool, you need to go to All Programs if you're on a Windows and locate the Postgres folder. If you expand that, the PGAdmin 4 tool is located inside that folder. So click to launch the tool. Give it a few minutes to launch. When the admin tool loads up, just click to expand the servers and click on the Postgres server. Once you click on that, it will give you an option to log in. So if you can just enter the password that you entered during the installation of the Postgres server. Click OK and it should give you access. It tells you server connected on the bottom right. So now to create a database, we just right click on this databases folder here and click on create and then database. It should give you a dialog box to enter some details. You need to enter the database name. I'm going to call mine fruits. And you can put a comment if you want. I'm just going to say database of fruits. And that's basically it. If you click save, it should create the database. Give it a few minutes. So the database has been created. That's the database here. When you create a database, it jumps to the top. So that's the database we've just created. So click on the plus sign to expand it so you can see more about the database. So these are all the objects that come with the database. This is a schema. If I expand that, it creates it under the public schema. And it also creates other stuff. So these are other objects that are created when you create a new database. So we can check on the properties by clicking on this property icon there to see what the properties are. And this is basically the properties of the database. So when you create a database, by default, there's certain things you enter. Others can be completed for you. Like these here grayed out, there's the security option here. So none of that was completed. The definition was inserted for you. This is the encoding. By default, it gives you this table space. Collation indicates the language you're using. So I'm in the UK, so it's put that there. Template, it says no, I'm not using any template. Allow connections, yes. You can also decide not to allow a connection if you create a database and you just want to use it for testing purposes and you don't want any connection while you are doing some tests. Other things you can check, click on the SQL to see this is the SQL that was actually generated when you create a database. So if I was to create a database using SQL or SQL, this is how I would create it. From the information I provided, it has generated a SQL for the database. So this is the SQL used to create the database. Click on statistics. There shouldn't be that much. So these are various statistics relating to the database. Dependencies, there shouldn't be. Dependents, there's no dependence. So you can also access the property page by right clicking on the database itself and going properties. Once you're in the properties, you can also click on the definition. This was the only information we completed during the creation of the database. The definition part was actually inserted for us by this tool. So all this here, we didn't do it. The tool inserted it for us automatically. And security, if at some point you want to implement security on the database, this is where you implement the security. So you have to be a guarantor to add privileges, and then this is where you grant the users. Parameters, if you've got any parameters, this is where you add it. Default privileges, if there's any, this is where it will be. And the SQL here tells you nothing has changed from the SQL that was used to generate, or the SQL that was generated when the database was created. So that's basically how you create a database using the PGAdmin4 tool. Many thanks and bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to create a table using PG4admin. Open up your PGAdmin4 tool. I've already opened mine and I'm already logged into the server. So to create a table, there must be a database already in present. So you create a table inside a database. So the database I'm going to create a table on is this database called fruits. We created this database earlier. So I'm just going to expand this database and look for the schema. This is a schema. Inside the schema, which is called public, there are tables. Although there's no tables at the moment, but this is where you create tables from. So to create a table, you right click on tables, which is under this fruits database, and click on create and then table. And it should give you an option to enter the table name. So I'm going to call my table oranges. And it tells you the owner is Postgres. The schema is public. You can select a table space if you want. Once you've done, just click save and it should create the table name. So you can see here, that's the table oranges. We've now created a table. So we can go back to the table, right click and go properties, and we can add more bits to the table. We can add columns. So to add columns, we click on that. And before we do that, let me click on the general tab. You can see it's created it in the default PD_default table space. So let's go to columns and let's start adding the tables, the columns. It gives you option to, you can inherit from tables. If you've got other tables, you can inherit columns from tables. Gives you that option, but I'm not going to do that. I'm going to create new columns. So click on this plus sign here to create a column. So with tables, they store data in columns and rows. So I'm going to call this category ID, and I'm going to select the data type, which it has to be an integer because it's going to be a number. So I'll select integer, leave this to blank, and I'll select, do I want it to accept null value? No, I want there to be a value, so I say yes. Do I want to make it a primary key? Yes, I want it to be the primary key. So this column here, all the records in this column will be unique. So that is the first column. So I click to save it, and I can add more columns. I go back, go into properties, I wait for it to load, and then I go to columns again, and I click on the plus sign, give me another row. So at this time I'm going to add the name, and I'm going to make the character varying character. So I'll type in character varying, so it'll be a varying character. You can give it a length. I'm going to give it 25 for the name. I don't expect there will be any fruit that will have more than 25 characters of name. Again, I want there to be a name. I don't want that value to be empty, so I say yes. I want it to be a null value. I don't want any null value. Null means there is no, you don't know. So, you know, but by making this yes is forcing you to enter a name for the category. So I click save. I'm going to add one more. I go right click again, I go properties, wait for it to load, and I'm go columns, and click on the plus sign. I'm going to make this color. So I want to find out the color of the fruits. Again, I'll make this varying, character varying. I'll make it 25 as well. I'll leave this. So this can be empty if you're not sure what color the fruit is. So I don't want to enforce that. So I leave that option open. So if people are not sure what color it is, I want that left blank or null. I'll click save. So we've now created a table with 3 columns. If I expand this, you can see the columns of the table. So these are the columns. It tells you here 3 column. There are other things you can apply to the table. If I go on the properties, for example, you can you can apply constraints. You notice because I've added a primary key to one of the table, it's made that a constraint. Constraint basically, in a way, is kind of like a check. It forces you. It means you can't progress unless you enter something in that field. Okay, so there are other options here: advanced parameters, security. You can add security to a table, so you can give access or restrict access. If you want to do that, this is the area you will be doing that. And the SQL basically tells you nothing has changed since the table was created. So if you want to see the SQL that was used to create the table, all you need to do, let me cancel out of this. I click save. So if you want to see the SQL or the SQL, you right click on the name of the table, and where it's got scripts, just click on create, and that would generate a script with the create command. So there you go. So this is a script that you would use if you were to create it without that is not with the table, not from within the admin tool. So this basically is the SQL or the script this script was generated when you created the table. So if I wasn't going to use the admin tool, I wanted to use SQL or SQL, this would be the SQL I would use to create the table. So that's it for this lecture on creating a table using the PG4 admin tool. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the Postgres create table statement to create a table in a database. Let's take a look at a typical syntax to create a table. So this is what a typical syntax looks like to create a table. You begin with the create table command, followed by the name of the table, and then in between the parentheses you specify the names of the columns the table will contain. A table can have as many columns as you wish to specify. So once you specify the name of the table, you then begin to define or specify the names of the column. So you start with a column name, followed by the data type, if it's going to be an integer, which is a number, or a text. And there are different types of textual data type. So you need to insert that. And then if you want a constraint on the column, you also need to add that. A constraint basically is a condition that you apply to a column. For example, you can add to a column that you don't want that column to be empty. There must be a value. That is a kind of constraint. So let's go over to our PG4 admin editor and create a table. I have already logged into the PG4 admin tool. So I'm just going to expand the list of databases. When you create a table, you need to create it in the correct database and schema. So I've got 3 databases listed here. The database I want to create a table on is this one here called fruits. So I'm going to expand that and then expand the schema, and you should see one for tables. There's only one table there. So what I need to do, I need to access the query editor. So I right click and go query tool. You can also access the query tool from the tools option and click on query tool. So I have now got my query tool open. So this is where I'm going to define my table. As you can see here in the editor, it says fruits on Postgres. So it knows that I'm in the fruits database, which is this database here. So that's where I'm creating the table in. So I'll start with the create table command. Followed by the name I want to call the table. I'll call it berries, and then I have to enclose parentheses, and then I put my mouse in between the parentheses and expand it. So in between this parentheses is where I'll define the columns for the table. So the first column I'm going to define is going to be the ID. So I'm going to type in berry underscore ID. I'm going to make that the primary key. A primary key basically is a column or a group of columns that is used to identify a row that is unique in a table. If you are adding more columns, you put a comma at the end of the first column, and then you tab to the next line and then add another column. So I'm going to type in berry underscore name. Again, I need to specify the data type this time. It's going to be a voucher data type that will accept, that can allow 255 characters. And I'm going to set a constraint. A constraint basically means that you are applying some kind of restriction or a rule to that column. What not means that there must be a value in this column. That is, it cannot be empty. For illustration purposes, I'm just going to leave it with 2 columns. But you know, you get the idea. You can add as many columns as you wish to in a table, but for this table I'm just going to make it really simple and just leave it at 2 column. So I want it to be a 2 column table for now. Once you're done, you need to put a semicolon at the end to indicate that you are done with creating the table. You can always add columns later when the table has been created. Once you're done, you can now execute the query to create the table by clicking on this here. So once you've executed, it tells you that query returned successful. So successfully created the table. It tells you the command you used. Notice that I've added a data type. You must always have a data type when you're creating a column, so that the column knows what type of data to expect. So here, after the name of the column, you need to add the data type. This is an ID column, which is going to be an integer, which is a number. So this int means integer. So that's the data type for this column. So basically, this is a simple format that you can use to create a table. You can make it as simple as this one or as complex, whereby you can also add a constraint to several columns within a table, and you can also add constraint to the table itself. So let's quickly query this table that we've just created to see if we can communicate with it. So I'm going to quickly write a select statement. I'll do select star from berries. It's very important to always just check what you've done, just to make sure everything checks out. Okay, so I'm highlighting that and I click. So you can see it's successful. It tells you we've got 2 columns in this table, tells you the data type, but there is no data inside the table. So we've got the table structure all in place, waiting for data input. Thank you for watching, and I hope the lecture has been useful. So this is how you create a table using Postgres create table command. Thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I'll be introducing you to Postgres select statement. One of the most common tasks you will perform when working with Postgres is the task of querying data from tables, and you do that by using a select statement. So the select statement is basically used to query data from a table. The select statement can be very basic, or you can make it complex by combining it with several clauses. So you can use it in combination with other clauses to make the select statement more complex and powerful. There are several ways you can build a select statement, but let's have a look at the basic syntax you can use. A syntax basically refers to how something is written. So for a very basic syntax or a very basic select statement, you can specify the column. For example, a table stores data in columns and rows, just like in an Excel spreadsheet. If you wanted to query data from a table, you have an option. Rather than query all the data, you may want specific data to query. So you can do that by selecting the columns individually and specifying the table where the data is coming from. And the way you will write that statement is this. You do a select, which is a select keyword. Select indicates you are trying to retrieve data. Select doesn't cause any damage to the database. There's no risk because all you're trying to do is read data. So you start with the keyword select, followed by the columns you want to retrieve data from. Say you have a table that has maybe 20 columns and you only want to retrieve data for 2 columns. Rather than retrieve everything and then sift through what you want, you can specify the actual columns you want to retrieve data from. This also helps save network traffic. Rather than pulling all the data from a table, you only pull down the specific data you need. So you assume you want to retrieve data from column 1 and column 2 from a table that has 20 columns. So you just specify column 1 and then you separate each column by a comma. Okay, so I want to retrieve data from column 1, comma, and then column 2. You don't need to put a comma at the last column because there's only 2. If you were to add another column, then yes, you put a column after the 2, but not with the last column. And then you need the from. The from is very important because the query needs to know where it's pulling that data from. So the from is used to specify the name of the table. The other way you can write a select statement is if you wanted to retrieve all the data from a table. So you want all the columns and all the rows. You don't want to be specific. You just want to get everything out of that table. The way you specify that statement is this. You do a select keyword followed by the asterisk symbol. That asterisk symbols indicates that you want to retrieve all the data from all the columns and all the rows. You also have to specify a from field, which indicates the name of the table the data is coming from. So these are the two basic ways you can write a select statement. These are just basic. You can obviously make it more complex by adding other clauses to it. But at the very basic, this is what a select statement looks like. This is how you would write it. You can also obviously make the select statement more complex by adding things, other keywords or clauses to make the query more complex. But in a very basic select statement, this is how you would specify it. So that is it for this lecture. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn to use subquery to build complex SQL queries. A subquery basically is a query nested inside another query, and this can be with a select statement, an update statement, and also an insert statement. To construct a subquery, the second query is placed inside brackets, and also you have the where clause used as an expression in the subquery. So a subquery basically is an SQL statement that has another SQL statement embedded in the where or in the having clause. So let's look at a typical syntax. This is what the syntax will look like. So this portion here where you've got the brackets, that's this bracket here and this one here in between, this is known as the inner query. So this here is the embedded query. It is known as the inner query, while this portion here, this part of the query here, is known as the outer query. So I've changed the color to make it more pronounced. So the part in yellow here is known as the outer query, while the query in green, which has brackets around it, is known as the inner query. All right, let's start with a very simple example. So I've got a simple query here where I'm selecting the rental rate from this film. This is the film table, and this is the column I'm selecting, and I'm applying a AVG, which is an aggregate function, to this column here called rental rate, which is this column there. So suppose we want to find the films whose rental rate is higher than the average rental rate. So we can do this in two steps. First, we find the average rental rate by using the select statement and the average function, which I've specified here. The second step is to use the result from the first query in the second select statement to find the films that we want. So let's execute this so we can see the result. All right, so let me just expand that a bit. So this is the result from this query. So approximately is 2.98. So which means the average rental rate is 2.98. Now we can get the films whose rental rate is higher than the average rental rate. So I've implemented this query here. This query you can see to find the films whose rental rate is higher than the average rental rate. You can see here I've used the greater than sign. So I've said select the film ID, title, and rental rate from this film table where the rental rate is higher than 2.98. 2.98 was the average we found. So let me run this so we can see what it outputs. So this is the output from this query. You can see these are the rental rates. The way the code is implemented at the moment is not that elegant. So what we can do, we can make it elegant in 2 steps, and we'll do that by implementing a sub query. So what we want to do, we want a way to pass the result of the first query to the second query in one query using a sub query. So I've modified the query here to make it look more elegant, and if implemented a subquery. So a subquery basically is a query nested inside another query. So what I've done here, I've started with a select statement and picked out the columns from the film table, and in the where clause I have applied some conditions. So I've said where the rental rate is greater. Okay, so it will output this result first and use that result of this first query and use it for the second query. So where rental rate is greater, and then this is where the second query starts from. So this is select, and I've applied an AVG to the rental rate from the film. So the second query is nested inside the first. You can see the brackets, that's the opening brackets, and that's the closing brackets. So the query inside the bracket is what is called a subquery or an inner query. The query that contains the subquery is known as the outer query. Postgres executes the query that contains a subquery in the following sequence. First, it executes the subquery, okay, which is this query here. Second, it gets the results and then pass it to the outer query. Third, it executes the outer query. So the format in which Postgres executes, first of all, it will execute the sub query, all right, which is the inner query, the query that contains the query in the brackets. This is the bracket here. So this query here is what is known as the sub query or inner query, while this here is known as the outer query. That is the query that contains the sub query. So when the code executes, it will execute the sub query first, which is this query, and once that query is executed, it will use the result from this query and pass it on to this outer query here. And the third, then the outer query uses that result and executes it. So let me execute so you can see. All right, so this is what the output looks like. A subquery can also return 0 or more rows. So this is just a simple illustration of how to implement a subquery. You can also use other operators when you are implementing subqueries. For example, you can use the subquery with an in operator and also with an exist operator. Many thanks for watching. I hope it has been useful. Please do let me know if you have any questions. Thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the Postgres update statement to update existing data in a table. Let's have a look at a typical syntax. So this is what the syntax will look like to update data in a table. So you start with the update keyword, followed by the name of the table. Then you use the set keyword. This set is important because this is what activates the change. So you type in the word set, followed by the column name you're trying to make the change on. Then you use the equals to sign. This equals to basically is what you use to change the value. So after the column name, you set the new value. If you're changing more than one column, then you separate the first column with a comma, and then you do the same for the second column. If you're adding more than two columns, again a comma, and so on. And then you specify a where condition. The where is important. The where acts as a filter to prevent you from updating any other records in the table. So the condition you specify in the where clause is important because that enables that only the columns that match the condition in the where clause will be updated. So let's see how this works. I've logged into the PG4 admin, and the database I'm going to use to illustrate is a database called Fruits, and it's inside the public schema. And the table I'm going to update is this table here called berries. So I'm going to right click on the berries table. One advantage of using this PG4 tool, it makes things a lot easier for you. So rather than me writing the script from scratch, I can just go here where it says script and select update, and it will begin writing some of these scripts for me. All I need to do is just make some modifications. So basically this is what it's done. It's saying this is the update statement. The public refers to the schema. Berries refers to the name of the table. So this is what I'm doing, is asking me what am I changing. So set here is what I need to specify what data I'm changing. So this indicates the name of the column. So I am going to, before you make any modification to a table, it's always best to see what the table contains first. So I'm going to do a quick select statement. Do a select star from berries. Where you've got more than one statement in the editor, it's best to highlight what you're trying to execute so that the editor doesn't get confused. That's one of the reasons you should always have a semicolon after each statement. Notice I have an error and the editor puts a dot where he thinks I've got the error. That's because I've got the name of my table wrong. So I've got a missed out an extra R. So I just type that in and I'll run the query again. All right, so this is the content of the table I'm trying to make some updates on. And when you are making update, the process is the same, whether you're making updates to one or several columns in a table. All right, say I want to make some modification to this here called strawberries. I want to change the name of the strawberry. I want to add some extra text. I just want to add strawberries and then followed by the word UK, just to indicate that the strawberries come from UK. So the way I would do that is in the set area, I will get rid of the ID because I'm not changing the ID. What I'm changing is the name. Okay, so I'm going to say set berry name. That's the name of this column. I'm going to set it, and then I need an equals to sign to indicate the new value I'm going to give it. I'm going to call it strawberries UK. So I've added the word UK next to the strawberries. If I was to do that if I didn't include this where clause here, what that will do, it will update all the strawberry, everything here will update this to strawberries UK, that to strawberries UK, and this to strawberries UK. The where clause prevents that happening. This is very important because if you're in a production environment and you have thousands of records, if you don't include the where condition, it will just update everything, and that could be disastrous. So the where clause is very important. So I've used the set keyword to indicate where I want to make the change. So I'm changing the berry name, which is this here, to strawberries UK. In the where condition is where I need to attach the condition. So I will now say where berry underscore ID is equals to 1. So what that means, it will only change or update the records where this condition is true. You can see here the berry ID here is 1. So that means if I run this script, it will not affect the other records. So let's give that a go. I just select that and click on this to execute. If all goes well, it tells you query returned successfully. If I run this select statement again, you'll notice the change has been made. You can see now it's now updated this to strawberries UK. So that's how you perform an update statement on a table. The process is the same whether you are updating one record or 1,000 records. The key thing to take away here, you must not forget to include the where clause. If you don't include the where clause in an update, the update applies to the entire column in the table. So it's very important you use the where clause to prevent errors from happening or to prevent disastrous situations. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the Postgres delete statement to delete rows of a table. So if you wanted to remove a record or a row from a table, you need to use the delete command or statement to achieve that. Let's have a look at a typical syntax for a delete statement. So this is how you would structure a statement. You start with the keyword delete, and then you use the from to indicate the name of the table, and then you add a filter with the where condition. When you're deleting records or rows from a table, if you don't use the where condition or where filter, it will wipe out everything from that table. So it's very important to use the where clause to act as a filter to protect other records in the table. So let's have a look at how we'll implement this. I have logged into my pgadmin 4 tool, and the database I'm going to use to illustrate is the fruits database. This database here, and the table is in the public schema, and the table I'm going to use is this table here called berries. So to make things a lot easier, I'm going to use the built-in script in this pgadmin to save me time. So I'm going to right click and go script. So different kind of scripts you can use here. I'm just going to say I want to delete, and it will write a delete script for me. All I need to do is make some modifications to that script. So basically it starts with the keyword delete, and then from the schema, and then the table name. This is where you specify the condition. Before you perform a delete, it's always best sometimes to check this table, what's in the table first. So I'll do select star from berries. I'm just going to highlight that and click execute so I can see the data in the table before I make any deletion. So let's say I want to delete this record here called Strawberries UK. The way I will achieve that is in the where condition. I just come here. When you're deleting, make sure you've got the right table. By using the script option from the pgadmin, it just makes things a lot easier for you. Although you can also manually write that, it just saves you time. So I'm deleting from the berries table, which belongs to the public schema. So I'm deleting where is where I specify the condition. So when you delete, you actually delete a record. A line, all these are all records. So I'm deleting where the berry underscore ID is equals to 1. That is basically the condition. If I didn't have this where clause and I just say delete from public berries, it can wipe out all the records from the table. So you can imagine if he had millions of records or thousands, he'll wipe them out. So the where clause is very important. What that means, it will only delete records that matches this criteria where the berry ID, berry underscore ID is 1. So let's run that and we can see what it does. Execute. Tells me it's returned, so it's done the job. So if I run this again, there shouldn't be any record for strawberry. All right, so you can see it has record 1 no longer exists, where you've got berry underscore ID 1. It has removed that record from the table. So the process is the same, whether you're deleting 1 record or you're deleting 1,000 records. The key thing to take away here is that you must always use the where clause. If you do not use the where clause when you're deleting, it can cause catastrophic issues by removing records you didn't intend to remove. Very important to specify the where clause in your delete statement. That's it. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to insert new rows into a database table using the insert command. Sometimes when you create a new table in a database, it is bare, it doesn't have any data. In order to add data, you need to use the Postgres insert statement to insert data or rows of data into the table. A typical syntax to insert data or rows into a table is like this. You begin with the insert into clause, followed by the name of the table, and then in parentheses you specify the column names. If the table has got 2 columns, you specify the 2 columns, and then you add the values. The values basically is where you specify the data you're trying to insert, and the values must match the column and also in the order. So these are the columns you want to insert data or row into. You specify that first, and then in the values you have to separate each of the values by a comma. The value list must be in the same order as the column list specified after the table name, which is this one. So if I've got column 1, which is an integer, column 2, which is a string, in the value list it must correspond or must match, must be in the same order. I can't have a data type here of integer, and then here I have a data type of string. It will not work. So the format, the column names, and the values you enter must match. If this is an integer, the value I'm entering here must reflect that, and so on. When you're inserting or adding rows to a table, you can add one row at a time, or you can insert multiple values. So let's see how this works. So I've logged into my PG4 admin tool. I'm going to expand the databases. I've got 3 databases here. The database I'm going to use is the fruits database. And if I go to the schema here, within the schema, I've got a public schema, and then I've got the tables. This database has got 2 tables, oranges and berries. So I want to insert some rows, some data into the berries table. So what I can do, I'll right click where it's got berries, and then I'll click on the query tool. Okay, I can either do that, or if I want to save time, I can go to scripts and click on insert script. So that will add some of the script for me. All I need to do is make some modifications. So by doing it by the script option, it saves me a bit of time. So it has kindly done the insert for me, so I don't need to add that again. It's also added the public, which is the name of the schema, and then it's added the name of the table, which is berries. So the dot separates the table name from the schema name, and you can see the parentheses here. That's the opening parenthesis, and this is the closing parenthesis. And you see it's identified the name of my columns. Berry underscore ID is put that in there for me, and berry underscore name is put that in for me. It can't do the values because it doesn't know what values I'm trying to add. So you notice that each of the values has been separated by a comma. So all I need to do, I know that berry ID is an integer, so it must take a number. So I'll put number 1 there. If I put anything other than a number, it will not work because I'm trying to enter the wrong data type into a column that does not accept a non-integer data type. And in here, if I do the same, if I enter an integer, it will complain. So what I need to do is enter the correct data type. So I'm going to type in strawberry. And do that. Because it's a string, I need to enclose the values in quotes, and then you end that with a semicolon. Now let me execute, and hopefully it should insert the record. If I click on this here, the execute option, and we should see it says query returned successful. So query returned, so it has inserted. So let's quickly check by typing in a quick select statement. So I do select star from berries. Berries is the name of the table, and I execute. Ooh, doesn't like it. Error, duplicate key. All right, that's worked. The reason I had an error is that because I didn't select this and I was trying to run the query, what it's trying to do was trying to run both queries. It was trying to run this and it was trying to run this. So it was erroring because it thinks I'm trying to add the same data I've already added. So when you have multiple scripts in the editor, and you want to execute only a particular one, it's probably best to just highlight that one so the editor doesn't get confused. So as you can see now, I've got a record in our table called berries. That's the ID, That's the name. In some databases, you can set the primary key, or this column here, an ID column. You can set that to auto increase. What that means that you can set up what is known as a sequence. So each time you add a record, it automatically, increases. You don't have to manually add this column. It will auto increase for you. All right, we've learned how to insert a single record, which is what I've done here. So now we're going to insert multiple records. So again, the query is the same. The only difference here is that I've added this to, I'm inserting multiple records. So the values has to match the columns. So I've got berry ID, which is an integer column. So this is the values for that. So I add the berry ID will be this, and the berry name will be that. The second value will be 3, and this will be blueberry. I just need to change the name. I didn't change that. I just changed that to blackberries, and I'll change this to raspberries. Okay, so now if I execute this, I just highlight it. It should insert 3 extra records. Tells you there. Okay, so now I've got 3 extra records inserted. I come here, I run this select statement, I highlight it and click. You can see these are all the records. Now you can see this 1, 2, 3, 4. So that's how you insert records or data into a table. Notice that in production live databases, where you have an integer column, normally that is auto populated with a sequence. So you don't necessarily have to manually add this column here. You just add a sequence, and the sequence will auto insert the next value for you. So that is it for this lecture on inserting records into a table. Thanks for watching, and bye for now. Hello and welcome to this lecture. Postgres uses comparison operators to test for equality and inequality. So in this lecture, I am going to explain some of the comparison operators that Postgres uses. So here is a table of some of the common comparison operators used in Postgres. We'll start with the very common one, which is the equals to. This here basically is used to set, if you want to check if a value is equals to something, you'll be using the equals to sign. So you're checking the condition if something matches something or is equals to something. If you want to check if something is not equals to, if a value does not match or is not equal to, if you want to check that condition, you use the not equals to sign, which is this. There are two you can use. You can either use this one, which is which looks like an angle bracket. You use this, or you can use this one here. So either of these two symbols will achieve the same purpose for the not equals to. If you want to check if a condition, if something is greater than something, you use this. This is the greater than sign. If you want to check if something is greater than or equals to, you use this sign. This is greater than or equals to. If you need to check for a value that is less than, you use this. This is less than symbol. And if you want to check something less than or equals to, you use this. All right. The way I tend to remember this, if you use your left hand basically you represent less than, and for greater than you use your right hand. That's how I tend to remember them. So this here means less than or equals to. If you want to check if a value is less than or equals to, you use this symbol here. The in operator basically is used to match a value in a list. It usually is placed in between parentheses. So if you want to search for certain criteria in a list to match, you use the in operator. You use the between operator to check for a range of value. If you want to check for a range of value to check a criteria, you'll be using the between, and you specify the range, and the data or whatever you're looking for will match the value specified in that range. You can also use a like operator. Usually a like operator is used to match pattern in a column, and you use that in combination with two wildcards, the percent and the underscore. I'm just going to quickly show you a couple of examples using the comparison operators. I'm going to use our sample database, which is a DVD rental database, and I'm going to use a table or a couple of tables from this database. So these are the tables. The database has 15 tables. So I'm going to expand this table here. And the first table I'm going to use is the payment table, this table here. So let me right click on the table and select the query tool and quickly write a quick query to illustrate one of the comparison operators. This table has 6 columns. I'm going to just use all the columns rather than select specifics. So I'm going to do a select star from, and then I specify the name of the table, which is payment. Before I use any comparison operator, I just want to run this query so you can see before and after. So if I execute that, keep an eye on the bottom right here. It says 14,000, over 14,000 rows retrieved. Now I'm going to use a comparison operator inside the where clause, and that should limit the amount of records returned. So I'm going to add a where clause here as a filter, and I'm going to say where, so only records that matches the conditions in the where clause will be returned. So I'm not expecting 14,000 records to be returned. So I'm going to say where the amount, which is this column here, is greater than 999. So I'm using a comparison operator here, which is the greater than sign. So I'm saying that only one records return that matches this condition. So only where the amount is greater than 999. So I don't expect 14,000. So let me run that, and you should see a much reduced. You can see 107. It has matched the criteria I have set using the greater than sign. So you can see here, all the amounts here are above 999 because that's what I've specified. Only those that matches this amount will be returned. Although I've used the greater than sign, this is applicable to the less than, greater than or equals to, and other operators. All right, let's do one more example. I'm going to pick a different table this time. I'm going to, let's see, I'm going to pick this table here called city. It has 4 columns. So let's do a quick select on that. I'm going to do a select star from city. And let me just run that and see what we get. So we have 600 records returned for that table. So I want to reduce that. So I'm going to apply a filter. So it won't be reduced by much. So what I'm going to do, I am going to get rid of the semicolon there and add a filter. So I'm going to say where. So I'm going to say where city, this city here, this column called city, where city, I'm going to go for this one here called York. All right, so what this query will do, it will return everything apart from York. So if I run this query again, you will not see an entry for York because it will be excluded. What this symbol is, it means not or not equals to. That means return everything apart from this, where the city name is not York. So let's run that. We can see what happens. All right, so it's returned everything. It used to be 600 records, so you can see it's now showing 599, which means it has excluded York. So normally you would have seen the York now, but there is nothing, no entry for York. So that's basically how you use some of these operators. So you can, instead of using this, you can use the exclamation, and that means the same thing as that. It means not equals to. So if I look out for Abu Dhabi, if I change that to Abu Dhabi, Abu Dhabi, notice the entry here, number 3, Abu Dhabi. If I run this, I expect this query to exclude Abu Dhabi. As you can see, Abu Dhabi was number 3. You can see number 3 is being excluded from the query output. So that's basically how you use some of these comparison operators. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I will show you how to use the Postgres between operator. The between operator basically is used to match a value against a range of values. The values it can match includes numbers, text, or dates. The between operator is usually included or defined within the where clause of the select statement. So this is how the syntax looks if you need to include the between operator inside your select statement. So once you've defined the select statement, you can either specify column names or you can use an asterisk. By using asterisk, that means it will retrieve all the column names. Then you specify the table name from the from field, and inside the where clause you specify the name of the column, and then you add the between operator followed by the values you want to check against. So you specify the values you want to match inside a range of values, and the data will be returned by the query. So let's go over to our pgadmin tool and see how this works. So I have logged into my pgadmin 4 tool, and the table I'm going to illustrate the between operator with is going to be the payment table. And this payment table here belongs to the DVD rental database, which is this database here. So I'm going to use the payment table. Before I do that, I just want to expand the table so we can take a look at the columns within the table. So I click on the plus sign and it should reveal. So these are all the columns in the table. It's got 1, 2, 3, 4, 5, 6 columns. So what I want to achieve here, I want to use the between operator to query some data. So let's open up a query tool, right click on the payment table and go query tool, and that should launch the tool. When writing select statements, it's best to avoid using the asterisk if you can. If you don't need all the data from the table, it's best not to use the asterisk, because retrieving all the data, if it's a table that's got lots of data, retrieving that data over the network each time can slow down or can impact on the network traffic. So as much as possible, if you know the columns you need to retrieve data from, it's best to specify them rather than use the asterisk to get all the data from all the columns. So in this table here, I want to only pick a few columns here. So I'm going to select the customer ID here, customer underscore ID. I'm going to select the payment underscore ID, and I'm going to select the amount. So let me define or build a query. I do a select followed by the name of the first column, which is customer underscore ID, and you separate each of the columns from each other with a comma. And the next the next column I want is the payment ID column, which is this column here. So it's payment underscore ID, and then a comma, and I'll select the other column, which is this amount column. Next, I specify the table the data is coming from. The name of the table is called payment. So I'll type in payment. The next line is where I will specify the where clause. Inside the where clause is where I will specify the criteria or the between operator. Actually, before I do that, I'm just going to comment out this. So I'm going to comment out this where clause for now. I just want to show you something quickly. I want to execute this query as it is, so that you can see, it says I've made an error. Okay, I had an error because I didn't comment out the where clause properly. So I've commented it out now. So you can see here that this is the data that has been returned. I have not applied any filters or used any operators here. So I just wanted you to see what the data looks like before and after I apply a filter. So these are all the rows. So let me execute that again so you can see the number of rows. So if we look at here, it tells you 1,400. This is the row 14596 row. Okay, over 14,000 rows returned. So I don't want all that. I want to filter that out. So this is where I'm going to use the between operator. And the column I am going to use is this amount column here. So you can see there are different amounts here, $7.99 in dollars, different various amounts. So I'm going to filter based on this. I'm going to set a range using the between operator based on this column here called amount. I just wanted to show you that first before including the between operator inside the where clause. So now I can remove the comment and now add the where clause. So I just need to get rid of that asterisk. So inside the where clause now is where I will include the column name, which is amount, which is this column here. And then I'll add the between operator. Notice the color has changed because it's a keyword. So then I specify the value. So I want a value between, say, 7 and 8. Notice the and is the color has changed as well because it's also a keyword. All right. Previously, when I executed this query without the where clause and without the between operator, I had over 14,000 records returned. Now that I've applied a filter with the where clause and added a range of data to return, so I've said where the amount, which is this column here, is between 7 and 8. So it will only return data that matches this criteria. So I don't expect to get 14,000 records returned. So let me execute. I'll click on that and we should see it tells me 626 rows retrieved. So that is much smaller than the previous record where I did not apply a filter or a between operator. So you can see these are the conditions here specified in the where clause using the between. So between is used to check against a range of values. So you can see here I've specified the amount between 7 and 8. So it's only return data that matches a range of 7 and 8. So if you look through the data, you would not see anything other than between 7 and 8. So you can see that all the data that's returned is within that range, 7 and 8. So that's how you use the between operator to also filter data from a table. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'm going to show you how to use the not between operator inside your select statement. It basically works like the between operator, but in the opposite direction. So basically it is used to return values not within a range that you have specified. Like the between operators, the values can be numbers, it can be text, or it can be dates. Also, it's usually included in the where clause. So let's have a look at the syntax, which shows you how to specify the not between operator. So basically, the not between operator will only return values not specified within the range of values you have defined, and it is defined inside the where clause. So let's go to our PG admin tool and have a look at how this works. So I'm going to use the payment table here. This payment table belongs to the DVD rental database. So I'm going to quickly run a query on this table so I can illustrate how the not between operator works. So let me expand the table so you can see the columns. These are all the columns within the table. So I'm going to right click on the table and click on the query tool to launch the query tool. And once the query tool is open, I'm just going to write a few statements. I'm going to select specific columns rather than use all the columns. So let me begin by typing in a select statement. So I'll start with the select keyword, followed by the columns I want to use. I want to use the customer ID column, the payment ID column, and the amount column. So I'll select the customer first, customer underscore ID, comma, and then the next will be the payment underscore ID. And I put comma, and then add the next column, which is the amount ID, amount column. So I've now got three columns: customer ID, payment ID, and amount. So you can add these columns on separate lines if you want, but I like doing it this way to make my query shorter. All right, so now I'll specify where the data is coming from. I need to indicate the table. Name of the table is called payment. Next. All right, what I want to do before I apply the where clause and the not between operator, I want to just run this query as it is so we can see. Look out on the bottom right hand corner. It will show you the amount of records returned without the where clause or the not between operator. So let me execute that. If you look here on the right, it should show. It tells you, see that 14,596 rows returned. All right, of over 14,000. So I want to reduce that amount. So to do that, I'm going to apply the where clause here. I'm going to type in where, and I'm going to use this amount column to do the filtering. Where amount, which is this column here, these values are all in dollars. So I'm going to say where the amount, and I'm going to attach the not, where the amount is not between, I'm going to specify 0 and 8. So that is a lot. So I don't expect the records to return for 14,000 or more. So I expect it to be much less because it's only going to return values that does not match these values here. So it will exclude anything between 0 and 8. So let me execute and look at here. It says 780 rows. That's much more lower than 14,000. So I've used the not between operator to exclude data to be returned by the query. All right, so that's how you use the not between operator. You can use that to exclude a range of data that the select statement or query returns. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I will introduce you to the like operator. The like operator basically is used to match pattern in a column. It is used to query data by using pattern matching technique. It is used with the where clause to search and match specified patterns in a column. It is also used in combination with wildcards, and the two common wildcards that are used with the like operator are the percent wildcard that allows you to match string of any length or characters including 0. So when you are using the percent in combination with the like operator, the percent sign actually represents 0, 1 or more multiple characters. So that percent can represent a 0, 1 or multiple characters including 0. The other wildcard that is used with the like operator is the underscore. The underscore actually is used to match a single character. It represents a single character. Just to recap, the like operator is used in the where clause to search for a specified pattern in a column. Let's take a look at the syntax. Syntax represents how you would structure a like operator with your queries. So this is a simple syntax whereby you select your column names if you're choosing columns. If not, you can use all the column by using an asterisk. You specify the table name, and then inside the where clause is where you, after the column, you specify the like pattern, the pattern you are trying to match. The best way to show you this is to actually see it in action. So I'm going to head over to my PG admin tool and experiment with one of the tables in our sample database. I have logged into my PG Admin 4 and I'm going to use the DVD rental sample database. This database here, and it has 15 tables. I'm just going to expand and look for the table I'm going to use. I'm going to use the customer table here. Let me expand that so you can see the columns in the table. So these are all the columns. It's got 10 columns inside the customers tables. Suppose the manager of a store asks you to find a customer that he does not remember the name exactly. He just remembers that the customer's first name begins with something like a J or Jen. How do you find the exact customer that the store manager is asking for? You may find the customer in the customer table by looking at the first name column to see if there's any value that begins with Jen. Again, this can be tedious, and depending on how large the data in the table is, it can be time consuming. The best way to search for that kind of information is to use the like operator. So let's open up the query editor, right click on the table name and click query tool to launch the query window. Once the query window launches, we can begin writing our queries. Give it a few minutes. All right, we're not going to use all the columns from the table. Remember, the query is basically to find a customer whose name begins with Jen, Jen. That's all the store manager can remember. Not quite sure the full name. Just all he remembers is that it begins with a Jen, Jen. So what I'm going to do is select, and I'm going to pick the first name column, a comma, followed by the last name column. And when you are specifying columns, make sure you specify the way they've been defined in the table. As you can see, my first name matches the first name here, last name matches the last name there. Next thing I need is specify the name of the table. It's called customer. And then next thing I need to do is specify the where clause. And inside the where clause, this is where I apply the condition. I specify the column first where I'm trying to search for the pattern. So it's going to be the first name, because all the manager remembers that the first name begins with something like Jen. So I'm going to specify the first name column, and then I'll introduce the like operator. I'll say like, because it's a string, I need to enclose it in quotes. And then insert a wildcard, a percentage wildcard. Actually, the percentage has to come before the ending quote. So this is how you would structure that. When you're searching for a pattern in a column, if you're searching for a pattern that begins with something, the percentage is placed at the end here of the pattern you're trying to search for. If you are searching for a pattern that ends in something, the percentage will be in front of the character pattern you're trying to search for. Because I'm searching for a first name that starts or looks like Jen, the percentage is placed at the end of the character I'm searching for. So let's give that a go and see what we get. So I'm going to click on this here to execute the query. And as you can see, we've got 3 rows from that table. And as you can see, they all begin with Jen. We've got Jennifer, we've got Jenny, and we've got Jenny. So from this data, the manager should be able to spot the customer he was trying to look for. So that's basically how you use a like operator. So you can use that to search for different types of pattern as well. If, for example, you wanted to search for someone whose first name, begins with A, again, you can change that from Jen to A, and it will search for everyone whose name begins with A. There you go. See, it searches, that's the pattern. And this is everyone whose name begins with A. Okay, so you can change that. If I move the percentage from the beginning to the end, from the end here to the front, what this is saying is that search the pattern for anyone whose first name ends with the letter A. So let me search that. So this will be searching for anyone. Oh, there's no one whose first name ends with the letter A. How about B? Let's try B. No one with a B. Okay, let's try lowercase a. Oh, yep. Okay, we've got a lowercase a. So these are people whose names end with the lowercase a. So I just wanted to give you an idea of how the like operator works in combination with a wildcard. You can also use the like operator with the underscore. When you use it with the underscore, it will search for a pattern and it only searches one character. So using an underscore will only match a single character in the pattern you are trying to match. So let's see how that works. Say, for example, I want to search for a pattern in the first name that, and I put in the underscore followed by her and then a percent. So basically what this means is that I'm looking for a character, one character that you can add to this and it will form part of a name. So the character you add here will combine with this her to form a name of a person, the first name. So let's see how that works. Let me run that. And you can see here the pattern is returned 4. If you add C, which is a single character here, it turns this into Cheryl. So the pattern I'm trying to match is this HEROS, trying to match that with one character. As you can see, I've done that with the C, I've done that with the T, I've done that with the S, and here as well. So you just want a character, single character that will match these 3 letters, that ends in these 3 letters. As you can see here, I've done the match. So that's how you use the underscore to match a single character in a sequence. So that is it for the like operator. I do apologize, this lecture is taking a bit longer than I expected, but I hope it has made sense. Thanks for watching and bye for now. Hello and welcome to this lecture. In this lecture, I will introduce you to the Postgres NOT operator. The NOT operator is used to display a record if the condition or conditions is not true. So it only displays records where the conditions is not true. It also is defined with the where clause, so it works with the where clause. So let's have a look at the syntax. The syntax refers to how you would write such a statement to include the NOT operator. So the syntax basically is this. You use the select keyword followed by the column names. If you are not specifying the column names and you want to retrieve all the columns, so you replace the column names, just put an asterisk instead of the column names. And then in the from field, you specify the table name. And inside the where clause is where you add the not operator. And then you specify the condition for the not operator. So the condition has to be false. All right. So the condition you specify here, the records will be returned if the condition specified is not true. Let's open up our PGAdmin tool so we can see how this works. So I've got my PGAdmin tool open. I'm going to use the DVD rental database, and it has 15 tables. The table I'm going to use for this lecture is the inventory table, this table here. Let me expand that so you can see the columns from the table. This inventory table has 4 columns. So let's quickly write a select statement. I'm going to right click on the table name and click on query tool and wait for the query tool to open up. So the query tool has opened up. I'm just going to write a simple query. Because the columns are not that many, I'm going to use all the columns in the query. So I'll type in select followed by asterisk. The asterisk means it will get all the columns from the table. And then the from field is where you indicate the name of the table. It's called inventory. Before I apply the where clause and also include the not operator, I just want to run this query so we can see what it contains. Look out for the bottom right hand corner. When the query is executed, it will tell you how many rows were returned. So let me run that. So look out here. It says 4,581 rows retrieved. Okay, over 4,000 rows retrieved. So I want to modify this query. So I'm going to get rid of the semicolon here and add a where clause. So I'm going to type in where. After the where clause, I'm going to add the not operator. And then I specify the condition. I'm going to use this here, this column called store ID as a condition. So I'm going to say where the store underscore ID is equals to 1. So it will only return records that does not match this condition. So it will only return records that matches where the store ID equals to 2. All right. So that's what this not operator means. It will return record that does not match the condition you have specified. So this condition here is not going to be true because it's going to return records that does not match this condition. So if I execute this query, I don't expect to get anything above 4,000. The previous query gave us over 4,000, so I expect it to be much less because we are excluding anything that's called store ID number 1. So I only expect the store IDs to be 2. So let me run this query. Look out for the bottom here. It says 2,311. So it has returned less queries. And if you look in the store ID field here, all the store ID is 2 because you won't find anything here with the store ID of 1 because this is a condition included in the not operator. So anything that matches that, the data will not be returned. All right. So that's how you use the not operator. Many thanks for watching. Bye for now. Hello and welcome. In this lecture, I'm going to introduce you to the Postgres OR operator. The OR operator basically is used as a filter to filter records based on certain conditions. So with the OR operator, it will return any conditions that matches, it will return records that matches any condition you have set. So you usually will specify more than one condition. It doesn't have to match all the conditions. As long as it matches one, it will return data for whichever condition it matches. It is usually specified inside the where clause of the select statement. Let's have a look at a typical syntax, how you specify the OR operator. So with the OR operator, you can use it to filter records based on one or more. So the syntax basically looks something like this. So once you've written the key select statement, you've specified the from keyword, and then in the where clause is where you specify the condition that the data will return from the query. So with the OR operator, you have to specify several conditions. So you can specify as many as you want. If the query matches all the conditions, it will return data for all the conditions. If it only matches one, it will still return the records for that condition it has matched. The best way to show you this is to illustrate how it works. So let's go over to our PG admin and see how to implement this. I have logged into my PG admin tool, and the database we are going to use is the DVD rental database. So it's going to belong to the public schema, and these are the tables for the database. It's got 15 tables in total, and the table I'm going to use for this lecture is the city table. So I'm going to expand so you can see the columns. These are the columns for this table. It's got city ID, city country ID, and then last update. So to run the query, I right click on the table name and click on the query tool to launch the query window. Before I use the operator, I just want to quickly type in a query here just to select the data or the columns I want. Actually, because the columns in this table are not that many, I'm going to just get all the columns. I'm going to use asterisk to get all the columns, and I'm going to specify from is where you indicate the name of the table. So I'm going to just execute this query now. So it's going to get all the data from this table called city. So let me run that, and it returns 600 rows from this table. So there are 600 records inside this table. So this is without applying any where clause as a filter or the OR operator as a filter. So now I want to change this structure of this query and implement a where clause. So I'm going to add a where clause, and inside the where clause I'm going to use the city column, which is this column here. I'm going to apply some conditions to that column. So I'm going to say where the city is equals to, I'm going to select, these are all the cities at the moment. I'm going to select one that I know is not there in the database, and I'm going to select one that I know is definitely there. All right, so I'm going to select Atlanta, and when you are selecting text, you need to enclose it in quotes, okay, so that the database can read that. So I'm going to say where the city is Atlanta, or this is where I apply the OR operator, or city equals to London. Okay, I know we've got London in the database, but I know we haven't got Atlanta inside this database. So these are the two conditions I've specified using the OR operator. So it will return any data that matches both or either of these conditions, either where the city is London or city is Atlanta. So let me execute and you can see. You can see it's only returned 2 rows because, as I said, Atlanta doesn't exist there, but it's return record for London. If I was to change this to, say, Abu Dhabi, I know there is an Abu Dhabi there, and I run this again, I expect to get more than 2 columns. You can see it's giving me 3 because I know Abu Dhabi exists. So the OR operator is quite useful because you can use that to specify a range of conditions for data to be returned. That's how you use the OR operator. Many thanks for watching and bye for now. Hello and welcome to this lecture. In this lecture, I will introduce you to the Postgres AND operator. This operator is a very fussy operator in that it will only return data if all the conditions specified between the AND operator is true. So the AND operator displays records if all the conditions separated by the AND operator is true. It is usually specified within the where clause, so it works with the where clause. And it is used to filter records based on more than one condition. Let's have a look at the syntax. This is how the syntax works. So basically, you use the select keyword to indicate the column names, or asterisk if you want all the column names returned. In the from field, you specify the table name. In the where clause is where you specify the conditions. So the conditions on either side of the AND operator must be true. If it is false, no records are returned. This is why I say this operator is a very fussy operator. Unlike the OR operator, as long as one condition is matched, it will return some data. The AND operator wants all conditions to be matched. It's either all or nothing. So let's see how this works. So I'm going to go over to my PG admin tool. I'm going to use the tables from the DVD rental database. I'm going to expand this table here. And the table I'm going to use to illustrate is this table called city. If I expand, you can see all the columns. It's only got 4 columns, not that many. So rather than select individual columns, I'm just going to use all the columns. So I'm going to right click on the city table and go query tool. And I'm going to write a simple query to first of all give me all the data from this table before I apply any where clause. So I'm going to do select star from, the name of the table is called city. That's basically it. So I'm going to run the query, and this is returned 600 rows or records. So I just want to use one row here to illustrate how the AND operator works. Just to let you know, you can have more than one AND operator inside a select statement, just to let you know. So let me look at all the records from this table. I'm going to use this here as an illustration, this record here. So let me modify the statement to include a where clause and the AND operator. So I'm going to type in where I'm going to use the city ID. Yeah, this is city ID, where city ID. city underscore ID is equals to, city ID here says 596, and then I implement the AND operator, and city, which is this one here, is goes to this value here called Zaria, equals to Zaria. This is a text, hence I've enclosed it in quotes. When you are dealing with text values, you must enclose them in quotes, hence I've done this. This value here is a numerical value. You can see here it says 596. I've not enclosed that in quotes because it's not a string or a text. You only enclose text or strings in quotes. So if I execute this query, I expect this query to return just one record for this here, this line here, because all the conditions have been met on either side of the AND operator. The city ID is 596, as we can see here, and the name of the city is Zaria, as we can see here. So let me run this query. If it doesn't return, there you go, it's returned one row as expected. If, for example, this value, if I change that value to 597, that means that this condition is no longer true. All the conditions on either side of the AND operator must be true for any data to be returned. If any condition is wrong, it will not return anything. So let me execute this and you can see what I mean. I'll click this to execute. It says 0 rows retrieved. This is because this condition here for the city ID is no longer true. The actual ID was 596. Because I changed that, that means that condition is no longer true. Hence the AND operator refused to return any data. Hence no data was returned. This operator here, you use that if you want to ensure that all the conditions are met. Is quite a strict operator. It will only return data if all the conditions specified between the AND operator in the where clause is true. So take note when you use the AND operator, if it doesn't return any records, it means some conditions specified are or is not true. So if I change this condition back to 596, that should make it true and it should return one record. So I just click on that again. As you can see, it's returned one row of record. So that's basically how you use the AND operator. Many thanks for watching and bye for now. Hello and welcome to this lecture. In this lecture, I'm going to explain how you can use the AND and the OR operators together with a select statement. The illustration I will show you would be using a select statement, but it is also possible to combine both operators with an insert statement, an update statement, and also a delete statement. Also, when you are combining both conditions in a statement, it is important that you use parentheses. The parentheses basically helps the database determine the order in which to evaluate the condition, just like you would in a math operation. If you want certain math operators to be performed first before the others, you place it inside parentheses. So you do the same when you're combining the conditions for the AND and the OR operators. So I'm going to go over to my PG admin tool and show you how this works. I have logged into my PG admin 4. I'm going to use the DVD rental sample database, and I will be using the tables, one of the tables from this sample database. The table I am going to use for the illustration is going to be this table here called city. If I click on the plus sign to expand, you can see all the columns of the table. It has 4 columns. So I'm going to right click on the table and click on the query tool. I'll wait a few minutes. Once the query tool opens, I will now write the query. I've only got a few columns for this table, so I'm going to use all the columns in the query. So I'm going to type in a select followed by star. The asterisk means it will get all the data from all the columns. The from is where I specify the name of the table, which is city. And before I do that, I just want to run the query as it is so we can see the records. It's got 600. This table has 600 records. I just wanted to see how many records in that table. All right, so now I can start applying other aspects of the query. So I'm going to add a where filter, and I'm going to use both the or and the and operator. I'm going to use the and operator first, and I'm going to enclose that in parentheses so that the database will evaluate this condition first. So what I'll do, I'm going to select the country ID. This here is called country ID. So I'm going to look for a random country ID to select. I will look for one shortly. All right, so I'm going to select this one called Basel. So the country ID, which is this for Basel, is 91. So I'm going to type here country underscore ID. I'm going to set that to equals to 91. Country ID is 91. And I'm going to specify a city name. Let me scroll down to the bottom. See, I'm going to use this city here called Zaria, and city equals to Zaria. When you are specifying a text value, you must enclose it in quotes, as you can see here. By putting this condition, the and condition, in parentheses, what that means is that the database will evaluate this condition first. Notice that any condition in the and operator must be true on either side. So it will evaluate this first before it jumps to the or operator. Now I can add the or operator. So I can say or where the city name. All right, I've got country ID 91 and the city equals Zaria. So this time I'm going to use a different column. I'm going to use the city ID, which is this column here. So I'm going to use where the city underscore ID is equals to, I'm just going to pick a random, I'm going to pick this one, York, where the city ID is 589, which is York. With numeric or integers, you don't need to enclose them in quotes. So that is basically the query sorted. So I've got the select statement here. It will select from all the columns because I've used the asterisk. It will get the data from the city table, which is this table. And this is the where clause. And inside the where clause, I've got parentheses here, and I've got the and operator. So the conditions on either side of the or operator must be true. for any data to be returned. And I've got the OR operator here, and I'm giving it a condition where the city ID is 589, which is York here. So if I execute this, I expect to get some records returned, at least 2 rows of records. So let me run that and we can see, I've only got 1 row returned, which is this ID here. For some reason, it looks like the condition inside this AND is wrong. Hence, it's only returned the condition for the OR operator. So let me check what's gone wrong. All right, so I figured out what went wrong here. The country ID was wrong. So for any condition you specify in the AND operator, the condition must be both correct. If not, it doesn't return any data within the AND operator. So I had this value wrong, hence no records were returned. Now that I've run the query again, it gives me 2 records. So is this first record here, York, is for the OR condition here, and the second record here is matching this condition where the country ID is 69, okay, for this Zaria here, and the city equals Zaria. So both conditions have been met. So when you are using combined operators, always place parentheses around the operator you want to be evaluated the first. So that's how you combine both the AND and OR operator in the same query. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I will introduce you to the Postgres limit clause. The Postgres limit clause basically is an optional clause that you can use with your select statement. And what it does, it gets a subset of rows returned by a query. You can also use the limit clause to obtain information like the highest or lowest item in a table. For instance, you can use that to obtain the top 10 most expensive films and other types of related data. Let's have a look at the syntax. Syntax refers to how you would write a limit clause. So usually it's embedded or added to a select statement. So looking at this select statement here, we've got the limit clause here and we've got the n variable. So what that means, basically the statement returns n number of rows generated by this above query, which is the select statement. If the value of n is 0, or if it is null means there's no value, the query basically will ignore this limit here because the n returns 0 or has a null value. Then this will not be applicable because there's no rows for it to act on. So the n, there must be a value for this n here for the limit clause to kick in or to be activated properly. When you use the limit clause, you can also use it with an offset. For example, if you want to skip a number of rows before returning the n number of rows, you can use the offset clause. Okay, and this is how you place that. You specify the n number of rows and then offset the m value. And what this statement means basically is that the statement first of all will skip the m rows before returning the n rows generated by the query. However, if the m row is 0, the statement will still work as if it didn't have the offset clause in it. All right, so basically the offset clause here is used if you want to skip a number of rows before returning the n number of rows. However, if the value of this m row is 0, the statement will still work, but it will work based on the n value alone and ignore the m because there's no value, or the value of the m is 0. Sometimes the order of the rows in the database table is unpredictable. So when you use the limit clause, it's recommended that you also use the order by clause so that you can control the order of the rows. If you don't do so, you probably will get results that are unpredictable. So this is how you would specify the statement to include an order by clause. So using the order by clause basically controls the order of the rows returned. So let's go over to our PGAdmin tool so I can show you how to use the limit clause in your select statement. So I've logged into my PGAdmin tool and I'm going to illustrate from the DVD rental database. So I'm going to expand the tables from that database, and the table I'm going to use for the illustration is this table here called film. Let me just expand so we can see the columns in the table. So I'm going to use this table here called films. It does have several tables, so these are all the columns from this table. Quite a few columns here for this table called film. So let me open the query editor. I'll right click on the table name and go query tool, and that will launch the query editor. I don't want to use all the columns from this table. I just want a few, so I'm going to select the film ID, the film title, and the year of. There should be one for, and this here called release here. So let me do that. So I'll start with a select statement. When you write a select statement, you can put each of the statement in a separate line. For example, you can put the film ID on one line if you want. Some people prefer doing that, but I just like to write as short code as possible. So I'm going to put all the columns in the same line. So I'm going to do title and then release here. Release underscore year. Make sure you specify the columns the way they've been defined in the table. So I've got film underscore ID, that's that one. And then I've got title, and then I've got release underscore year. So if you want, you can put each of these columns in a separate line, but just separate each of the columns by a comma if you wish to space them out. But I just want, I'm happy with it like that. And then you type in the from field and specify the table. The table name is called film. And next I'm going to specify an order by. I'm going to use an order by clause. I'm going to order by the film ID, film underscore ID. Then I'm going to apply the limit. What I want to do here, I want to get the first 5 films ordered by the film ID. So I'm going to do a limit 5, and that should get me the top 5, get me the first 5 films ordered by this film ID here. So let me execute that, and hopefully this is the result I'm looking for here. So you can see it's giving me the first 5 films ordered by the film ID. If, for example, I wanted to retrieve 4 films starting from the third one ordered by the film ID, starting from the third one, yeah, ordered by the film, this is the third one here, yeah. If I want to retrieve 4 films starting from there, I can do that by adding an offset to the statement. So what it will do, it will retrieve 4 films, but starting from here. The offset will start from here. That means from here, it will count 4 and display the films. So let's modify this query and include an offset. So rather than offset, I can leave rather than offset limit 5. I can say change this to limit 4 and then add an offset. Offset 3. So what this means, it will have asked it to give me a list of the 4 films, but what it will do, it will, from this query here, it will start it from here. I've said offset 3. So it will skip this, anything before 3, it will skip this 2, and it will start the count from here. So I expect the query to return 4, 5, 6, and 7. All right, at the moment, this is, notice I've said offset 3. That means from anything after the 3, return the next 4 films. So let's check that out. I'll click on this to execute the query. And as you can see, as I said, is retrieved. See, it says limit 4, offset 3. So I've got 1, 2, 3, 4, 4, 5, 6, 7. The first results gave me 1 to 5, and I've used an offset. What I'm saying is that from the third, give me the next 4. So that's how you use an offset with the limit clause. So I hope the lecture has been useful. If there are any aspects you do not understand, please feel free to let me know. Many thanks for watching. Hello and welcome to this lecture. In this lecture, I will be introducing you to the Postgres in operator. The in operator basically allows you to specify multiple values inside a where clause. So when you use the in operator, you can basically check against a list of values specified in the where clause. There are several ways you can specify that, but you must specify the in operator inside the where clause. So let's have a look at a couple of syntax. The first is this. So you specify the in operator inside the where clause. You can see this is the in operator here, and it is specified inside the where clause. So you start with the select statement followed by the name of the column if you're specifying column names, and then the table, and then the where clause. Within the where clause is where you specify, for example, maybe the column name, and then you use the in operator, and then you must place the values you're trying to check against. They must be placed in parentheses here. So another way you can specify it is this way, where you specify obviously the column names, the table, and the where clause. And inside the where clause, you specify the column name and then use the in operator, and then you use the select statement as the parameter. So the values inside the select statement is what you are checking against. The best way to see this is in action is to actually show you how it works. So let's go over to the PG admin tool and see how this works. So I have connected to my PG admin 4 tool here, and these are the tables from the DVD rental database. The DVD rental database is a sample database we are using for this illustration. So it has 15 tables, and the table I am going to use here is one called rental, this table here. So I'm just going to expand that so you can see all the columns within that table. So these are the columns from this table called rental. So let me open the query tool by right clicking on the table and clicking on query tool. and that will launch the tool we can use to query the table. Right, I don't want to query all the dates, all the columns from this table. I'm going to be specific here. So I'm going to select the customer ID, the rental ID, and the return date. So those are the three columns I'm going to use. So let me start the query. I'll start by typing in select, followed by the column names, and I'll separate each column name by a comma. Note, you don't have to have all the column names on the same line. You can have them on separate lines, but separate each one by a comma if you wish to. That will obviously make your query longer. So I'm just going to type in customer ID. You must specify the column names the way they have specified in the table. So I'll do a comma to add another column. So it will be rental underscore ID, which is this one here. And I put a comma to add another column. And the other column I want to add is the return underscore date. Return underscore date. I don't need to put a comma because that's the last column. So, but it is possible to have these columns on separate lines after the select keyword, and then just put a comma on each one apart from the last one if you wish to do that. But writing it this way makes the query much shorter. So next, I need to specify the table the information is coming from. So it's coming from the rental table. This table here is called the rental. Next, I need to add my where clause. The where clause will act as the filter. So this is where I specify the condition to use with the where clause. So I'm going to say, I'm going to use the customer ID column. I'm going to say customer ID customer underscore ID, and then this is where I add the in clause. I'm going to say in. So anywhere we're going to look for any one that has customer ID 1 or customer ID 2. So the in operator here is checking against these two variables. It will check if the customer ID is 1 or if the customer ID is 2. Any that matches these two criteria, it will return the data. So let's execute that. What we can also do, we can order the data. Let me add an order by. Order by is usually the last you add in a select statement. So I'll do order by, and I'm going to order by the return date, which is this column here. And I'm going to make it in a descending order. Okay. Actually, no. Let's make it in ascending order. Ascending means it will return it from A to Z. So that's it. Let's execute the query. I click on this and the query. Ooh, I've got an error. Okay, syntax near rental. Oh, I don't know if you can spot the error there. It tells you, see the dotted line? It tells me where I've made the error. It's in my from. I need to adjust that and put in F. You can see it should work now. So if I click execute again, excellent. So it tells me 59 rows retrieved. So you can see here, I've ordered it by return date. This is the return date in ascending order, and that is from A to Z. So this is the way it has returned it. And the condition here is that any customer ID that matches 1 or 2, it will return the rental ID and it will return the return date. So the in operator here, you can use it to specify multiple values. I've only got 2 values in there. I could easily have 20 or even 100 values in there, and it will check against those values are placed between the parentheses here and return the data. So basically that's how you use the in operator. It makes it easy to return data if you just want to check against certain criteria. If I wanted to amend this data, for example, I can change from the where clause, I can change it to rental ID. If I wanted to say, for example, let me just amend this a little bit. I'll say rental underscore ID, and inside this rental ID, let me put a few values in here. I'm going to select, say, 320, comma. You have to separate each value with a comma, and I'll put in 76, comma. I put in, say, 2128, this value here, 2128. And let me pick this one, 5636, comma, 5636. And I'll change the order by, I'm going to order by, say, I'll leave it order by return date, but this time I'll change that to descending. That is from Z to A. So the data that's going to be returned by this query will be much shorter, because it's only going to target 1, 2, 3, 4 values. So it will search under rental ID. If any of these IDs it finds, it will return the data for these columns that I have specified. So let me execute. I go that, click on that. As you can see, it's returned only 4 rows. The reason being, there are only 4 values in there for it to check, and the values I have specified are unique values, so they are not duplicate. Hence the reduced rows it has returned for the conditions here. So that's how you use the in operator. You can use it in combination with the where clause to filter data returned by a select statement. Many thanks for watching. Very important that you place the values in between parentheses, and you must separate each of the values with a comma, as I've done here. Thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to use the union operator to combine result sets of multiple queries into a single result. When using the union operator, if there are any duplicates in the result, it removes the duplicates. Both queries must return the same number of columns. Also, the corresponding columns from the queries must have compatible data types. Let's have a look at the syntax for implementing a union operator. So basically, a union operator combines the results of 2 or more select statements. So basically, this is the first statement here. First statement picks column 1, column 2 from table 1, and then you apply the union operator, and then query number 2, the select statement picks column 1, column 2 from table 2. So they must have matching columns. So if you have 4 columns there, you must have columns in the second table, and both columns must be of the same data type. Once the results are combined, any duplicates are removed. So I'm going to show you an illustration of how to implement the union operator. I'm going to use the sample database, which is the DVD rental database, and I'm going to use a couple of tables from the database. The database has 15 tables. I'm going to use the customer table and the payment table. The reason I'm doing that is because the columns have matching columns in those tables. So if I expand the customer table, it has a customer ID column. If I expand the payment table, you can see it also has a customer ID column. So let me open up my query tool and implement the query. So I'll start with the select statement for the first table, which is going to be the customer table. So I do a select followed by the column I want to use, which is the customer ID column. Customer ID, and then I specify where the table is coming from. It's coming from customer. Now I apply the union operator, and then I add the second select statement. So I'm selecting customer underscore ID from the payment table. So the union operator joins the output from the first select statement to the output of the second select statement. Both participating columns must have the same data type, and you must have matching columns. So if you've got two columns here, you must also have two columns here. So if I execute it now, any duplicate entries will be removed. So let me execute that. You notice we've got 599 rows. So these are all the records returned from combining these two select statements. So that's basically how you implement a union operator. Thank you for watching. Hello and welcome. In this lecture, you will learn how to use the union all operator to combine the results from multiple queries into one. Unlike the union operator, the union all does not remove any duplicates that occurs as a result of combining the output from both queries. So it keeps the duplicates. Both queries or all the queries participating in the union all must have the same number of columns. Also, they should have the same data types. So the corresponding columns must have compatible data type. You can't have one that is a string and then the corresponding one will be an integer. The data types have to match. Let's take a look at the syntax for implementing the union all operator. So it's basically identical to the union operator. You write the select statement for the first query, you apply the union all operator, and then you write the select statement for the second query. Just make sure that both queries have the same number of matching columns. If one of them have got 4, make sure the other have got 4, and also make sure the corresponding data types are the same. So let me show you an illustration of how the union all operator works. This is a query I previously wrote for the union operator. So let me just execute that again so you can see the number of rows. With the union operator, it removes any duplicates within the queries from both queries. So checkout is got 599 rows retrieved. So it has removed all the duplicates. If I was to convert this query into a union all by just adding the all, it will not remove the duplicates. So remember that this output was only 599. If I run this, change this to the union all and execute this, I'll expect to get much more than 599 because all the duplicates will be kept. So that's the key difference between the union and the union all. One removes duplicates, the other keeps the duplicates. So let me run this query and look out for the amount here. It says this is 15,000, over 15,000 rows retrieved. So it keeps the duplicate. If I scroll through, you might see some of the duplicate. You see all these are all duplicates. These are duplicates. So if you don't want the duplicates, you have to use the union operator and not the union all. So that's the key difference between the two operators. So that's it for this lecture. Many thanks for watching and bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to use the intersect operator to combine two or more select statements to form a single result set. The intersect operator returns all rows from both result sets. Also, the number of columns that appears in the participating select statements must be the same, must be equal. So if you've got 4 columns in the first select statement, you should have 4 in the second select statement. Also, the data type should be the same. Let's have a look at the syntax or how you would implement an intersect operator. So this is the syntax, quite straightforward. You start by specifying the first select statement and you specify the columns you are going to use from that first statement. You then apply the intersect operator once you've specified the table from the first select statement. And then you write the second select statement and also specify the columns to be used in the second select statement. And then you specify the table from the second select statement. So the columns must match. If you've got 2 columns specified in the first statement, you must also have 2 columns specified in the second statement. Also, the data types must match. To illustrate how the intersect operator works, I'm going to show you using a couple of tables from the DVD rental sample database. This database here, it has 15 tables. So I'm just going to click on the plus sign to expand the tables. The tables I'm going to write the queries for is going to be 2 tables. I'm going to use the customer table. It has 10 columns, and I'm also going to use the staff. There's a table called staff here, and this has 11 columns. So both tables have, sizable amount of columns. When you are specifying the columns, they must match. So you can see there's quite a few columns that match from this table. You've got the customer ID from the customer table. That doesn't actually match. So the matching columns are store ID. You've got the store ID here from the staff table, and you've got the store ID here from the customer table. You've got the first name, last name, email from the customer table, And if I come over here to the staff table, you've also got the first name, last name, and email. You've got quite a few here, few columns that do match. So there's quite a few columns you can use to participate in this intersect join. But I'm going to use just one column from each of the table. I'm going to use the store ID from the customer table and the store ID from the staff table. But you can feel free to experiment and use multiple columns from either table, because both tables have more than one columns in common. So you can practice by using more than one. But the illustration I'm going to show you is just going to be with the one column. So I'm going to right click on the table and just go query tool to open up the query window. So I'll start with the first select statement. I'll do a select, and I'm going to use the store ID from the customer table. So I'll type in store underscore ID, that will be the column. And then I specify the name of the table is called customer. Then I apply the intersect operator. Then I write the query for the second select statement and table. So this is the second select statement. Again, I'm using the same column type, which is store ID, from name of the table is called staff. So if I just expand that a bit, so that's basically our intersect operator setup. So let me run that, and it will combine the result of the first and second into one. So this is the actual output from the combination of these two select statements. So that is it. In this lecture, I explained how to implement the intersect operator. Many thanks for watching, and bye. Hello and welcome to this lecture. In this lecture, you will learn how to use the except operator to return the rows in the first query that do not appear in the output of the second query. So the except operator returns rows based on comparison. So it will return the rows by comparing the result sets of two or more queries. Just like the union and the intersect operator, the except operator will return the rows by comparing the result sets of two or more queries. So it returns the results of the first query not present in the second query. So it returns the rows from the first query that are absent in the output of the second. It also returns distinct rows. Distinct means it removes the duplicates. So it returns distinct rows from the first or left query that are not in the output of the second or right query. Also, the number of columns and their orders must be the same in both participating queries. Likewise, the data type of the columns in the participating queries must be compatible data types. Let's take a look at the syntax to implement the except operator. So basically you start with the first select statement, you pick out your columns, sort out your table, and then the where clause is where you apply the first condition. Then you add the except operator and implement the second select statement, choose your columns and the table, and then you implement the second where condition. I'm going to show you a few illustrations here, and I'm going to use the DVD rental sample database. This database has 15 tables. So I'm just going to expand the tables, and we are going to use some of the tables. So I'm going to take a look at the film and inventory table. So let's start with the film table first. This is a film table. It has 13 columns. So these are the columns from the film table. Next, I'm going to look at the inventory. So this is the inventory table. It has 4 columns. So if you look at the film table, 13 columns, inventory table, 4 columns. To save a bit of time, I have added some query here. So this is just a simple query. So I'm selecting the film ID from the film table and also the title from the film table. And I'm ordering that by the title in the film table. So this query is only querying data from just one table. So let me run that so you can see the output. So this is the output, 1,000 rows retrieved from this table called film. So these are all the films and the titles returned from the film table. Next, I'm going to add a query that will return the films that are in the inventory table, this table here. So this is the query I've added on to retrieve data that will show the films in the inventory table. So basically I've done a select statement here. I've used a distinct from the film ID table. The distinct will remove any duplicate entries. So I'm selecting 2 columns, the film ID and also the title. So this is inventory. So I'm using the inventory ID. And I have implemented a join, an inner join here. So I'm joining the film table here, which is this table. So I'm joining the film underscore ID column that belongs to the film table. I'm joining that with the film underscore ID column that belongs to the inventory table. So performing a join on this table, and then I'm ordering the output by the title. So let me execute that. So you can see, so it's got 958 rows. So this output here is showing the films. It has returned the films that are available in the inventory table. So the 2 queries I have executed both return a result set that consists of 2 columns, the film ID and the title. In order to get the films that are not in the inventory table, we're going to have to implement the except operator in our next query. So this query will get the films that are not in the inventory table, okay, because I've used the except here. So basically I've used the select keyword. I'm selecting the film underscore ID and the title, these 2 columns from the film table, this table here, and then I'm implementing the except operator here. So this is the first query. The second query starts here. With the second query, I'm using a distinct on the inventory table and on this film underscore ID. What the distinct will do, it will get rid of any duplicate, okay, from this film underscore ID. and I'm also adding the title. So this has 2 columns, this has 2 columns. So both queries have matching columns. And here I've implemented the join as well. I'm joining the film ID from the inventory table to the film ID on the film table. So I'm performing a join here, and then I'm ordering the output by the title. Notice that I placed the order by clause at the end of the statement so that it sorts the film by their title. If you place the order by clause in each query, the final result may not be sorted because each query will sort the result set by the title column, and after that the except operator is applied to both queries. So putting the order by at the end is the best option because it will sort out the film by their titles properly. So let me execute so you can see the output. So this is the output, and all duplicates would have been removed. So in this lecture, we learned how to use the Postgres except operator to combine 2 queries to get the rows in the first query that do not appear in the output of the second query. I hope it's been useful. Thank you for watching, and bye for now. Hello and welcome to this lecture. Postgres joins are used to retrieve data from multiple tables. A Postgres join is usually performed whenever 2 or more tables are joined in a SQL statement. Also, tables that are participating in the join must have related columns between them. There are several types of joins you can perform in Postgres. You can perform inner join, left join, full out join, a cross join, and a natural join. We will be covering each of these types of joins in this section. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to select data from multiple tables by using the Postgres inner join clause. With the inner join, it will return records that have matching columns from the participating tables. So any record returned from using the inner join will have matching values from the columns in both tables. What that means is that the participating tables must have columns that are matching. For example, you can have on one table, they've got a column called Joe Blogs. On the other table, they must also have a column called Joe Blogs. Let's have a look at a simple syntax of how to implement an inner join. So this is the syntax, just a basic syntax here. So you select the column names from the participating tables. In the from field, you specify the first table, and then you perform the inner join on the second table. And this is how you use the on keyword to indicate this is what actually implements the join. It's like a glue, that's what glues it on. So you do an inner join on table B on table A dot column. That is the column from table A where you're performing the join on. Will be, you set that to equals to the column on table B. It will make more sense if I actually show you how an example of how this works. So this is just a simple illustration here. We've got a table A here and a table B. So you will have, it will return records that match columns from both tables. So they must have participating columns that match. I am going to perform an inner join on two tables that belong to the DVD rental sample database, this database here. So let me expand the tables here and I'll tell you the two tables I'm going to use for the inner join. So I'm going to use the customer table, which is this table here, and the payment table. So one of the criteria in a table join is that the tables that are participating in the join must have columns that match. So let me look at the customer table first. You can see the customer table. These are the tables in the customer table. And it has a customer ID, store ID, first name, last name, and so on. So I want you to take note of this. It has a customer ID. Now let's look at the payment table. You can see here the payment table has 6 columns. It also has a customer ID. All right, so this customer ID here matches the customer ID for the customer table. So we have a matching column. So these two tables can participate in the join. This is an illustration of the relationship between the two tables that I am going to use to illustrate the inner join. This is the customer table. It has a customer ID, which is the primary key on this table. And you have a customer ID on this table called payment. Although it's not the primary key, but there is a relationship. You can see that of all the columns here and of all the columns here, the columns that match is the customer underscore ID and the customer underscore ID here. So those are the two columns we are going to use for the inner join operation. So looking at this ERD diagram here, this basically indicates one-to-many relationships. So basically what this means is that each customer may have 0 or many payments. See, that's the 0 there. May have 0 or many payments. Each payment belongs to one and only one customer. That's what this is. All right. So the link between these two tables is established via the customer ID field, which is this field here and this field there. To save time, so that you don't have to watch me type all the statement for the query, I've already pre-written the query. I'm just going to explain it to you. So I'm just going to right click on the first table here, the customer, and click on the query tool. And once the query tool launches, I will paste the code I've written into that, and then I'll run through it with. So this is the code I've written here, and in this statement here, I have used the inner join clause, this inner join clause here, to join the customer table to the payment table. So let me start with the first statement here. So the select statement basically is what will read or get the data out of the table, and I've got the customer dot. The dot here indicates that this field here, customer ID, this column is coming from the customer table. So you separate the column from the table name with a period or a dot. That's what this means. Customer underscore ID is coming from the customer table. The first name also is coming from the customer table. Last name also customer table. Email here, the amount from the customer table as well. Sorry about that. I may have confused you a little bit. Let me just run through this again. I'll start again. You start with a select statement. So you need the select keyword to retrieve data from a table. And here, because we have two customer ID fields we're going to use, customer ID that belongs to the customer table and the customer ID that belongs to the payment table. All the columns listed here are the columns that will be displayed when the query has been executed, and when it outputs, these are all the columns it's going to output. The reason I've got the customer underscore ID here, so that it differentiates that this customer ID here that's going to be displayed in the output belongs to the customer table. That's the main purpose of this, to differentiate this customer ID from the customer ID in the payment table. The first underscore name is coming from this customer table. The last underscore name is coming from the customer table, and also is the email. The amount comes from the payment table, and the payment date also comes from the payment table. So I've got two columns that are coming from the payment table, and the others are coming from the customer table. So now in the from field, we are specifying the customer table. Okay, so all the customer table where we're specifying the from field, and the inner join, we're doing the inner join on. Notice after the inner join clause, we specify the name of the other table participating in the join, which is the payment table, and we use the on keyword to indicate where the join is going to take place, kind of like where the glue is going to be placed. So the join is on the customer underscore ID table, or the customer underscore ID column that belongs to the payment table. We're going to set that to equals to the customer ID table that belongs to the customer table. So it's going to combine the records from these two tables when the query outputs. So let's give that a go. Run the query. If everything goes okay, we should see a good output. All right, so we've got over 14,000 rows retrieved. So we now have the customer ID, customer underscore ID field is a combination from both the customer table and the payment table. All right, so that when it says this customer ID from this payment equals to that, this is where the join takes place. So you can see now we've now got data from multiple table courtesy of a join, an inner join using columns that match in both tables. This illustration is just on two tables. You can perform a join on many tables as possible, as long as you have columns from all the participating tables that match. Thank you so much for watching. Take care and bye for now. If there are any aspects of this lecture you do not understand, please feel free to let me know. Many thanks and bye. Hello and welcome to this lecture. In this lecture, you will learn how to use the Postgres left join clause to select data from multiple tables. When you use the left join clause, it will return all the records from the left table in the join, and also any records that have been matched from the right table. If there are no matching records from the right table, nothing is returned from the right table, but it will return all the records from the left table. Let's have a look at the syntax on how you would write a left join. So this is the syntax. Basically, you start with a select keyword and the column names, and you select the first table, which is the table on the left, and then you left join the second table on table 1, dot the column name from table 1, and you set the column name from table 1 to match the column name in table 2. So this, where it's got the equals to here, is where you have the matching column where the join is actually performed. So let's have a look at an example. So this is just an illustration here. In this illustration here, you can see that all the records from the left table are returned, hence it's all shaded, and any record that is matched from the right table, you can see the right table, only this bit here is shaded, which means it will only match the records that meet the criteria set in the join clause. All right, so if it doesn't match these areas, the white areas here, the data has not been matched. The only matched area is this shaded area here. So let's have a look at a quick ER diagram. ER basically means entity relationship diagram. So it kind of like gives you a diagram of the relationship between two tables. These are a couple of tables from our sample database, which is the DVD database. I'm going to use that database to illustrate how we perform a left join. I just wanted to show you the actual diagram to show the relationship between these two tables we are going to use. This table here, called the film table, has a primary key, which is the film underscore ID. If you look at the inventory table, it also has a film ID column. So these two tables here have a relationship, and we can perform a join based on the matching columns from both tables. What this diagram is saying here, this ER diagram, basically it says that each row in the film table, this table here, each row in the film table may have 0, you can see the 0 here, may have 0 or many rows in the inventory table. This here indicates many. So each row in the film table may have 0 or many rows in the inventory table. Also, each row in the inventory table has 1 and only 1 row in the film table. So you can see here, that's why you've got this means many. You can see here there's only a single, which indicates that each row in the inventory table has only 1 and only 1 row in the film table. So this kind of like gives you a relationship diagram. It's called an entity relationship diagram. Shows you the relationship between the entities of both tables. So now let's head over to our PG admin tool and implement this join between these two tables. So this is the admin tool here, and this is the DVD rental database, and these are the tables. So the two tables we are going to use in this join is the film table. Let's look at the film table quickly, and you can see it has 13 columns. We've got a film ID column, and if we look on the other table, which is the inventory table, we should have a film ID column as well. So this is a film ID column. So we are performing the join based on these two tables having a matching column. That's where the relationship is. So let me quickly open up our query tool. I'm going to right click on let me go back to the film table. I'm going to right click on the film table and go query tool, and that will launch the query editor. So what I've done to save time, I've pre-written the script. I'm just going to copy that in and explain it. So this is a query to perform the join. So what I've basically done here, you can see that I have used the left join clause to join the film table to the inventory table. All right. So we start with the select statement. If you're reading data from a table, you always use the select keyword. So this start with the select keyword, and then I specify the columns that will be displayed in the output. Because I'm using identical columns from the film table and the inventory table, it is the film underscore ID column from the film table that will take precedence. That's the table, that's the column that will display after the join has been performed. So hence I've got film underscore ID dot film. The dot indicates that this column here is coming from the film table. Next, I've got the title here dot film, which indicates that this title column here is coming from the film table. And then we've got the inventory ID, which is coming from the inventory table. And the from is from the film table. The film table is the first table. That will be the table on the left. So it will return every record that matches from the left table and part of the record that matches from the right table. So on the right table, it will return things like the inventory ID, because that should match. So let me execute. This is the join now. After the from field, we've got the left join, which is the keyword. This is what actually you have to indicate to perform the join. So we're performing a left join on the inventory table, and we're using the on, this on keyword. Without that, the join does not happen. That's what glues it together. So we're using the on keyword, and we're specifying the columns that are involved in the join. So we're joining the film underscore ID column that belongs to the inventory table. We're joining that to match the film underscore ID column in the film table. So the join has been performed using just these keywords here. So let me execute so you can see. All right, so the join has been performed. As you can see, the columns listed in the select statement and the ones you can see here. Film underscore ID, this ID here, that's the one there. The title is this title, and the inventory is coming from the inventory table. So that's how you perform a left outer join. We can modify this query slightly because sometimes you find rows that may be empty. For example, in the films table, there are some rows in the film tables that do not have corresponding rows in the inventory table. So the values of the inventory ID will become null. Null means there's no value. So what we can do, we can add a where clause to select only films that are not in the inventory table. So let's modify this slightly to include a where clause. So what I'm going to do, I'm going to take off this semicolon here to indicate that we're adding to the statement, and I'm going to attach a where clause. So I'm going to say where inventory dot film underscore ID is null. So let me run that again. You can see we've got you can see much reduced rows here. So we've actually filtered the result down by specifying where the film ID is null. So we've changed the conditions slightly with the where clause. So by adding the where clause, it only selects films that are not in the inventory. All right, so this is what we've done here. This technique can be useful when you want to select data in one table that does not have a match in another table. Thank you so much. In this lecture, I've shown you how to use the left join in Postgres to select rows from one table that may or may not have corresponding rows in another table. Many thanks for watching. Please let me know if you have any questions. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to use the Postgres full outer join to query data from 2 or more tables. When using the full outer join, it will return data from both the left and the right tables. However, if the rows in the joined tables do not match, the full outer join sets a null value for every column of the table that lacks a matching row. So when the tables are joined, if there are rows that do not match, the full outer join will place a null value in that row. When using the full outer join, for the rows that do match, a single row is included in the result set that contains columns populated from both joined tables. One thing to note is that when using the full outer join, it can potentially return very large result sets, so bear that in mind. Let's have a look at the syntax of how you would implement an outer join. So basically, once you typed in the select statement and you specify the column name, the table, you then add the full outer join clause and you include the second table where you are performing the join on. And obviously you need the on keyword, and then you select the column name from the first table that will match the column name from the second table. This is just an illustration of what the full outer join looks like. So it populates both tables with data. Suppose we want to perform a full outer join of 2 tables. I'll call it table A and table B. The following this syntax here indicates the full outer join. So we're selecting all the columns from table A and we're performing a full outer join on B, and the matching columns are the ID columns in A and the ID columns in B. The outer keyword here is optional. You don't always have to use it. It is an optional word to use. So what actually happens is the full outer join will combine the results of both the left join and the right join. If left and right join, meaning left table and right table, if the rows in the join tables do not match, the full outer join will set null values. So it will add null values for every column of the tables that lacks a matching row. For the rows that match, a single row is included in the result set that contains columns populated from both joined table. So you can see in the diagram here, rows in A that do not have matching rows in B in this shaded area here. Rows in B that do not have matching rows in A are represented in this shaded area there, while the darker shaded area contains rows that match to both A and B. I'm going to illustrate how the full outer join is implemented using our sample database, which is the DVD rental database. And I'm going to use a couple of tables from this database. I'm going to use tables we probably used before. I'm going to use the film table, this table here, and the inventory table. So let me show you the relationship between these two tables. Both tables are related because they have a matching film underscore ID column. You got the film underscore ID here, which is a primary key, and a film underscore ID here. So they are both related courtesy of matching columns. To save time, I have already written the query. I'm just going to paste it in and then run it through with you. I've already shown you the relationship between the film table and the inventory table. They are both related courtesy of the film ID. We've got a film ID column there and we've got a film ID column here. So we are performing the join based on those matching columns. So I've started off with the select keyword, followed by the film underscore ID column that belongs to the film table. When you have a dot before the column names, it means it identifies what table the column is coming from. The title is also coming from the film table. This is the film table and we can see the title there. However, the inventory ID is coming from the inventory table here. That's the inventory table and that's the inventory ID column. And the left table, the main table for the join, is the film table. So that's I would say that's the primary table. Then we implement the clause that will initiate the join. So we type in the full outer join and we have to specify the second table that is participating in the join, which is the inventory table. And you need the on keyword because that's what glues it together. And we are performing the full outer join on the inventory table on the film underscore ID column that belongs to the film table and the film underscore ID column that belongs to the inventory table. So we're joining data from these two columns. And I've also included an order by to order the data that is returned by the film ID in ascending order, that is from A to Z or from 1 to 100. So let me execute this query so you can see the output. So this is the result of our 4,000 records retrieved. So if you scroll through this record where there are no matching columns or no matching records, it will insert null values. So let me scroll through and you should see a null value soon. Oh, I just spotted one. See, it's inserted a null value where it does not have a matching row to the other column. So it does that by default. It will insert null values. Because there are rows in the film table that do not have corresponding rows in the inventory table. And the full outer join, to compensate for that, inserts a null value in the inventory table to match that missing row. However, if you want to filter this data and if you want it to display, or if you want to show all the records that have the null values, you can do that by adding a where clause. So if I come here, I'll get rid of this semicolon and just tab down and insert a where clause. So I'll say where inventory dot film underscore ID. Inventory refers to the table. Film underscore ID refers to the column, the table that is refers to the column in that table. All right, so add the operator is null, which means it will return all the records that have null value. So this is quite useful because you may want to just check to see how many records do actually have the null values. So let me run that and you would have much reduced output. So I click run and you can see it's only got 42. It has now displayed all the records in the inventory table here that has null value. So it's quite a useful thing to add to your query if you want to check what values are null in your returned data. So that is it for this lecture on the full how to join. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to use the Postgres cross join to produce the Cartesian product of rows in the joined table. Basically, a cross join allows you to produce the Cartesian product of rows in two or more tables. With a Cartesian join or cross join, the cross join is also referred to as a Cartesian join. With a cross join, the participating tables, you can join tables without having to specify matching columns conditions inside the join clause. So when you're using a cross join, it's easy to just join two tables that are not necessarily related by matching columns. So using a cross join, you can combine two tables together completely, whereby you return all the columns from one table added to the columns of the other table to produce a new product, which is known as a Cartesian product. So the tables participating in a cross join does not have to have matching columns in the join clause, whereas the other types of cross join, normally you can specify a condition in the join clause for the matching columns. You don't have to do that with the cross or Cartesian join. Let's take a look at a simple syntax of a cross or Cartesian join. So basically, this is what the syntax looks like. Fairly basic. You select, for example, all the columns from table 1 and you cross join it to all the columns in table 2. That's basically it. So let's see how this works. I have logged into my PG admin tool and I'm going to illustrate this Cartesian or cross join with a couple of tables from the DVD rental database, this database here. So let me just scroll down, and the two tables I'm going to use are the actor table and the city table. If you look at the columns of the actor table, there are 4 columns. Actor ID, first name, last update. If I check the table, the columns in the city table, there are also 4 columns. City ID, city, country ID, last update. There are no matching columns from both tables, but we can still perform a Cartesian join. So we can join these two tables together to create what is known as Cartesian product of rows. So let's go ahead and do that. I'm just going to right click on the first table and go query tool. You can also access the query tool from the tool window here. You can also access it from here. So just that it's quicker to just, if you're already in this area, you can just right click rather than jump to the tools option. So I'll go query tool and I'll wait for the tool to load up. All right, so it's going to be a fairly straightforward query to write. So I begin with this select keyword. I'm going to use all the columns from the table, the first table and the second table, because they're not that many. So I'll do select star. Star means it will retrieve all the columns from the table, and then I specify the from field and indicate the name of the table. So the first table is going to be the actor table. Actor, and then this is where I add the join. So I'll do a cross join on the name of the second table, which is the city table. And that's basically it. Because I've indicated asterisk here, that means it will produce an output that contains all the columns of the first table, which is the actor table, and the second table, which is the city table. If you notice also, there is no on keyword, because with a cross join, you don't have to specify matching columns. So now if I run this query, it should produce an output that consists of all the columns from the actor table and all the columns from the city table. So let's give that a go. I'm going to click on this and wait for the query to execute. The query might take a little longer than the other types of join because it's trying to combine data from both table into one. So there you go, it has finished. So this is the output from the cross join. So if we look at the output here, you can see that the first 4 columns, actor ID, first name, last name, or last update, come from the actor table. And then the other columns, city ID, city, column ID, and last update, city ID, city, country ID, and last update all come from the city table. So this is how you perform a cross join, and it produces a new product called a Cartesian product because you're creating a new product from the combination of 2 or more tables. So that's it for this lecture. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to use the Postgres natural join to query data from 2 or more tables. A natural join is a join that creates an implicit join based on the same or matching column names in a joined table or joined table. Natural join can also be an inner join, left join, or a right join. A right join basically is the opposite of a left join, in that with a right join, all the records from the right join are returned, followed by any matching from the left join. Left join meaning any records matching from the left table. So it will return everything from the right table and anything that matches on the left table. That's what is known as a right join. If you do not specify the type of natural join you are using, by default Postgres will make it an inner join. So the default is an inner join. So when you are using a natural join, if you don't specify if it's an inner join, a left join, or right join, Postgres will automatically assume it's an inner join. Let's have a look at the syntax to see how you would implement a natural join. So this is the syntax. Basically, you select all from the column, if you're using all columns, and then from the first table, and then you specify a natural join. If you want the natural join to be, say, a left join, you have to indicate that inside square brackets. If you don't indicate that, the natural join will implement an inner join. If you also use asterisks rather than the actual column names, if you use that in the select list, the result will contain all the common columns, which are the columns in both tables that have the same name. Every column in the first and the second tables that is not a common column. So using the asterisk will produces what it will generate. First, it will give you all the common columns which are common in both tables that have the same name, and also every column in the first and second tables that is not a common column, that is where the names don't match. All right, let's go over to our admin tool and implement this. So I'm going to use a couple of tables here from our sample database. Sample database is DVD rental, and these are the tables, got 15 tables. So I am going to use the customer table and the payment table. So let me expand that so we can see the tables. This is the customer table. It's got 10 columns, and I'm also going to use the payment table. Payment table has got 6 columns. So when I implement the natural join, what should happen? All the common columns which are identical in both tables will be displayed. Also, all the columns in the first and second table that also do not have matching columns will also be displayed. So let me do that now. Let's right click on the table and go query tool. Okay, so what I'm going to do, I'm going to select all the columns. I'll do select star, means get all the columns from the customer table first. Table called customer, and I'm going to do a natural join. Because I've not specified what type of natural join, it will make it an inner join. So if I wanted it to be a left join or a right join, I will indicate that. But because I've not, Postgres will assume it to be an inner join. So I'll do a natural join on the second table, which is the payment table. That is basically it. The query is completed. So what should happen? It will return columns from both tables. Let me run that so you can see. So it has returned over 14,000 records from both tables. So this query here is basically the same as an inner join. All right, so if I was to modify this, it will to an inner join, it will give me the same result. Say for example, I do select star from customers. Okay, and I do an inner join. Inner join on the payment table using the customer ID, because customer ID is a column that is present in both tables. So if I execute this query, it should give me the same output. All right, so this is the first query here for the natural join, which, because I've not specified what type of natural join, it makes it an inner join by default. This query also can also be written as an inner join. If I was to write this as an inner join, it will give me the same result, the same output of over 14,000. So let me run this and you can see that. If I execute, look at here, it should show over 14,000 records. If it doesn't, then you see that it's shown over 14,000. So it's giving me exactly the same output. The convenience of using the natural join is that it does not require you to specify the join clause because it uses an implicit join clause based on the common columns. I would be cautious using natural joins because sometimes it can give you unexpected results. All right, so let me show you another example of how you can get unexpected results. So I'm going to pick two other columns here. I'm going to use two tables. So I'm going to use the city table and the city table here and the country table. I'm going to perform a natural join and you'll see what I mean by unexpected result. So I'll start with a select statement. I'll do a select and it will be star from city, which is the city table here, and I'm going to do a natural join with the country table, which is this table here. So if I run this, you'll be surprised at the result. You get something probably you didn't expect. So let me run that. As you can see, total query runtime, 0 records retrieved, but it's displayed the names of the columns, but no rows. The reason the query result is empty is that both tables have a common column name called last update, which cannot be used for the join. However, the natural join clause, this one, just uses the last update column. Okay, so you can see what I mean by you can sometimes get unexpected results. In this lecture, I have explained how to use the natural join to retrieve data from multiple tables. Thanks for watching and bye for now. Hello and welcome. In this section, you will learn how to use the PostgreSQL aggregate functions. What are aggregate functions? Aggregate functions are used to perform a calculation on a set of rows and return a single row. So when you use aggregate function, the output will always be a single row. Aggregate functions can be used in a select statement. They can be used with the having and group by clause. When you use aggregate functions with the group by clause, the group by will first divide the result set into groups of rows, and then the aggregate functions will perform a calculation on each group. So in this section, we'll be taking a look at the basic aggregate functions that you'll find in PostgreSQL and also in other relational database management systems. So we'll be covering the AVG, which is used to return the average value, the count, which is used to return the number of values, the max, which returns the maximum value, the min, that returns the minimum value, and the sum, which returns all or distinct values. So I'll be taking you through each of these basic aggregate functions in separate videos. Hello and welcome. In this video, you will learn how to use the PostgreSQL AVG function to calculate average value of a set of rows. The AVG function is basically used to calculate the average value of a numeric column. What that means is that the column within the table, the rows within the table that you are applying the AVG to, that column must be a numeric column in data type. The AVG is one of the most commonly used aggregate function. It can be used in a select statement, with a group by clause, and also with a having clause. So let's take a look at the syntax. AVG also ignores null values. So whereby you have null values in a set of rows that you are applying the AVG function to, it will ignore the null values. So this is what the syntax looks like. You basically indicate the name of the function, which is AVG, followed by the column you are applying the function to. I'm just loading up the PG admin. When you load up the PG admin, you may get a prompt like this saying you are currently running X version, and it tells you the current version because this PG admin tends to be updated fairly frequently. So if you get this pop-up, do not worry, you can upgrade it if you want. But I'm going to leave it for now because it's not going to impact on the course. So I'm just going to click on the X to get rid of that, and I'll upgrade it at my own convenience. So first thing you do when you're logged into the PG admin is to log in to the Postgres server if you haven't previously saved your password. So click on the plus and click on the plus again, and you get the prompt to pop your password in. So once you've entered your password, you can save it if you wish to do so. That way it doesn't prompt you all the time. And then click OK. And once you're logged in, it will tell you the server is connected. You get this message here. And then expand the database. Let's see what data. I currently have 3 databases. So the database I'm going to apply the function to is this DVD rental. So right click on that and click on Query Tool. The Query Tool basically contains the editor where we'll write our code. This is the editor, and this is where the output of the result of the query will be rendered. And this here, you can resize it if you wish. If you want more space on the query window, just resize that. All right. So you can see also here on the title bar, it's got the name of the database that you are executing the queries on. So it's got the DVD rental, which is this database here. So any query I write will execute against this database. So I'm going to do a quick query on a table within this database. So if you expand the schema, you will see the public schema. And within the public schema, you will see a list of objects. So we want to click on the tables object. That will give you all the tables for this database. So the table I want to look at is this table here called film. If I click on the plus sign, we can see the columns. If I click on the plus, so these are all the columns for this table called films. So before I actually apply the AVG function, I like to run a quick query on the table to see the columns. So here's a simple query. Just select statement. The asterisk means it will retrieve all these columns and the rows from each of the columns. From here indicates the table is getting the columns from. Name of the table is film, which is this one here. So I'm going to execute by clicking on this lightning bolt, and that will give me output in here. So it tells me 1,000 rows were retrieved from this table. So I've added a block of query here, this block here, and what this query is doing basically is going to find the average replacement cost. I've got a column here called replacement cost. So it's going to find the average, and I'm enclosing this AVG function inside a round function. The round function is basically going to round it up, round the result to 2 decimal places. You notice here, I'll put a comma and I'll put 2. That means it will round the result in 2 decimal places, and this will be the column that will be outputted in the result here. So I have a temporary column called AVG underscore replacement cost, and under this temporary column, it will give me the average for this column. So let me execute that by selecting this and clicking on the lightning bolt, and that will give me the average. There you go. So I've got 19.8. You can see it's rounded to 2 decimal places because I've used the round function to round it to 2 decimal places. So this is a basic, simple example of using an AVG function. So in this simple example here, I've used the AVG just to compute the average on a column. So I'm going to show an example where I'm going to use the AVG in combination with the group by clause. When you use AVG with the group by clause will divide the results into various groups, and then the AVG is applied to those groups. So I'm going to show you how that works now. So I've added the query here. So in this example query here, I'm calculating the average value of a group. So I'm using the AVG function with the group by clause. So what's happening here, the group by clause will divide the rows of the tables into groups. Then the AVG function will be applied for each group. So what I'm doing in this group, in this example here, I'm calculating the average amount paid by each customer. Okay, so let me execute this and you will see it will output. So you can see here, because of the group by, we're able to group we are able to divide the rows of the table into groups, and then we apply the AVG function. That's why we're getting this result. So you can see the AVG amount on here on this side applied to each of the groups. So I've also used a table join. So you see the inner join here. Joins basically allows you to relate data in one table to data in another table, and I'm using an inner join here, basically which I'm using to join the customer table to the payment table. So I've got a table called customer. If you look in the list of tables here, there's a table called customer, and there's also one called payment. So this is what I'm doing here. I'm joining the customer ID from the customer table to the customer ID on the payment table. And then once I've joined them, I'm using the group by to divide them. I'm also using an order by. I'm ordering by the customer ID. So that's why we have this output here. So I've illustrated how to use an AVG function with a basic select statement and also with a group by clause. Next, I'm going to show you an example how to use AVG with the having clause. So here I've got a query I've added on using the AVG with the having clause. You can use the AVG function in the having clause to filter the group based on a certain condition. For example, all the customers, I can get the customers who paid the average payment bigger than $5. You can see here, say greater than. So if I wanted to get all the customers who's paid larger than $5 5 US dollars. I'm using the greater sign here to indicate that. I can use the AVG with the having clause. So let me execute the query and you'll see what I mean. If I click on that, and that will give you, you can see the output is returned 20 rows. Notice here I have used the to_char expression. Basically what that does, it is used to convert the timestamp. It can convert the timestamp. It can also convert an interval, an integer, a double precision, or a numeric value to a string. So you usually, what I'm doing, I'm just converting a value to a string using the to_char expression. So this is how you use the AVG in combination with the having clause. You can also use the AVG with null values. Basically, a null value is a value that is unknown. So if you are applying AVG to a column that contains null values, the AVG will ignore the null values and compute based on other values, other numeric values within the column. So that's it for this lecture on the AVG aggregate function. Thank you for watching and bye. Hello and welcome. In this video, you will learn how to use the PostgreSQL count function to count the number of rows in a table. What does the count function actually do? The count function basically returns the number of rows that matches a specific condition of a query. So let's take a look at a typical syntax for writing a count function. So this is what it looks like. So within the select statement, you indicate the count function followed by the table that you are performing the count operation on. Notice that inside the parentheses here, we've got an asterisk. What the asterisk means basically is that when you use the asterisk inside the count parameter, that means you're counting all the rows from all the columns within the table. If you don't use the asterisk, you can be specific. So you can actually specify which column within a table you want to perform the count on. If you don't do that, then the asterisk will perform the count operation on all the columns and rows within that table. So I've added a very basic query here to perform a count function. So we're using the select statement followed by the count function, and we are counting. Because we put an asterisk in there, that means it will count all the columns from this table called film. Okay, so all the columns, it will return all the rows from all this column here. If I can be specific and remove the asterisk and just pass in the name of the column. So I can pass in maybe this column and say, give me the count. But because I've used an asterisk, it will be applied to all the columns. So let me execute this so you can see the output. And it will give me, you can see it's returned a count of 1,000. So I know I've got 1,000 records in this table called film. I've added another query here, and basically a more specific query. So what I'm doing in this query here, I am getting the number of drama films with this query. So I'm being specific here. So I'm selecting a count. Okay, so it's going to count all the drama films from the film table, and I'm joining the data from a table called film category, which is this table. So, and then I'm using the film ID, using that from that table, and I'm doing an inner join from the category table. So I've got a table here also called category. Okay, so I'm getting this ID, category ID from the category ID from the category table, and then I'm using a where clause as a filter, and where the category is 7. So it's going to look for an ID that matches that category ID of 7 from this category table. Don't forget, I'm joining these two tables. I'm joining the table called film category, and I'm using the film ID from the film category, and then I'm using the category underscore ID from the category table. So this table here is the category table, and if I expand that, you will see that the category table has got a category ID, and I've also got a film category. All right, so there's a film category, which is this, which contains the film underscore ID, which is this. And there is another table called category. If I expand that, and within this table called category, we've got a category ID. So I'm using the category ID from this category table and using the film ID from this film table. So I'm joining data from these two tables, and then I am using the where clause to filter the data, so it will only return the data where the category ID matches 7. So let me execute that query, and you will see the output. So you can see it's giving me 62. So there are 62 films, okay, that matches this criteria. So do I know that I've got 52 drama films that matches the criteria I have set. So this is another way you can apply the count aggregate function. The main function of the count is to count. It gives you a total count of a row based on the criteria you have set in your query. I have added another query here where I have used the count function with a distinct keyword. The distinct basically is used to remove duplicate. So wherever you have duplicate, the duplicate will be removed, and the function will be performed only on the unique values. So I've got a table here called payment. So let me just see. Yep, I've got a table here called payment. So that's what I am applying the count to. I only want the amounts that are distinct. Before I actually run this query that includes the account, I want us to see what we've got in this table first. This table called payment. So I'm going to run that query first, so we can see if we can spot the duplicate values. Okay, so you can see here where this query here, I'm doing it on the amount. You can see this is the amount here. We can see a lot of duplicates. You can see 799, 799. You got a lot of duplicates here. So by using the distinct, it will only show one instance of a duplicate number. That's why we're using the distinct here. So it's going to skip anywhere there are duplicates. You can see we've got a few duplicate values. You got 4.99 there, 4.99, 2.99. So you got, quite a few duplicates here. All right, so now that you've seen what the table contains, let's run the function and click on that. And you can see it says returns a value of 19. So it's done a count based on the unique values. By using distinct, it will only count the unique values. So I've got another example I've added here. This time I'm using the count function with a group by clause. So I'm using this to get the number of payments by customer. all right, using the group by clause. And what the group by clause is going to do is going to group the payments into groups based on their customer ID. I've specified it here based on the customer ID. And once it's done that, I will then use the count function to count the payments for each group. That's basically what this query is going to do. So let me highlight and execute. So you can see here the group by has been used to separate the payments into groups. So it groups the payments into group based on the customer ID, and then I've applied the count function. So we can see here the customer ID is this, and this is the count, and so on. So the counts are on this side, and the customer ID is on that side. So that's how you use the count in combination with a group by clause. So we have seen how the count function works with a group by. Now I've added a query here, this block here of code, that will illustrate how to use the count function in combination with the having clause. So when the count function is used with a having clause, it is used to apply a specific condition to the groups. You can see I've used, when you're using the having clause usually comes after the group by clause. So here we're using the having clause to apply a specific condition to groups. So for example, here I am returning the customers who have made more than 40 payments. Okay, that's why I've used the greater than sign. So let me execute the query. I'm just going to highlight that and click on the lightning bolt, and that will, so you can see this is what has been returned. It matches the criteria I have set. So it has returned customers who have made more than 40 payments. So that's basically how you use a count function in combination with a having clause. So in this lecture, I have explained how to use the PostgreSQL count function to return number of rows in a table. Thanks for watching. Hello and welcome to this video. In this video, I will be explaining how the PostgreSQL max function works. The max function basically is an aggregate function used to return the maximum value in a set of values. So let's take a look at a typical syntax for expressing a max function. So this is what the syntax looks like. You start with the word or the name of the function itself, and then inside the parentheses is where you enter the expression. The expression could be a column within a table. So let's take a look at some examples of how the max function works. I have added a very basic script here just to show you how the max function here works. So in this example, the max function is used to return the maximum replacement cost of films. All right, so the column I am applying the max function to is to a table called film, which is this table here, and within that table, the table has a column called replacement cost. So this is the column this is what is going to be the expression. This is what the function is going to compute on. So let me run this query. and you can see the output. So that's the value. So this is the maximum replacement cost for the film. So once a film is lost, say someone loses a film or something, this will be the maximum replacement cost. I've added another query here, this block of query here. Basically what this query is going to do is going to find out the maximum replacement cost for a film. So if I wanted to get the films, I'm trying to find out here all the films with their maximum replacement cost. So I'm using the select here to select the film ID, which is this column here. Selecting the title. So I'm selecting two columns from the film table where the replacement cost, which is this column, I'm using which equals to I'm using a subquery here. So we're getting the result of one query and using that in another query. And then the second query here, we're using the max function based on the output, selecting the max function based on this replacement cost from the film, and we're ordering it by the title. So let's check this out. I'm going to highlight that and click execute, and that will give me, so this is it gives me a total of 53 rows, which shows the film ID and then the title. So with this query here, I told you I used the subquery. So the subquery returned the maximum replacement cost, which then used by the outer query for retrieving the film's information. So we did the first query. What the first query did is to return the maximum replacement cost, and then we use the outer query to retrieve the film's information. So when you're using a subquery, it will always return the output for the outer query. So we did the calculation first, and then we did this bit here. We selected this query, we ran this query. Hence we have the output for the film ID and then the title, because this query here is computed first, which is the inner query, and then the outer query is output is computed. That's why the result here is showing the outer query, but we've already done the calculation using the inner query. I have added another query here, this block of query here, again just to go over how to use the max function in a subquery to get other related information. So in this example here, I am using the information together with the maximum payment. All right, so I'm using a subquery here. So what we're doing here, the subquery gets the maximum payment, and then the outer query selects all the rows with the amount that is equal to the maximum payment returned from the subquery. All right, so in a subquery, the outer query is usually the first one, and this one here is referred to as the inner query. So I'm using the way I've used the query and the subquery here. The inner query, which is this one here, is used to return the maximum payment. All right, and then the outer query, which is this one here, selects all the rows with the amount that is equal to the maximum payment returned from this subquery here. So let me execute this block of code and you can see the output. The reason I keep highlighting this is because I've got other queries on the editor. I don't want them all to execute, so I have to highlight the one I want to execute. So I'm going to click on that, and that will give me, is returned 8 rows All right, so that's what is. We've got 8 rows here. So that's how you use the max function in a sub query. I have added another block of query here, this query here, basically to illustrate how to use the max function with a group by clause. So what I'm doing here, I'm getting the maximum value per group. All right, so the query is doing here is going to get the largest payment paid by each customer. So we're using the group by clause to group the customers by their ID, and then we are using the max function to apply to those individual rows grouped by the IDs. So let me highlight this and run this query, and you can see that each customer ID will have the maximum amount. You can see here, this is the max function, and this is the customer ID. So that's how you use the max function in combination with a group by clause. I'm going to add another query which will illustrate how to use the max function in combination with a having clause. When you are using a having clause, the having clause is used after the group by clause. So I've added this block of code here to illustrate how the max aggregate function works with a having clause. So what this query is doing basically is that we're using the having clause to apply a filter for the whole group. So we've already used the group by to group the customer IDs into group. We're now using the having clause to apply a filter for the entire group. So what this query will do is going to select only the biggest payments paid by each customer, and the biggest payments are greater than 8.99. all right, so we find out the biggest payments paid where the payment is greater, so the payment has to be greater than 8.99. So let me highlight and run this query, and we can see. So right, so this is it. So this is the output here. So we've got, it has to be 8.99 or more, not less than. So you've got 8.99, 9.99, and so on. All right, so it's got to be greater than or equals to 8.99. So that's basically how you use the max function in combination with a having clause. And when you're using a having clause, usually there is a group by already present. So the having clause is used to filter, to apply a filter to a where a group by clause has already been used. So that's it for this lecture. In this lecture, I explained how to use the PostgreSQL max aggregate function to find the maximum value of a set of values. Thanks for watching, and bye for now. Hello and welcome to this video. In this video, I'll be explaining how the PostgreSQL min function works. So the way the function works is opposite to how the max function works. The min function basically is used to return the minimum value in a set of values. Let's take a look at the syntax for expressing or writing a min function. So inside the select statement, you add the function, which is min, and then in the parentheses is where you specify the column you are applying the function to, and then you indicate the database table. So let's take a look at some examples. So this is a very simple example here. We're basically applying the main function to a table called film, and inside that table we are applying it to a column called replacement cost. So we want to find out what the minimum replacement cost will be if a film is lost. So I'm just going to highlight that and click on this bolt here, lightning bolt. So it tells me here that the minimum amount is $9.99. So that's the minimum replacement cost. I've got another example here of using the main function in combination of a subquery. So we're using a subquery here. Subquery, basically the way the subquery works is that it uses the result of the inner query. Once the inner query has been executed, the outer query will now work on the result of that query. So we've got two select statements here. That's why it's a subquery. This is the first one, which is called the outer query. So we're selecting the film ID, the title, which is film ID title from the film table, where the replacement cost equals to. So basically what it's saying is that when in a subquery, the inner query is executed first. So what it will do this block of query first, it will do a select on the replacement cost, which is this column here. So we are applying the main function to this replacement cost from the film table. We're ordering it by the title. Once that result gets computed, then the output of that result is not displayed here. This outer query here will now use that result and then select the film ID and the title from the output. Okay, so if I run that now, you will see the output based on, you can see here it doesn't give you any minimum value. What it's giving you here is a film ID and the title. All right, and because this output here has already used the result from the inner query to perform the main function, and then it passed the result onto the outer query, which has now displayed this output. Again, I've got another simple query here. This query, the queries I'm using here is identical to the queries I used in illustrating the max function. So a lot of it is the same. All I'm changing is the name of the function. Again, here, this is a typical subquery where we use the result of the inner query and for the outer query. So here we have two select statements. The first one here is what is known as the outer query, and this one here is what's known as the inner query. So we do the way the subquery works. It does the inner query first. So it will select the amount, all right, and then apply the main function to the amount. So once it's applied the main function to the amount, we're referring to this. There's a table here called payment. Sorry, we're working with this table here called payment. If I expand the columns of the table, there is a column here called amount. So we are applying the main function to the amount from this payment table. Once that has been done, it doesn't output the result here. It passes the result onto the outer query, which then uses it to select all the columns from the payment. So when I output this query, it will show all these columns from this payment table. So let me highlight it, and then you can see that. Give it a few minutes. So you can see here all the columns of the table called payment is represented here or in this output. Okay, because we've used the result from the inner query that did the main function and passed it on to the outer query, which then used this query here by selecting star from which returned all the columns and rows from the payment table. So that's how you use the main function in combination with a subquery. So here I've got a simple example here of how to use the main function in combination with a group by clause. So again, I'm selecting the customer ID from the payment table, which is this payment table here, and we've got the customer ID, and I'm applying the main function to this column called amount from the payment table, and then I'm grouping it by the customer ID. So the way this will work, the group by will split all the rows according to the customer ID and then apply the main function to that. So let me run this query and you can see what I mean. So there you go. So it has split this group by here, has split all the customer ID here. So this, if I expand this, you see this says customer ID. So split the customer ID into their own groups and then apply the main function to each of the group within the customer ID. So that's how you use the main function in combination with a group by. Next, I'm going to illustrate how you use the main function in combination with a group by and a having clause. So this is a query here that includes a main function being used in combination with a group by and a having clause. You can see the group by. So the group by here is by the customer ID. So this query again is identical to what I use in the max, illustrating the max function. I've just changed the name of the function. So what the having clause does basically is filter the group whose minimum value matches a certain condition. And the condition I've set here is that the minimum value must match this condition, which means less than 8.99. All right, so let me run this query and you can see the output. So it will return anything that is less than 8.99. There you go. All right, so that's basically how you use the main function in combination with a group by and a having clause. Many thanks for watching and bye for now. Hello and welcome to this video. In this video, I will be explaining how to use the PostgreSQL sum function. The sum function basically is used to calculate a sum of values or distinct values. So when using the sum aggregate function, it will return the sum of values or distinct values. Distinct basically means unique. So whereby you're using it with distinct values, it will remove duplicates. Let's take a look at the syntax. So this is what the syntax looks like. You start with the name of the function, which is sum, and then you use distinct to indicate that you are applying the function to a distinct value within a column. When you're using the sum aggregate function, it ignores null values. So it means the null values are not considered in the calculation when using the sum function. A null value basically is a value that is unknown. You don't know the value. That's why it's referred to as a null value. I have added a block of code here. So this query here basically is illustrating how the sum function works. I've also used it with a group by clause. So what this statement is doing here is using the sum function to calculate the total length of films grouped by the film's rating. All right, so I'm grouping the film by their ratings and then applying the sum function to each group, and then I'm ordering it using the order by clause by the rating. So it's a very basic query. So let me execute so you can see the output. So this is it basically. So we are ordering by the rating. So this is a rating and this is the sum. So we're using the group by to split it into different types of ratings. So we've got the G, PG, these are the ratings which have been split using the group by, and then I apply the sum function to each of the groups, and that's the output. I have added another block of query here. This block here basically is slightly similar to the previous query. What this query is doing here is going to return the top 5 customers who paid the most. You can see I've used the limit here keyword. That means it will limit the rows to the top 5, and I'm ordering it by this column here. So basically this is it. I'm selecting the customer ID from the payment table. I've got a table here called payment. So if I just expand the list of tables, you can see here I've got one called payment, and I'm using the amount. I'm applying the function sum to the amount column, and I'm going to use an alias table. So it's going to output it as total. Total is an alias. I've used the alias by using the AS, which indicates when the output is done here, it will have this label on the column. This is just a temporary label on the column. So, and I'm getting the details from the payment table. I'm grouping this I'm grouping the customer ID. So what the group by will do, it will split the customer by their ID and then order by this column here, this column I've used here, in a descending order, and I'm limiting it to the top 5 customers. So let's check that out. I'll highlight and run that. So it should only output 5 rows. You can see here it's giving me 5 rows based on the customer ID. So I've got the customer ID column. If I expand that, you can see customer ID, and then total, which is this column, alias column I've used here. So that's basically how you use it with a group by. So next I'm going to show you how to use the sum function in combination with a having clause. So when you use it with a having clause, you also have to have the group by involved. So I've added this block of query here, and basically what that query is going to do is going to filter the sums of the groups based on a specific condition. So I'm using the sum function in the having clause. You can see the sum here, I'm using it in the having clause, and I'm applying that function to the amount column. There's a column here inside the payment table called amount. That's what I'm applying the function to, and using a certain condition. The condition is where the amount is less than $200. So this query here will return only customers who paid more than $200. So let's check this out. I'll highlight the query and click on the lightning bolt, and that will output. There you go. So it has returned 2 rows. So there's only 2 rows that matches the criteria I have set of customers who have spent more than $200. You can see this customer here spent 211. This customer spent 208. So that's basically how to use the sum aggregate function. Thanks for watching, and bye for now. Hello and welcome to this section on analytic functions. Analytic functions are also referred to as window functions. What are analytic functions? Analytic functions are functions that will compute an aggregate value based on a group of rows. They are similar to aggregate functions, but the key difference between analytic functions and aggregate functions is that, unlike aggregate functions, they can return multiple rows for each group, while aggregate function returns a single result. So that's the key difference between a window or analytic function and an aggregate function. The term window basically describes the set of rows on which the window function operates. So a window function will return a value from the rows in a window. A window function also performs a calculation across a set of table rows that are somehow related to the current window. So just to summarize, a window or analytic function will compute an aggregate value based on a group of rows and can return multiple rows, in comparison to aggregate functions that will compute but return only a single value. Let's take a look at a typical syntax for a window or analytic function. So this is what the syntax looks like, and I'll try and explain as much as I can. The window, so we have the window function, and then we have the arguments, first argument, second argument. So this is the window function. You can use any built-in or user-defined aggregate function as a window function. In addition to that, you can use PostgreSQL built-in window functions. So PostgreSQL has some built-in functions such as row number, rank, dense rank, and so on. I'll be explaining that in the next slide. And here we've got the over clause. The over basically is very instrumental. This is what makes the whole thing analytic. So what the over does, it determines the partitioning and the ordering of a row set before the associated window function is applied. All right. So the over clause defines a window or user specific set of rows within a query result set. Yeah. And then the window function will compute a value for each row in the window. The partition by here, this partition by is basically used to divide the rows into groups or partitions. If you omit the partition by clause, what will happen is that the whole result set is then treated as a single partition. So if you want to partition things or divide things, best to use a partition by, or the function will treat everything as a single partition. Next here we have the order by here. This order by clause basically is used to sort the rows within a partition. So what happens? The window function will process the rows in the order specified by the order by clause, especially for the window functions that are sensitive to the order. Okay, because there are window functions such as the first underscore value and the last underscore value and so on. So if you have Windows functions like that, then the order by is important in the expression. So let's take a look at some common Windows or analytic functions. We'll be covering each of them in separate lectures. I just want to highlight them here. So we've got the row number, we've got the rank, we've got the dense rank, the first value, the last value, and then we've got the lag and the lead functions. So we'll be covering them in separate lectures. Thank you so much for your time. Take care and bye for now. Hello and welcome. In this lecture, I will be creating a couple of sample tables that I'm going to use to illustrate how the analytic window function works. I haven't got any suitable tables at the moment, so that's why I'm going to create some sample ones. The queries I'm going to use will be available for you to download under the resource page for this lecture. So I've got a couple of queries here that I'm going to use to create a couple of tables. So I'm going to create two tables. One is going to be called product underscore groups, and the other is going to be called product. So basically it's going to have group ID as a column. You've got the 0, basically gives it automatic numbering, and that's going to be the primary key. And then we've got a group underscore name with the voucher data type. Not null means that's a constraint. That means that field cannot be empty. So here the same thing, we've got the serial for the data type, which gives it automatic numbering. We have the price in decimal data type. We've got a group underscore ID column. Again, here we've got a foreign key called group ID. Foreign keys basically means it has a corresponding, is related to this table. Okay, so let's go ahead. I'll create the first one. I'll highlight that and click on this lightning bolt, and that should create. Make sure you're creating this table in this DVD rental database. So make sure you're inside your query tool, make sure it's highlighted DVD rental. So it will tell you what database you're creating the table on, because it will highlight the name of the database there. So it tells you query returned successfully. Let's run the other query to create the second table. I'll click on the lightning bolt, and you can see it's created two tables. So we now have two tables. So let's come down here to the DVD rental and refresh the list of tables. We should see the two tables we created. Let's check that out. You see product groups and product. Excellent. So the two tables are there. The tables are empty at the moment, so I need to insert some sample data. Again, the sample data will be available for you to download under the resource page for this lecture. All right, let's insert some data into the products under groups table, which is this table here. And these are the values. So I'm just going to highlight that and click on the lightning bolt, and that will tells me it's inserted 3 rows. So let's insert some data into the other table, which is the products table. So this is these are the columns, and these are the values that I'm going to load into that table. So I'm going to highlight it. The reason I'm highlighting it because I've got other queries in the editor, so I don't want them all to be executed, just the one I've highlighted. So I click on the lightning bolt, and that would say it's inserted 11 rows or records into the table. Okay, let's quickly query the tables and just to check that they have got some data. So I'm going to query this table here called products. So I'm going to highlight that query and click on the lightning bolt. Excellent. So we've got 11 rows in that table. That is good. Let's try the other query. Select that and click on that. Excellent. We've got 3 rows in that one. So we've got some data in both tables. So I can now begin to illustrate with analytic functions. Before I wrap up this lecture, I just want to do a quick test on using an aggregate function so that you have a clear understanding the key difference between an aggregate function and an analytic function. So before I start illustrating with analytic, let me quickly run through with an aggregate function. So the aggregate function I'm using here is AVG. So I'm selecting the price from this table here, the table called products, which is this table. If I expand the column, there is one for price. So I'm doing an AVG, I'm computing the function, running the AVG function on the price column, which is from the products table. So this will return, it will work on all the rows, but it will only return a single value, which is the key difference between, you can see it's returned just a single value. When I start illustrating with analytic function, you will see that analytic functions can perform the same calculation, but will return multiple, return multiple results in comparison with the aggregate function that returns just a single output or a single result. So that is it for this lecture. We've got our table set up. We got some sample data in. So we'll start illustrating with some analytic function from the next lecture. Thank you. Bye for now. Hello and welcome to this video. In this video, I'm going to illustrate how to use an AVG aggregate function as a window function. In the previous lecture, I illustrated a simple AVG function, which is an aggregate function. So this is the query I use. So I'm going to run that again so that you can see that an aggregate function returns a single value. So it will perform the function on all the rows within the table, but will return a single result value. An an analytic or window function behaves in the opposite direction. It will perform the same calculation, but can return multiple values or multiple rows. So in this query I've added here, the query is going to return the product name, the price, the product group name, along with the average prices of each product group. So in the query, the AVG function here is working as a window function that operates on a set of rows specified by the over clause. So what that means, each set of rows is called each set of rows is called a window. So this over here is what gives this query an analytic edge. So we are getting the data from this table called products, and we are doing a join, a simple inner join with this table called products underscore groups, using the group ID from that table. All right, so let me highlight this, run the query, so you can see the output. You can see in comparison with the aggregate function, this has returned, you can see multiple values for each group. So what actually happens behind the scenes, PostgreSQL will sort out the rows by their values in the group underscore name column. The partition by will then group the rows into groups. Then the AVG function calculates the average price for each product group. Okay. A window function will perform calculation on the result set after the join, or in cases where you have the where or the group by or the having clause complete. Okay, so it will do all that, but also before the final order by clause. So if you've got several order by clause, the window function will kick in before the final order by clause, but it will do so where there's a join. After the join, once the result has been calculated after the join, or where there's a where clause, or where there's a group by clause, or a having clause. Once all that is completed, it will then apply the window function. So that's it for this lecture on using the AVG aggregate function as a window function. In the next lecture, I'm going to take a look at the row number function. Thanks for watching. Bye for now. Hello and welcome. In this lecture, I'm going to illustrate how the row underscore number function works. So what is the row number function? What does it do? The row number function basically allows us to assign numbering to the rows of the result set data. So it will assign a running serial number to rows in each partition. So I've added some query here to illustrate how the row number function works. The row number function basically is going to assign a unique integer to each row in a result set. So let's quickly take a look at a basic syntax for the row number function. So this is what the syntax looks like. So it will use this syntax to assign integer values to each row in a result set. The set of rows that the row number function operates on is called a window. So the partition by this clause will divide the window into smaller sets or partition. Okay, but if you don't specify the partition by clause, the row number function, the row number for each partition will start with 1 and increment by 1. That is if you don't specify the partition by clause. Because the partition by clause is optional to the row number function, you can omit it, and the row function will then treat the whole window as one single partition. All right. Notice I've got an order by here. The order by clause, which is inside the over clause, will determine the order in which the numbers are assigned. Before I actually illustrate with a query, I just want to quickly run a quick query on the product table so we can see the content. So I'm just going to run that so we can see. So this is the content of the products table. So it has 11 rows in total. So I've got a basic query here, and I've deliberately left out the partition by clause because that is optional. So I've not used a partition by. So let me run this query and see the output. So this is the output. So because we did not use the partition by clause, the row number function has considered the whole result set as a single partition. All right. The order by clause sorts the result set by the product ID. Therefore, the row number function assigns the integer values to the rows based on the product ID order. So I have modified the query, and this time I have included a partition by clause. So we're using the partition by clause to divide the window into subsets based on the values in the group ID column. So what's going to happen in this case is that the row number function is going to assign 1 to the starting row of each partition and increases by 1 for the next row within the same partition. By doing it this way, it makes it unique. The order by clause will then sort the rows in each partition by the values in the product name column. Okay, so let me run this query and you see the output. So let's give it a few minutes. Yep, so you can see what I mean. By using the partition by, you can see we have a different output. All right, so I'm going to do one more example, but this time I'm going to use a distinct with it. Distinct basically enables you to eliminate duplicate values. So you can see we have a lot of duplicates here, but if I use a distinct, it will remove the duplicates values. So I'm using the row number function this time with the distinct keyword. I'm using a select distinct, but I'm using it on a different table. I'm using it on the same table, but this time I'm ordering it by the price column. Okay, so let me run this and you see it will remove all duplicates values. So you can see here there are no duplicates, so all these numbering are unique. All right, before I wrap up this lecture, I just want to show you one more query example. Basically what this query is going to do, I'm going to use the row number function for getting the nth highest or lowest row. For example, to get the third most expensive products. So first we have to get the distinct prices from the product table and then select the price whose row number is 3. Once we've done that, notice here I'm using a subquery. So using a subquery basically uses the result of the first query, and then the outer query performs the operation on that query. All right, so what we're doing here in the outer query, we get the products with a price that equals to the third highest. All right, so let me run this and then you can see the output. It's a fairly long query, so this is the beginning, just in case you didn't catch all of it. That's the beginning and it ends on line 24. All right, so I'll just run through that with you and I'll tell you again what the query is going to do. It's going to find the third most expensive product. So what the query does first is going to get the distinct prices, that is the prices that are unique. It's going to get the distinct prices from the products table and select the price whose row number is 3. Then in the outer query, we get the products with a price that equals the third highest price. All right, so that's the beginning of my query and that's where the query ends. So let me execute the query and you can see the output. There's the result. So that gives you the third highest price. So in this lecture, I've shown you how to use the PostgreSQL row number function to assign integer values to rows in a result set. Many thanks for watching. If you have any issues and if you don't understand the lecture properly, please feel free to contact me. I'll be more than happy to go through that with you again. Take care and bye for now. Hello and welcome. In this lecture, I'm going to illustrate how the rank function works in PostgreSQL. The rank function basically is used to assign ranking within an ordered partition. If the values of the two rows are the same, the rank function assigns the same rank with the next rankings skipped. So if you've got two rows having the same rank, it will assign them the same rank, but it will skip the next ranking. So here is a query I have got to illustrate how the rank function works. So we've got the select statement. We're selecting these three columns from the table called products. All right, so we're selecting the product name, group name, price, and then we're performing the rank function over the partition. We're grouping it by their name and we're ordering it by the price. So this is the product table. I'm also performing a simple join on this other table called products underscore groups using the group ID. Okay, so when you perform a join, you can see this product group here has an identical column called group ID, and the products table also has an identical column called product ID. So it's easy to perform an inner join based on those identical ID columns from both tables. So let me execute this query by clicking on the lightning bolt. So this is the query. So you can see on the query that both in the laptop section, we've got this Sony Vaio and this Lenovo ThinkPad both occupying a ranking of 1 because they have the same price. So they've received the same ranking. The next row you notice is this Dell Vostro laptop. If you notice, the ranking has skipped because these two occupied the ranking of 1, so it skipped 2 and assigned this one a ranking of 3. So that's basically how a rank function works. Thanks for watching and bye for now. Hello and welcome. In this video, I'll be showing you how the dense underscore rank function works in PostgreSQL. So it's similar to the rank function in that it assigns ranking within an ordered partition, but the difference is that the ranks are consecutive. What I mean by that is that the same ranks are assigned to multiple rows and no ranks are skipped. When we did the rank function whereby there is a tie where two rows have the same rank, it skips the next numbering and it skips the next rank and then assigns the next available one. With the dense rank, it doesn't do that, so it will have multiple, it can have multiple rows with the same ranking. So let's take a look at an identical query that we use for the rank function. This time I'm using it for the dense rank, and I've got the partition by and then the order by as well. And I've got a simple join here where we're joining using the group ID from this table, joining to the group ID of the other table. All right, so let me run this query and we can see the difference. All right, so you can see here straight away that when we did the rank function, whereby there's a tie, it will skip the next ranking and, and give the other ranking available. So you can see here, but with the dense rank, the ranking is not skipped. So you can see multiple rows can have the same ranking. So these two share ranking of 1 and so on. And then it doesn't skip for example, it hasn't skipped to 3 like it did with the rank function. So that's the main difference between this function, the dense rank, and the rank function, in that the dense rank does not skip a ranking, while the rank function skips a ranking if there are rows that have the same ranking based on a criteria. In this case, the criteria is on the price. So these two have the same price, so they're both ranked 1. So that's it for this lecture on the dense_rank function. Thanks for watching. Bye for now. Hello and welcome to this video. In this video, I'm going to illustrate how the first underscore value function works in PostgreSQL. So what is the first underscore value function? What does it do? Well, the function basically is used to return the first value from the first row of the ordered set. So for example, if you wanted to return the lowest price per product group, you can use the first value underscore function to achieve that. So let me illustrate with a query. So this query here is going to use the first underscore value function to return the lowest price per product group. So it's just a basic query here. I'm selecting these 3 columns from this table here called products. Okay, and I'm applying the first value function to the price. And we're using the over clause here and the partition by, and we're ordering by the price as the lowest price group. So once the function has done its bit, it will display the lowest price per group. We're also doing an inner join using the group ID on the table called products underscore groups. So let me go ahead and execute this query, and we can see the output. So it's returned 11 rows. So you can see the query now is return the lowest price per product group. So let me just expand this column by dragging it. All right, so this is the lowest price per product group. Okay, so that's basically how you use the first underscore value function. Thanks for watching and bye for now. Hello and welcome. In this video, I'm going to show you how the last underscore value function works. This window function works in the opposite way the first underscore value function works. So what does the last value function do? It basically returns the last value from the last row of the result set. So let me illustrate with a query. So I've got a query here, and this query basically is going to be used to return the highest price per product group. Okay, so we've got standard query stuff here. We've got to select the columns. We're using the last underscore value function over the price here. We've got the over clause. So these are all standard query stuff. So, but what is different here is this line 8 and 9. The range between unbounded preceding and unbounded following. What does that mean? Basically, by default, the window clause is range between unbounded preceding and the current row. So basically the lowest possible bound, which is the unbounded preceding, refers to the first row. The current row is referred to as the current row, and the unbounded following refers to the last row. So the rows preceding and following the current rows are retrieved in using the n preceding and the n following, where n is the relative position to the current row. All right. So if you don't specify the between, the window function will implicitly end at the current row. So by using the unbounded preceding and following basically indicates that unbounded references the first row, and then the unbounded following refers to the last row. So the rows preceding and following the current rows are the rows that will be retrieved. So let's run this query and we can see what the output returns. So there you go. You can see the highest here is showing the highest price per group. You can see it's also in order. All right. So with the lowest right at the bottom. So that's how you use the function called last underscore value, which is basically, I've used it here to return the highest price per product group. Many thanks for watching, and bye for now. Hello and welcome. In this video, I'll be illustrating how the lag analytic function works. So what does the lag function do? Well, with the lag function, it gives you the ability to access data from the previous row. So let's take a look at a basic syntax for a lag function. So this is what the syntax looks like. So you have the name of the function, which is lag, and in between the parentheses, you've got the expression, which can be a column or expression to compute the return value. And then we've got the offset. Offset basically refers to the number of rows preceding the lag function of the current row. The default value is 1, and here we've got a default. The default basically refers to the return value if the offset is outside of the scope for the window. If it's outside the scope of the window, then the default value is used, and the normal value for the default is null. Null basically means the value is not known. So I've got a query here that I'm going to use to return the prices from the previous row and also calculate the difference between the price of the current row and the previous row. That's basically what this query is going to do. So most of the stuff in the query here are familiar stuff. So I'm just going to execute that query, and then you can see the result. I'm just going to bring that up a bit so you can see. We can see we've got some null values there because the value is not known. So in this example, I have used the lag function to return the prices from the previous row and then calculate the difference between the price of the current row and the previous row. So this is the output. This is the current previous difference of this is the difference, and this is previous. I'm just expand that so you can see. All right, so these are this is current and that's previous. So that's it for this lecture on using the lag analytic function. Thanks for watching, and bye for now. Hello and welcome. In this lecture, I'll be illustrating how the lead analytic function works. The lead analytic function basically allows you to access data from the next row. So let's take a look at the syntax for the lead function. So it's similar to that of the lag. So we've got the lead function, and inside the parentheses we've got these various arguments. So we've got an expression which refers to a column or expression used to compute the returned value. Next, we've got the offset, which refers to the number of rows preceding the lead on the current row. Then we have the default value of the offset is usually 1. Then we have the default, which refers to the default return value. That is if the offset is outside the scope of the window. The default is null. So whereby the offset is outside the scope, the default is then used, and the value for that default is null. Null meaning you don't know the value. Value is unknown. So I've added this block of query here. Basically, this statement is going to use the lead function to return the prices from the next row and then calculate the difference between the price of the current row and the next row. Again, we're using basic stuff. We've got a simple join here where we're using the group ID. So let me execute the query and you can see the output. I'm just going to bring that up again so you can see. So we can see here we've got the prices from the next row, and it's also calculated the difference between the price of the current row and the next row. So this is a difference for the current row, and this is the next row. So that's the next and that's the current. Okay, that's the difference and that's the next. So that's it. So in this example I showed you how to use the lead function to return the prices from the next row, and then which calculates also the difference between the price of the current row and the next row. So many thanks for watching. Take care and bye for now. Hello and welcome. In this section I will be introducing you to the concept of views in PostgreSQL. So I'll be showing you how to manage views. So we'll be creating a view, you learn how to modify view, and also how to remove views from the database. What is a view? A view is basically a stored query. So it's a select statement that is stored as a database object. A view can be accessed as a virtual table in Postgres. So basically views are a logical table that represents data from one or more underlying table using a select statement. A view is defined based on one or more table, and the tables are referred to as a base table. So you basically create a view from one or more tables known as the base table. So the views themselves do not store any data. They're just there to represent data from the base tables. However, there is a special type of view referred to as the materialized views. So they are the only type of views that actually stores physical data, and they actually refresh the data periodically from the base table. Materialized views have many advantages, and in that they are much faster to access the data, and you can also access the data from a remote server, and also it has caching features which makes it faster to return the data that is being queried. So that's it for the introduction to views. In the next lecture, we'll be looking at how to manage views. So we'll start off by learning how to create a view in PostgreSQL. Many thanks for watching, and bye for now. Hello and welcome. In this lecture, I'll be showing you some of the useful benefits of using a view. Views can help you simplify complex queries. So with a view, you can simplify the complexity of a query, because you can query a view which is based on a complex query just by using a simple select statement. Also, you can use views to hide sensitive information from a table. Okay, so you can hide sensitive information, for example, salary related information. You don't want that to be made available just to anyone, so you can restrict that information using a view. Like a table, you can also grant permission to a view. So for example, you create a table, a separate view with sensitive data, and then you can grant permission to users that you want to have access to sensitive information or specific data. A view also provides a consistent layer, even when the columns of the underlying table changes. You can query a view just like you query a normal table. So the syntax to retrieve data from a view is exactly the same as you would with a normal table. In this lecture, I briefly covered some of the benefits of using views. Many thanks for watching, and bye for now. Hello and welcome. In this video, I'll be showing you how to create a view in PostgreSQL. So we basically create a view using the create view statement. So let's take a look at a simple syntax. So this is a basic syntax for creating views. First of all, you start with the create view clause, followed by the name of the view, which you specify after the create view clause. Then you put a query after the as keyword, which is this as keyword. And a query basically can be a simple select statement or a complex select statement that even includes various type of joins. So first of all, to illustrate how to create a view, before we do that, this is just a simple query. A query is kind of like a complex query to show you different types of joins. So we're joining various tables together to create a query. So one of the advantages of views, for example, if you are querying data from multiple tables often, and you're going to be doing the same thing often, then you are better off creating a view from that statement. So that's what we're going to do, but I just want to show you what the complex query looks like before we create a view from it. So we are using our sample database, which is a DVD rental, and we're going to take a look at 4 tables. So I'll start with the customer table here. We've got a customer table, and which basically stores all the customer related data. So I've got this in my select statement here. I've got the customer table here, and from the customer table I am going to use the customer ID column and the store ID column, which is these two columns here. Notice I've got CU is just an alias. You normally specify an alias inside the from. You can see my from here. This is where I define the alias that I'm using here. So I'm taking two columns from this table called customer. I've got another table called address. If I bring that up, you can see address, and these are all the columns for my address table. The address table basically stores addresses of the customers. So from the address table, I'm going to use three columns: the address, which is this column here, the postal code, this column here, and the phone. So I'm taking three columns from the address. So you can see I've represented it here, and on the I'm using an alias A to represent address. So it tells you that this address is coming from the address table. So these are the three columns I'm picking up from the address table. So another table I want to use is a table called city. This is a city table, which basically stores data related to cities. And from the city table, I'm only going to use one column, which is the city column. So you can see here where it says city, I'm only using one column, which is city. Finally, I've got a table called country, which basically stores data relating to countries. And from the country table, I am using just one column here, which is the country column here, which is as specified here. You can see I've also used a case. A case expression basically is when it will evaluate the script based on certain condition within the case. So this is the case here basically. So when this is it meets that condition, then it will execute, whatever code is there. So that's what this case expression. But you can see how complex this query is, because I'm joining three tables together and I'm using other expressions as well, like case, when, else, and so on. So I'm going to execute this query so that you can see the output. Just click on that, and that should show me the output. Okay, so it's returned 599 rows. So we see how complex this is. So now I'm going to create a view from this complex query, and the view will give me a complete customer data, which would be a combination of data from several tables. So I've added another query here. So this is a query that actually creates a view from the multiple tables. We are using joins here to represent the data from multiple tables. So you can see here we started with the create view statement. I've created the view here, and I've called the view customer underscore master as the name. And basically it's a lot similar to the previous query, which is this query here, but not as complex as it. Okay, it's a bit similar but not as complex. So we're using the create view statement to create a view called customer underscore master, and then we are grabbing basically the same columns I mentioned before in the previous illustration of the complex query. So using the same column names and so on, and we are also using the join as an expression. So the key thing here is that we don't have to, once we've created this view, we don't have to do a join each time we want to query data from this table. So by creating a view, it gives us a more complete customer data. Okay, so all you need to do is just run the query and it will execute the view. So this is the main difference between this and this query, in that the view, we can save the view as a table. It is as a virtual table. So anytime we want all this related data, we just run the view. So let me execute this query, and you can see, I'll click on that, and we should get the same total here. Okay, so it tells you query returned successfully. So this actually creates the view. It doesn't execute the statement, but if I wanted to run this view now, I will query it just like you would a normal table. So the view has been created. If you look on the left hand side here, you should see a section for views. So if you expand that, you should see the view we've just created. You can see we've got a view here called customer_master. If I expand that, you can see the columns. We include all the columns. All these columns are a combination of columns from all the tables we've used in the view. So to execute the view, you just execute it the way you would do a normal table. So I'm just going to do a simple select statement here, which is this one I've written here. So I'm selecting star, means it will get data from all the columns from this view called customer_master. So I'm highlighting it to execute it, and then you can see the output. You can see it's giving me the same output when I ran the complex query. So it's giving me 599 rows. So this is a neater way of reusing a query that you would otherwise normally have to write all the time. So this saves a lot of time writing or reconstructing the data from each of the tables. So anytime I want this type of related customer information, I just come to my view and execute that. So that's basically how you create views. Hello and welcome to this video. In this video, I'll be showing you how to modify an existing view. So what we're going to do, we're actually going to modify a view by appending an extra column to the view. So in order to change a view, you have to redefine the query, and this is the syntax. So basically start with the create. We are creating or we are replacing, followed by the name of the view, and then you specify the query. So what I'm going to do, I'm going to add an extra column to the view we created in our previous video. So I'm going to add an email column to that view. So I'm just going to run a quick select statement so we can take a look at the columns that we have in the view. So that's the name of the view we created in our previous video. So if we look under the view section here, you can see the views listed here under customer_master. So I'm going to run this query and we can see all the columns we have at the moment. So if I expand the view, you can see the columns in the view. So these are all the columns, which are the columns that are displayed here. So the plan for this lecture here, I'm going to change this view by adding an extra column to the end. So I'm going to append it. So it'll be another column. And the column I'm going to add is going to be a column for an email here. So I'm going to add that. So let me add the script that will action that. So I've added a script. This is a query, and you can see here the previous view ended with this column here called seed, which is this one here. So I've had to put a comma there and added another column for the email. You can see this is the email from the customer table. CU basically is the alias I've given to the customer table. So that's what I've used here, CU, to represent the email. So this email column is coming from the customer table. So notice I've used the create or replace. So and notice I've given it the same name. All right. So what it will do, it will replace this view. That's what it's saying, either create or replace. So let's check that out and execute this query. We'll see what happens. So you can see it says query returned successfully. So it has created the view. So now if I run the select statement again, I will expect to see an extra column for email appended to the previous view. So this is the select statement I'm using to query the view. So I'm going to run it by clicking on this lightning bolt, and you should notice an extra column at the end for email. So there you go. So we have been able to modify an existing view by appending to the view. You can also change the definition of a view by using the alter view statement. You can see here I've used the alter view statement. So basically by changing the definition, you can, for example, you can rename a view. So if I wanted to change the name of the view from the current name, which is customer_master, to customer_info, this is the statement I would write to change the definition of the view. Before I wrap up this lecture, I also want to quickly cover how to remove a view in PostgreSQL. To remove an existing view, you basically use the drop view statement, which is this statement I've highlighted here on line 8. So you start with a drop view, and you got to use, you're using the if exists, so that if it will check first if the view exists, then you indicate the name of the view. So you specify the name of the view that you want to remove after the drop view clause. Removing a view that does not exist in the database will result in an error. So to avoid the error, you normally have to add this extra option, which says if exists option. So you need to add that option to the statement so that it will instruct the PostgreSQL database to remove the view only if it exists. Otherwise, it does nothing. That way you avoid getting unnecessary errors. For example, here on line 10, I've just got a single line statement here, basically to remove the customer_info view that, you know, if we got a view called this name, that would be how you would remove it by executing this piece of code. So it's a very simple query for just a drop view clause, checking if it exists, and then you list the name of the view, and that will remove the view from the database. In this lecture, I showed you how to modify an existing view. I also showed you how to alter a view definition, and also how to remove an existing Postgres view. Many thanks for watching, and bye for now. Hello and welcome. In this video, I'll be introducing you to PostgreSQL updatable views. I will be showing you the requirements for updatable views. What are updatable views? For a view to be considered updatable, there are certain conditions that has to be met. So let's go through the condition. The first condition is that the defining query of the view must have exactly one entry in the from clause. Okay, so it must have one entry in the from clause, which can be a table or another updatable view. Another condition is that the defining query must not contain one of the following clauses at the top level. So the clauses includes the group by, the having, the limit, offset, distinct, with, union, intersect, and except. So the defining query must not contain one of the following clauses at the top level. Another condition is that the selection list must not contain any window function or set returning functions or any aggregate functions such as the sum, the count, AVG, min, max, and so on. An updatable view may also contain both updatable and non-updatable columns. If you try to insert or update a non-updatable column, PostgreSQL will complain and give you an error. When you execute an update operation such as insert, update, or delete, PostgreSQL will convert this statement into the corresponding statement of the underlying table. Okay, and also in cases where you have the where condition in the defining query of a view, you can still update or delete the rows that are not visible through the view. However, if you want to avoid doing this, you can use a check option when you define the view. Users who perform update operations must have corresponding privilege on the view, but they don't need to have privilege on the underlying table. So this is important. So users who perform update operations must have corresponding privileges on the view itself, but they don't need to have privilege on the underlying table, which is the base table. However, people who own the views must have relevant privilege on the underlying table. So only the view owner, people who actually own the views, have relevant privileges on the underlying table, which is also the base table from where the view data is coming from. So these are the key conditional requirements for updatable views. Thanks for watching, and bye for now. Hello and welcome to this video. In this video, I'll be showing you how to create a PostgreSQL updatable view. So I've already opened up my query window, and make sure you're on the right database as well. You can see I've got the DVD rental, so make sure yours says the same. And this is the query I have got in here to create an updatable view. So we basically create a new updatable view using the create view statement. So you start with the create view followed by the name you want to call the view. So I've given the updatable view a name of USA underscore cities. All right. And so this view is going to contain the following column. Is going to contain cities. Is going to contain cities in the city table. So we've got inside the DVD rental. If I expand the schema, we have a table called city. So let me just expand the table here so you can see it. So that's the table called city. And if we take a look at the columns, you can see all the columns. Okay. So what we're doing here, we are getting the view contains cities in the city table. All right. This view here is going to contain city. You can see from table. So it's getting the data from this table here called city. Don't forget, a view is just presenting the data in a underlining table or base table. So this city here is known as the base or underlining table. So we are getting the cities in the city tables that belongs to USA. So you can see I've used a filter. So these are the columns from the view, and then you see we've got city, yep, the city here, and then we've got city ID. You can see the two columns we picked up there from this city, where the country ID, country underscore ID, equals to that. So we're using a filter to narrow down the data. We are being specific here by using the where clause as a filter. So let's execute this query just by clicking on this lightning bolt, and hopefully everything works out okay. You can see query returned successfully. So one next thing I want to do is query the view by running a select statement. Before I run this select statement, if you look on the left here, we've got a section for views. So if you expand that, you can see the view we've created is listed there. You can see USA underscore cities. And if I expand that, you can take a look at the columns. Notice we specify two columns, city and country ID. So there they are represented. So the view has been created. Let's just do a quick select statement to see what's in the view. So basically this is a select statement here. So I'm doing a select. Star means it will get all the columns from that table from the view called USA underscore cities, which is this view here. So the reason I'm highlighting it is that I've got other query inside the editor, so I don't want that to execute. So I'm only highlighting what I want to execute. So I click on the lightning bolt and that will execute the query. There you go. So it has generated the query for me, which has 35 rows. So remember that the view only contains cities in the USA. Okay, so it contains cities in the city table that belongs to USA. So this is the output we have got. So what I'm going to do next is I'm going to insert a new city into the city table using the views. Okay, so I've already got the query here. This query here is what I'm going to use for the insert. So what I'm doing here is that I'm inserting a new city into the city table through the USA underscore cities view, which is this view here that I've listed, using the insert statement. So this is the value. I'm inserting a new city called San Jose, and this is the value. That's the country ID here, and that's the name of the city. So let me highlight this query and execute, and you can see here it says it's done an insert, query returned successfully. So if I run a query on the data in the city table, you'll see. So I've got another block of query here, this query here, just to check the data in the city table. So I'm selecting the city. Let's take a look at the city table, which is this table here. So I'm selecting the city, which is this one here. I'm selecting the country ID from the city table where the country ID equals to 103, and I'm ordering by the last underscore update. Okay, and it's going to do that in a descending order. By ordering it this way, you can see here it's ordering it by there's a column here called last update. So let's run that, and it's going to display the data in descending order. So I'll highlight that, and you should see you can see the insert we just made. All right, so called San Jose, that's what we've just inserted using this query here. All right, so now that we can see the new entry that we inserted into the city table, we can also go ahead and delete the entry that we added using the view, which was called USA_city. So that's the next thing. Let's go ahead and do that. To delete a row from a table is fairly straightforward. You use the delete keyword from, you specify the view. This is the view, the update table view. And we are selecting where the name of the city equals San Jose. So let's highlight that. That should be a straightforward query. Ooh, okay. I've got an error. Okay, see, I'm not sure if you can spot my error there. You can see the editor's highlighted where I made a mistake. I've left out the corresponding quote here. You can see that's a single one here. I left out this one. That's why it was complaining. And also I can add the semicolon at the end. So I'll try that again. That should work this time. So excellent. You can see it says delete 1. So we've successfully removed the row we insert. So in this lecture, I've shown you how to create a PostgreSQL updatable view. I also showed you how to insert data into the view and also how to delete data from the view. Thanks for watching and bye for now. Hello and welcome to this video. In this video, I will be introducing you to the PostgreSQL materialized views. What are materialized views in PostgreSQL? Basically, they are views that allows you to store the result of a query physically and also update the data periodically. So they are different from the normal views that only represent the data of the underlining or base table. So with a normal view or simple view, they just represent the data. They don't actually store the physical data. But a materialized view actually stores the result of a query physically and also updates that data periodically. Also, a materialized view basically uses caching to catch the results of a complex, expensive query and then allows you to refresh this periodically. So it's a bit similar to what I'd already said, that it stores the result of the query physically and then updates it periodically. So it can even do that with complex queries. Materialized views are very useful in cases where they require fast data access. So we're looking at things like data warehouses or business intelligence applications. So these are areas where a materialized view will come in quite handy. So that's it for the introduction to materialized view. In the next lecture, we will be creating a materialized view. Many thanks for watching and bye for now. Hello and welcome to this video. In this video, I'll be showing you how to create a materialized view. We will be using the create materialized view statement. So this is the statement that can be used to create a materialized view. So you first of all have to specify the view name. Okay. After the create materialized view clause. So after this clause here, you specify the name of the view. And then the second thing you do, you add the query that gets the data from the underlining tables. You do that after the as keyword. Then the third thing you need to do is if you want to load data into the materialized view at the creation time, then you have to put with data. All right. So if you want to load the data at the same time you create the view, you use this with data option. Otherwise, you put with no data option. Okay. In case you use the with no data, the view is flagged as unreadable. So if you use this option with no data, the view is going to be flagged as unreadable. Basically, what that means is that you cannot query data from the view until you load data into the view. So another thing I want to show you is how you refresh data for materialized view. So to load data into a materialized view, you have to use the refresh materialized view statement, which is this statement here on line 7. So this is a statement you need to load data into a materialized view. So assuming that you created a view with this with no data option, then you need to load data by using this refresh materialized view statement. When you refresh data for a materialized view, PostgreSQL locks the entire table. Therefore, you cannot query data against it. All right. So it's very important you know that. To avoid this, you can use the concurrently option. There's another option you can use to avoid the entire table being locked. So you have to restructure your query to this one here, refresh materialized view concurrently, and then followed by the name of the view. So by doing it this way, it avoids the entire table being locked, because if the table is locked, you can't query data against the table. So with the concurrently option, this option here, PostgreSQL creates a temporary updated version of the materialized view. It then compares two versions and performs an insert and an update. Only the differences. Okay, so it compares the two and it then performs an insert and an update only on the differences between the two. You can query against the materialized view while it is being updated. One requirement for using concurrently option is that the materialized view must have a unique index. All right, so it must have a unique index for you to use that concurrently option. But the concurrently option is only available from PostgreSQL version 9.4 and above. So if you got anything above 9.4, then that option is available. You can also remove materialized view using this statement here. I've got on line 12. So you use the drop keyword. So removing a materialized view is pretty straightforward. Just it is the same way as you would normally remove a table. So you use the drop keyword. So basically you use drop and specify the name of the view, just as I've stated here in this statement, and that should get rid of the view. So now that we've gone through all these various examples, let's go ahead and create an actual materialized view. So here I've got some statement here. So this following statement is going to create a materialized view called rental_by_category. All right. So you can see with this view here, I have used the with no data option. All right. So by using the with no data option, that means we cannot query data from the view. If we try to do so, we will get an error. So creating a view is just normal thing like creating a table. So you can see I've used a lot of join statements here in the creation of the view. So we're using a table called payment. So if I go down here, you can see we've got a table called payment. So this is the table I'm pulling information from. So if I expand that table, you can take a look at the columns here. So these are just basic keywords you use in creating a view. You also can use that in creating a data. All right, so I'm going to create this view by clicking on the lightning bolt, and I won't be able to query the view because I've used it with no data option. So what I need to do now is add some data by using the refresh materialize view statement. If you try to run a select statement on the name of this view, you will get an error. Okay, so because we have not loaded any data, so table is locked, you can't query it. So let's populate the view. All right, so we are going to load some data into the view using this statement here on line 15. All right, so this is the statement that will populate the view. So let me just highlight this and run that statement. Click on the lightning bolt and hopefully everything should be okay. It says refresh materialize view, query returned successfully. So now we should be able to query the view. So to query the view, all I need to do is run this simple select statement. I'm selecting star, means it will get all the columns and rows from this view here. The view is called rental underscore by category. So I highlight that and click on the lightning bolt, and hopefully there you go. So it's returned 16 rows. All right, so we've got our materialized view sorted and working okay because we've loaded some data into the view. So anytime you want to load data into your materialized view, you have to use the statement, the refresh materialized view statement, followed by, the name of the view. If you want to refresh the view, the materialized view, using the concurrently option, you will need to create a unique index for the view first. And this is how you would do it. This is the statement you would use to create a unique index for the view. That enables you to use the concurrently option. And then once you've created the index, you can then refresh the data concurrently for the view by using this statement here. And that will enable you to refresh the materialized view concurrently. Okay, so that is it for this lecture. I do apologize, it is taking quite longer than I expected. I just wanted to get in as much as possible. Okay, so we covered how to create a materialized view. We also showed you the statement you would use to delete a materialized view. We also learned how we could load a materialized view by using the refresh materialized view statement. Okay, thank you so much for your time, and bye for now. Hello and welcome to this section. In this section, I'll be explaining about PostgreSQL triggers, why you should use the triggers, and also when to use the triggers. So what is a trigger? A PostgreSQL trigger is a function invoked automatically when an event associated with a table occurs. So it is a function that automatically triggers or fires off when an event associated with a table occurs. So there are different kinds of events that can happen on a table. An event could be anything, like an insert, when you insert something in a table, when you update a record in a table, when you delete a record, or when you truncate a table. So these are various types of events that can occur on a table. A trigger is a special user-defined function that binds to a table. So a trigger is a special user-defined function. So it's a function that the user defines and it binds to a table. So you have to associate a trigger with a table. And when you create a trigger, you can indicate when the trigger should fire off. So it can either fire off before or after an event occurs. So you can specify when to invoke the trigger. Before you can create a new trigger, you must first of all define a trigger function first. Once you've defined the trigger function, you then bind the trigger function to a table. The key difference between a trigger and a normal user-defined function is that a trigger is automatically invoked when an event occurs. There are two main types of triggers. There is a row trigger and there is a statement level trigger. So these are the two main triggers. Triggers that happens on the row level or triggers that happens at the statement level. The differences between the two types of triggers basically is how many times the trigger is invoked and at what time. For example, if you issue an update statement that affects 20 rows, the row level trigger will be invoked 20 times, while the statement level trigger will be invoked just the one time. And when you define a trigger, you can specify whether the trigger should be invoked before or after an event. If the trigger is invoked before an event, it can skip the operation for the current row or even change the row that is being updated or inserted. In case the trigger is invoked after the event, all the changes are available to the trigger. There are benefits of using triggers. When you use triggers, they can be useful in increasing the security of various databases. So is used to maintain the integrity. So if you have certain rules on your database, you can use triggers to maintain the integrity of the data in that data. You can also use triggers to check the activities of various types of application accessing your databases. So if you want to know what's going on, or if you want to know if any unusual activity is going on within an application that accesses the database, you can use triggers to achieve that. So triggers are useful in case the database is accessed by various applications and you want to keep the cross functionality within database that runs automatically when the data of the table is modified. For example, if you want to keep history of data without requiring application to have the logic to check for every event, such as an insert or update, you can use triggers to achieve that. And triggers also helps you maintain complex data integrity rules, which you cannot implement elsewhere except at the database level. For example, when a new row is added into, for example, a customer table, other rows must also be created in tables of banks and credit. Say, for example, if you have different table, one is called customer, one is called banks, one is called credit. You can set up a trigger so that when a new row is added to one table, it also inserts something in the other table. So there are different things you can do with triggers. There are also drawbacks of using triggers. And one of the main drawbacks of using triggers is that you must remember when you have a trigger on your database, and you must also understand the logic so you can figure it out if there's any data changes or if there's any issues. So even though the PostgreSQL implements the international SQL standard triggers, in Postgres it has some of its own specific features. For example, with the PostgreSQL, when the trigger goes off each time a truncate event happens. Truncate basically is when a table is stripped of its data. So anytime a truncate event happens, it automatically fires off a trigger in PostgreSQL. Also in PostgreSQL, it allows you to define statement level trigger on views. So if you have views set up, you can also define statement level triggers on the views. Also, it requires you to define a user defined function as the action of the trigger, while the SQL standard allows you to use any number of SQL commands. So this is key difference. With PostgreSQL, it requires you to define a user defined function as the action of the trigger, in comparison to the standard SQL, where you can use any number of SQL commands to do that. So those are the two key the differences between using the standard SQL and the PostgreSQL trigger. So that's it for this introduction to Postgres trigger. In the next lecture, we are going to learn how to create our first trigger. Thanks for watching. Hello and welcome to this lecture. In this lecture, you will learn step by step how to create your first trigger in PostgreSQL using the create trigger statement. What do you need to create a trigger? So to create a trigger in PostgreSQL, you need a couple of things. First, you need to create a trigger function using the create function statement. That's the first requirement. The second requirement is to bind the trigger function. Once it has been created, you bind that to a table using the create trigger statement. So these are the two requirements you need to create a PostgreSQL trigger. So let's take a look at the syntax you would use to create a trigger function. So a trigger function basically is similar to an ordinary function, except that it does not take any arguments and has return value type trigger. So this is a typical syntax of how to create a trigger. So a trigger function, basically you start with a create function keyword, followed by the word trigger underscore function, and then you have the return trigger as. So that's basically the syntax for creating a trigger. You can create trigger functions using any languages supported by the PostgreSQL. So what happens here is that the trigger function receives data about their calling environment through a special structure called trigger data, which contains a set of local variables. For example, you can have a variable called old and new, and that represents the states of the row in the table before or after the triggering event. So you have the state of the data before the trigger occurred and after the trigger. So basically you have a before and after. Once a trigger function has been created, you can bind it to any action on a table. So once you've defined the trigger, the other thing left to do is to bind it to specific actions on a table for it to be effective. To create a new trigger, you will need to use the create trigger statement. So this is the syntax here to create a new trigger. So you start with the create trigger statement. The complete syntax of the create trigger can be a bit complex because it has many options. So for the sake of illustration, I'm just using this basic simple form to illustrate how the create trigger syntax should work. So basically you have the statement create trigger followed by the name. You have to give the trigger a name. Then there is a before action and there's an after action. You also got is instead of, and then this is the event, and then the table on which you're performing the trigger on. So I'm going to explain all this in a minute. So the event, you notice I've got event here. The event could be anything, like it could be an insert when something's inserted into a table. It could be an update. It could be a delete, or it could even be a truncate statement. So you can define trigger that fires before, okay, or after an event. The instead of basically is used only for inserts. When you're doing insert, you use the instead of. So you use this instead of only for insert statement, update statement, or delete on views. So if you're dealing with views, if you want to insert something into views, if you want to update a view or delete a view, then you can use the instead of. As I've earlier explained, there are two kinds of triggers. You have the row level trigger and the statement level trigger, which can be specified for each row, which is what I've indicated here, for each row, which indicates the row level trigger, or for each statement, which indicates the statement level trigger. This execute procedure basically is what will fire off the trigger function. So before we can create the trigger, I want to create a new table first. So I'm going to create a new tables, a couple of tables, and I'm going to then define a new function and then the trigger. So I'm going to do it in that order. So let's create the tables. I'm going to use the pgadmin tool. So it's trying to launch. When you open up the pgadmin, you may get a message come up like this. The pgadmin tool gets updated every so often. So your version may become outdated. It says here, I'm currently running 1.4 of the pgadmin 4. But there is a recent version. I'm not going to update it for now because it's not going to impact on this course. So I'm going to skip that and update it at my convenience. I'm just going to X out of that, and I'll log into the server by clicking on the plus and then click on this Postgres again. Click on the plus, and if you haven't saved your password previously, it will prompt you each time you're trying to log on. So once you're logged on, you see the dashboard. So expand the databases on the left and give the database time to populate. I've got 3 databases. So the database I'm going to create the table on is this one called DVD rental. So I'm going to right click on it and click on this query tool, and that will launch the query editor. So the query editor is basically where I'm going to write and execute the script. You can see here on the title bar, it says DVD rental on PostgreSQL. So basically saying that any script I write here will be executed against this table, this database here called DVD rental. And the database has got one schema called public. And if I expand that, you can see all the objects within that schema. And these are all the tables in that schema. All right, so let's go ahead and create a couple of tables. So this is the first table I'm creating here. It's called employees. I haven't got any tables here called employees for this database, so that should be cool. So basically it's a simple table called employees. It's got the ID is a primary key. It's got first name column, last name column of the voucher data type with a maximum character limit of 40. And I've got it not null, which means this is a constraint. That means the values for these two columns cannot be null. You must provide the value. So let me execute this and create the table by clicking on this lightning bolt. See if it will do that. So it says query returned successfully. So it's created the table. Let's just refresh. Right click on these tables here and click refresh, and the name of the table should pop up. There you go. So we've got employees. If I expand that, we can see the columns of the table. There you go. So these are all the columns of this table, which is this 3 here. Excellent. So now that I've created a table, when you're doing triggers, you can create 2 tables. That is if the table you want to use is not already there. But it's always good to have an alternate table for audit purposes, so that any changes you make, the audit table will capture the before and after change. So basically, when an employee's name changes, I want to be able to log it into a separate table. I'm going to create a separate table called employee audit. So the purpose of this second table I want to create here is that when the trigger fires off, it will dump some data into this table, which will show me the change that was made before and after the trigger. So let me highlight this table and create it. All right, there you go. So it says return successfully. So if I refresh the table list, we should have a table called employee audit. So I should have 2 tables, one for employee. There you go, employee audit and employees. So I'm going to set a trigger on this table so that any changes I make, for example, when an employee gets married, like a female employee, they would change their name. So we want to be able to log. We want a trigger to go off that would log the changes into this table called employee audit. Okay, so I'm going to end this lecture here because it's gone on for quite a while. In the next lecture, we're gonna complete the creation of the trigger. So I've now created a table. Next thing I'm going to do in the next lecture, I'm going to create the function, and then I'll create the trigger. So see you in the next lecture. Bye for now. Hello and welcome to the part 2 of creating your first trigger. We are going to start over by creating a trigger function. A trigger function basically will define the action that will be invoked when a trigger fires. So open up your PG4admin tool, and once you've opened it up, expand the DVD rental database and expand the schema, expand the public schema, and then right towards the bottom there is a trigger function. So right click on that and click on create trigger function, and it will give you this dialog box. So you've got to complete each of these tabs. So the first tab we're on now is this general tab. So we're going to ask you a few things. First, the name of the trigger. It's good to give your trigger a descriptive name. The name you add or you give to your trigger is going to be displayed in the PGAdmin tree tool, and you have to know that trigger functions will be invoked in alphabetical order. All right, just to let you know. So we just need to check that everything on this page is correct. The owner is this database here, Postgres. So if you drop down, Postgres owns it. And then the schema is public. We've only got the one schema. You can put comment in there if you want. So let's move on to the definition. So on the definition page, the return type, the default is trigger, and the language is PGSQL. And then where it's got code, this is where you will add the code that will execute when the trigger function is called. So I've already pre-staged the code. I'm going to add it on there. So this is the code that I will be adding into the PG admin tool. So I'm just going to highlight and click copy and paste it in there. So I'm going to paste it in here. Okay, so let's move on to the next tab, which is the options tab. So let's click on this tab here that says volatility. I'll just explain what that means. If you click on the drop down, there are other options. So basically what these options in volatile basically indicates that the trigger function value can change even within a single table scan. All right, so that would be the one I will be using, but I'll just run through the other options. Stable indicates that the trigger function cannot modify the database, and that within a single table scan, it will consistently return the same result for the same argument values. Immutable means that the trigger function cannot modify the database and always returns the same result when given the same argument value. So this immutable means the result will not change when you give it the same arguments. Okay, so I'm going to go for volatile because this option basically indicates that the value can change even with a single table scan. So that's what we're going to select. Then we'll go through. These are all default values, but you can change them if you wish to do so. This return a set. Basically, this switch indicates if the trigger function returns a set that includes multiple rows. The default is no. So I'm going to leave the default. This switch here, the strict switch, basically indicates if the trigger function is going to always return null whenever any of its argument is null. Null basically means the value is not known. So you can set it to yes. That means the function is not executed when there is a null argument. So if you set this option to yes, it will not execute when there are null arguments. So I'm going to leave it to no. Here we've got security definer. This switch basically specifies that the trigger function is to be executed with the privileges of the user that created it. So the default is no. So if you only want the person who created it to execute, you can set it to yes. But I'm going to leave it to no because I want other people to be able to execute it. And then here we've got the move the window. This switch basically indicates that the trigger function is a window function rather than a plain function. Okay, so if you want it to indicate a window function, you change that option to yes. But I'm going to leave it to no because it's going to be a normal function. And then we have another option here, estimated cost. Basically, you can use this field to specify a positive number representing the estimated execution cost for the trigger function. So this can be in units of CPU operator cost. If the function returns a set, this is the cost per returned row. So you can put a value there if you wish to do so. For illustration purposes, I'm going to enter 100 in there. So we've got this option here, estimated row. You can see at the moment it's grayed out. Basically, this estimated row is used to specify a positive number, given the estimated number of rows that the query planner should expect the trigger function to return. So this is only allowed when the function is declared to return a set. The default is usually set to 1,000 rows, but I'm not going to put any value in there at the moment. So we've got this switch here that says leak proof. This switch basically indicates whether the trigger function has side effects. So the default option is no, and this option can only be set by a super user. So next, I'm going to click on the next tab, which is the parameters tab. So you can use this to specify any settings that will be applied when the trigger function is invoked. So let's move on to the next tab, which is the SQL tab. This tab basically is going to compile all the information we've entered in all the other tabs. It will compile it into a complete SQL statement. So once that's done, click on save, and that will create the function. So you can see here, the function has been created. It's called log last name underscore changes. So that's it for the part 2 of creating your first trigger. In the part 3 and the final part, we will be creating the actual trigger. Thanks for watching, and bye for now. Hello and welcome to the part 3 of creating your first trigger. In this part, we are actually going to create our trigger. In part 2, we created a trigger function and we called it, was called log last underscore name changes. And basically this is the code I used for the creation of the trigger function. The function basically is going to check if the last name of the employee changes. If it changes, it will insert the old last name, okay, into this table called employee audits. It will also insert the ID, employee ID, the last name, and the time of the change. It will log that into this table called employees audit. So that's what we created in our part 2. Now let's go ahead and create the trigger. So we are going to create the trigger on the employees table. So this is the trigger function. So now we have to locate the table. This is the tables. We need to look for the employees table. So this is the employee audit. We want the employees table. If you expand the employees table, there's an option for triggers. So you can see there's no triggers at the moment. So I'm going to right click and go create trigger. All right, so we just wait for it to fetch some information. So we need to give the trigger a name. So I've given the trigger a name called last underscore name underscore changes. Always good to give your trigger relevant names. Next, move on to, you can place a comment if you wish to do so. So let's click on the definition. And for the definition, it says, is this a row trigger? Yes, we are applying the trigger to a row. I'm going to leave this option for the constraint blank and deferrable blank, deferred basically these are all self-explanatory. Trigger function, we already created the trigger function, so we need to pick that up. So click on the drop down and it tells you this is our trigger, log last underscore name changes. That's the name of the trigger, and then any arguments. And let's move on to the next tab, the events. So basically these are the events, so you can select whatever event is going to trigger. So the event we want to be triggered is an update. So for example, when a record is updated, we want the trigger to be fired. And we don't want it to be fired. We don't want it to be fired before. We want it to be fired after the update has happened. Say for example, if an employee gets married and changes her name, obviously she's going to update her name. When that name gets updated, we want the trigger to be fired. So we want it to happen after this event takes place. So that's it. Once you've done that, just click on save, and that should create the trigger. You can see the trigger has now been created. So this is basically a script that I just created using the PG admin tool. So this is basically the same thing. I just wanted to show you the script version of it. So basically what this will do, this is going to bind the trigger function to the employees table. We've already specified the trigger name, which is called log underscore last name changes, and is going to happen when a column is updated. The trigger function will automatically be invoked into the log changes. Okay, we've got a table called audit log, so it's going to log the changes into that. Okay, so we've got our trigger now set up. So in order to test this, we need to insert some sample data into the table. So I'm just going to run a quick query on the table so that we can see that the table is actually empty. And this, you can see here, the table is empty. There's no rows at the moment. So I'm going to insert a couple of rows into the table. Okay, so this is a query. This is my insert statement. I'm going to insert 2 rows here. The first one will be for a chap called John Doe. Second one will be for a lady called Jane Blue Lime. So let's highlight that, and that should insert 2 rows into the table. Okay, we've got some errors here. So the reason why I had an error was because I left out one of the columns here. Notice I've got 3 columns in that field. So now I've now added an ID, and you can see I've already inserted this record. So if I run this now, you would see it has 1 record. You can see I've inserted John Doe. So what I need to do now is do the same for here. I'll just come here and type in the ID column and put a comma there and a space, and here I will just insert the number 2 to include. I'm just manually assigning IDs to the rows here. So let me execute this, and that will give me record number 2. So you can see now that's been inserted. So if I run the table again, I should have 2 records. All right. So this is I'm just doing basic inserts here just to illustrate how the trigger works. Ideally, in a normal way, this ID column should assign automatically when you insert, but I've done it manually. Okay, now we have 2 records. So let's assume this lady here called Jane got married and has come back to us to say she's married. So now we need to update her details to her married name. Okay, so I now have an update statement. So remember, her current name is Jane Blue Lime. So I'm saying I'm updating the employees table. I'm setting the last name 2 equals to Brown, where the ID is equals to 2. You can see the ID here is equals to 2. So it's going to change this lady's name, Jane, change the last name from Blue Lime to Brown. So let me run this statement and execute that. Hopefully everything should okay. I got an error. I want to know why. The reason why we're experiencing some issues, you know, when we created the table and when we inserted the values, we manually set a value for the column ID. So what I'm going to do, I'm going to delete both tables and set the table up again, this time using an automatic ID insertion. So I'm going to delete the 2 tables we created, the employees audit and employees as well. What that means is that inside the employees, I've got a trigger. That means I'm going to have to recreate this trigger here. Okay. So I'm going to right click and go delete or drop table, and that will get rid of that table. And I'll do the same for the employees audit, and I'll drop that table. Okay, so I've got both tables dropped. That means I'll need to recreate the trigger. The function, trigger function, is okay. I've already created it. Sorry about this. That means this lecture is going to go on a bit longer. But hopefully that should solve the problem. So let's recreate the table. This is the first table, employees table. What has changed here is this serial here. This is what will give it an automatic numbering. So I'm going to highlight that and execute. Hopefully that should create okay. So that's created that table. I'll do the same. I'll do the same for this table here. I'll right click, select all and click on that. So we've now created both tables. So now the tables have been created. If I refresh my table list, both tables should be there now. I've got the employee audit and employees. Now I can reinsert the sample data. Okay, so I'm inserting some sample data here. So I'm just going to highlight both and execute. And that should create, you can see it's created the rows. You can see here, I've not used the ID because of the automatic numbering we set up when I recreated the tables. So this table now should now have 2 rows. So what I need to do now is go back to the table and recreate the trigger. So I right click on the employees table, expand that, and there should be an option for trigger. So I'll just expand, right click, I'll create the trigger, wait for it to populate. I'll give the trigger a name. So I've given the trigger a name, same name as before. I'll click on the definition. So it's going to be a row trigger. I say yes. I'll leave all this. That should be okay. Everything should be set. Click on event. The event I want is going to be an update. This is when I want the trigger to fire. When there's an update, I'll just go to the definition. I need to select a trigger function. Click on the drop down. This is the trigger function we created earlier. So we've got the event. So it will trigger after. I'll put after an update, not before. So that's it. I'll click save. And so we've got our trigger now set up. All right, so I'm going to quickly do a quick query on the table and just make sure we've got something in there. You can see we've inserted 2 rows because of the automatic numbering. You can see it's automatically inserted the number row. So now Jane, let's assume Jane has got married. So we're going to update her last name. Hopefully that should trigger a set of the trigger. So I've added this query here. So we assume that Jane got married and her last name is now Brown. So we're going to update this. So where the ID is 2, which is this, and that should fire off the trigger. So I'll select that and click on that. You can see the query has returned successfully. So that means recreating the table has helped because of the automatic numbering. So now the trigger should have worked because we've done an update statement. Remember, triggers are automatically fired. So what I expect the trigger to have logged that information into the audit, employee underscore audit. So let's do a quick query on the employees underscore audit. Employee, let's take out the S. So the audits, let's do a quick check on that. Yep. Run that table. We should have something in there if everything's worked okay. Excellent. So you can see here is logged the ID, the employee, the last name. This was the old last name, and it tells you when it was changed. You can see the trigger has worked and it fired off the code automatically. So that is really good. Really pleased about that. So the issue we had earlier was because of the automatic numbering. So we have successfully created our trigger now and also tested the trigger. Thank you so much for watching. Apologies, it's taking quite long. If you do have any issues, please let me know. Take care and bye for now. Hello and welcome to this lecture. In this lecture, I'll be showing you how to manage your PostgreSQL triggers. So this will include things like modifying a trigger, disabling, and also removing a trigger. So let's start by taking a look at how we can modify a trigger. To modify a trigger, you have to use the following syntax, and it begins with the alter trigger statement. So you use the alter trigger statement to modify a trigger. This statement is a PostgreSQL extension of the standard SQL language. So basically, the syntax begins with the alter trigger statement, where you specify the name of the trigger associated with a particular table that you want to change. Second, you put the new trigger name in the rename clause. You can see there's a rename clause. So you put the name you want to change the trigger to. So I've got a simple query here. So for example, if we wanted to change the last name changes trigger, okay, we have a trigger called last name changes. If we wanted to change the name of that trigger, which is associated to this employees table and also to the log last name changes. So if we wanted to change that, we have to use this alter trigger statement. All right, so if we wanted to change it, this is the syntax we will use to change the name of that trigger. So this statement basically is saying change the name of this trigger, which is a trigger set on this employees table, change it to this name, log underscore last name changes. So let's take a look at how to disable a trigger. PostgreSQL does not provide any specific statement such as disable trigger for disabling an existing trigger. However, you can still disable a trigger by using the alter table statement. So let's take a look at the syntax. So this is the syntax if you want to disable a trigger. So you basically specify the name of the trigger after the disable trigger clause to disable a particular trigger. To disable all triggers associated with a table, you use the all. Okay, so if I wanted to remove all the triggers linked to a particular table, I will use this all switch as well. Instead of a particular, rather than use a trigger name, I will use this all switch, and that will get rid of all the triggers linked to a particular table. The key thing you need to know here is that the disabled trigger is still available in the database, even though you're just disabling it, you're not removing it. So it's still present, but it will not get activated when a trigger event occurs. So this is again another sample query here to disable a trigger. Say for example, I want to disable a trigger. I'll use the alter table, which is the table that contains the trigger. In this case is the employees table. And I'll use the disable trigger clause and then type in the name of the trigger I want to disable. So this will disable a specific trigger. If I wanted to disable all triggers for a table, I'll just use the all switch rather than the specific name of the trigger. Let's see how we can remove a trigger. To remove an existing trigger definition, you have to use the drop trigger statement. So let's take a look at the statement. So this is a typical statement you would use to drop an existing trigger. So you specify the name of the trigger that you want to remove after the drop trigger clause, and then the table that the trigger is associated with. To avoid errors of removing non-existent trigger, it's best to use the if exist option, which is this if exist, and that way you avoid the error message coming up in case you're trying to remove a trigger that does not exist. So by using this if exist option, it checks first to see if there is such a trigger, then it goes ahead to remove it. So this is an example on line 8 here of how you would remove a trigger. Say for example, if I wanted to remove a trigger called log underscore last underscore name underscore changes on this table called employees, this is the statement I would use to remove the trigger. So that's it. In this lecture, I've shown you how to modify, to disable and remove an existing trigger. Thank you for watching and bye for now. Hello there. PostgreSQL manages database access permissions by using the concept of roles. A role can be thought of as either a database user or a group of database users, depending on how the role is set up. Roles can own database objects, for example, tables and functions, and can also assign privileges on other objects to other roles in order to control who has access to which objects. It is possible to grant membership in a role to another role, this way allowing the member role to use privileges assigned to another role. A role that has login right is also referred to as a user, while a role that is a member of other roles are referred to as groups. Database roles management involves the database roles, the role attributes, the role membership, also involves inheritance, so group and user inheritance, dropping of the roles. Dropping basically means removing the roles, and default roles. So we are going to be taking a look at the different aspects of database role management listed here in separate videos. Thanks for watching and bye for now. Hello there. Database roles are global across a database cluster. A database cluster is basically a group of databases. Database roles are conceptually completely separate from operating system users. So the role that a user will have for an operating system is completely different to that of the database. To create a role using an SQL syntax, you specify that by using the statement create role followed by the name of the role. You can also use the PGAdmin tool to create a role. I have logged into my PGAdmin 4 tool, so you can use this tool, administrative tool, to also create a role using the login group role dialog box. So you see this here, login group roles. You can use that to define a role just by right clicking and going create a role. You specify that and it gives you the dialog box. So from this dialog box you can specify the name for the role, give it a comment, you can add definitions, you can add privileges, you can add membership, parameters, security, and finally the SQL that is used to define the role. So this is an area you can use within the PG4admin tool to create a new role. Every connection to the database server is made using the name of some particular role, and this role determines the initial access privileges for commands issued in that connection. The role name to use for a particular database connection is indicated by the client that is initiating the connection request. To get all the available roles in a cluster, you can query the PG role system catalog. So if I expand this here, you can see here we've got all these PGs here. So we can query the PG_roles catalog in order to determine all the available roles currently set within the cluster. So let's quickly run a quick query to see the current roles we have. So to do that, I'm just going to click on my databases here and select that, and then I go to tools, click on query tools, and that will give me the query window here. So this is where I will write the query. I have added the query here. So it's basically a 4-line code here. I've just spread it out to make it more understandable. So you do a simple select statement. You select the role name from PG_roles. So this PG_role here is a system catalog. So if I click on this icon here and execute, it tells you successfully run. So it tells you these are the various role names currently available within the database cluster. So that is it for this video. In the next video, we're going to take a look at the role attributes. Thank you for watching. Bye for now. Hello there. A database role can have a number of attributes that define its privileges and interacts with the client authentication system. Only roles that have the login attribute can be used as the initial role name for a database connection. So a role with the login attribute can be considered the same as a database user. You can create a role with login privileges in a couple of ways. So the first one would be using a statement with the create role followed by the name, and then you specify the login attribute. Another way you can create a role with login privileges is by creating a user. So by default, the create user is equivalent to the create role. The only difference is that the create user assumes the login by default, while the create role does not assume the login by default. You have to specify the login. A database super user bypasses all permission checks except the right to login. The super user is a dangerous privilege and should not be used carelessly. So you have to be careful how you use the super user privileges because it is extremely powerful. It is best to do most of your work as a role that is not a super user. To create a new database super user, you use the create role name followed by the super user word. You must do this as a role that is already a super user. So for you to create a new super user, you already have to be a super user. The database creation role must be explicitly given to the create databases. So to have the ability to create a database, you must explicitly have the create database permission. The only exception to this is the super users. Super users bypasses all the permission checks. So only super users can do that. But apart from super user, anyone who wants to create a database must have the role explicitly given. So to create such a role, you use the create role followed by the create DB statement. So that is the statement you need to create or to apply permissions or privileges to someone to be able to create a new database. A role must be explicitly given permission to create more roles. The only exception is the super users, since those with super users bypass all permission checks. So to create a role, you need to use the create role followed by the name and then the word create role. A role with create role privilege can alter and drop other roles. Also, it can grant or revoke membership in them. However, in order to create, to alter, to drop or change membership of a super user role, super user status is required. The create role is not sufficient to be applied to super user privilege. A role must explicitly be given permission to initiate streaming replication. Exception for this is the super users. So anyone with a super user can bypass all permission checks. A role that is used for streaming replication must also have the login permission as well. So to create a role that's got replication permission, which will include login, this is how you would define that. So the statement will include create role followed by the name and then the replication with the login. A password is only significant if the client authentication method requires the user to supply a password when connecting to the database. Okay, so to create a password or specify a password upon the role creation, you specify this way. So you use the create role followed by the name of the role, and then you specify password, which is usually a string. String basically means text. I just want to give you a tip here for good practice on creating a role. So basically, it is good practice to create a role that has the create DB and create role privileges, but not a super user privileges. Okay, and then you use the role for routine management of databases and roles. This approach avoids the dangers of operating as a super user for tasks that do not really require super user privilege. You can also use the login group roles from the PG4 admin tool for roles attributes. So if I right click on this now, I go roles, you can usually modify attributes. For example, where it's got privileges, you can specify if the role, person with the role can log in, can have super user access, can they create roles, can they create databases, can they update catalog, inherit. So you can use this login dialog box to do that. This dialog box here, you can use that just by choosing the appropriate options, so either yes or no. So just wanted to show you that you can also do it via the PG admin 4 tool. A role's attribute can always be modified after creation by using the alter role statement. So that's it for this video. We explored some of the role attributes in this video. Thanks for watching and bye for now. Hello there. It is easier to manage roles as a group so that you can grant or revoke privileges from a group as a whole. In PostgreSQL, you can create a role that represents a group, and then you grant membership in the group to individual user roles. By convention, a group role does not have login privilege. So to create a group role, you use the create role statement as follows. So type in create role followed by the name of the group role. For example, we can create a sales group role like this. You just type in a statement create role followed by the name of the group. In this example, I've called it sales. Once the group role has been created, you can add a user role to a group role by using the grant statement. For example, I can add the user bond to the role sales group. So this is how I would do it. I would say grant sales to the user called bond. You can also revoke the role privileges by just typing in revoke sales from a specific user. Notice that PostgreSQL does not allow you to have circular membership loops in which a role is the member of another role and vice versa. Hello there. A user role can use privileges of the group role in the following ways. The first is that a user role can use the set role statement to temporarily become the group role, which means the user role use privileges of the group role rather than the original privileges. In addition, any database object created in the session are owned by the group role instead of the user role. The second option is that a user role that has the inherit attribute will automatically have the privileges of the group roles of which it is a member, including all privileges inherited by the group roles. Let's take a look at an example script. So this is an example script. So with the following script, if you connect to the PostgreSQL database, for example, as the user Bond, you will have privileges of Bond plus the privileges granted to the sales, because Bond user role has the inherit attribute. However, you do not have privileges of marketing because the no inherit attribute is defined for the sales user role. However, you can execute the following script by typing in set role equals sales, and what that does is that it will provide privileges granted to the sales but not the ones granted to Bond. However, if you execute this script to set the role to marketing, what that will do, it will provide privileges that is granted to marketing, not the ones that are granted to the admin and Bond. To restore the original privilege, you can use the following statement by typing in reset role, and that will restore the original privilege. Note that only privileges on the database object are inheritable. The login, the super user, the create role, and create DB are special role that cannot be inherited as an ordinary privilege. So that's it for this video on group and user role inheritance. Thanks for watching and bye for now. Hello there. Before you can remove or drop any roles, there are things that you need to check before the removal can take place. And this is because roles can own database objects, and that in turn can hold privileges to access other objects. So before you can drop a role, you need to first of all check to see if any objects that is owned by the role has been reassigned to other owners, and also any permissions granted to the role must be revoked. So before removing a role, you must reassign or remove all the objects it owns and revoke its privileges. If you remove a group role, PostgreSQL will revoke all membership in a group automatically. The user roles of the group are not affected. So in order to remove roles, you need to use the drop role statement to remove a group role or a user role. That is it for this video on removing roles. Thanks for watching and bye for now. Hello there. PostgreSQL provides a set of default roles which provides access to certain information. Administrators can grant these roles to users and or other roles in their environment, providing those users with access to the specified capabilities and information. I have got my PG4 admin tool, so I'm just going to expand this login/group roles so that you can take a look at the default roles. So these are all the default roles that PostgreSQL provides. So I'm going to try and run through some of them so we can take a look and see what they do. All right, so we've got one here called PG_monitor. That basically is used to read and execute various monitoring views and functions. All right, and then we've got this one, PG_read all_settings. This basically is used to read all configuration variables, even those normally visible only to the super user. We've got this one called PG_read_all_stats. That basically is used to view various statistical data relating to the database. And then we've got this one, PG_signal backend. This basically is used to send signals to other backends, e.g. cancel query or terminate a query. Okay, and then we've got the PG_start_scan_table. This basically is used to execute monitoring functions that may take access, share, locks on table. For example, when there are locks on the table, you can use that to monitor it and also monitor potential issues relating to the table. The PG_monitor, PG_read_all_settings, PG_read_stats, and PG_scan_table are basically intended to allow administrators to easily configure a role for the purpose of monitoring the database server. Okay, so they grant a set of common privileges that allow the role to read various useful configuration settings, statistics, and other system information normally restricted to super users. So care should be taken when granting these roles to ensure they are only used where needed to perform the desired monitoring. Administrators can grant access to these roles to users by using the grant command. So that is it for this video on the default roles. Thank you for watching and bye for now. Hello there. In this video, we are going to create a role by using the PG_admin4 GUI. GUI stands for Graphical User Interface. A role may be an individual user with or without login privileges or a group of users. When you define roles at the cluster level, all the databases in that cluster will share the role. A cluster basically is a group of databases. I have logged into my PG4 admin. So to create a new role, you just right click and click on create and then click on role and you give the role a name. So I can call my DB. I'll give it an underscore monitor because I want this role to monitor the database. So you can give a comment if you want. I just say monitor database. Okay, and then you go through the different tabs before you can actually save what you've done. So let's move on to the definition. This is a general tab now. So go to the definition. Definition here, basically you set a password. So just set a password, and then you can set, if you want the account to expire, you need to activate that. But if you don't want to, you can leave that blank, grayed out. So also connection, basically the limit of the connection, I'll put it to -1. And then privileges, click on privileges. So these are the privileges. So I don't want the role to have login rights, so I leave that set to no. I don't want it to have super user privileges, so I use that, leave that as no. I don't want it to create other roles. I don't want it to create databases. I don't want it to update the catalog. I do want it to inherit rights from the parent roles. I don't want it to initiate creating replication and backups. So let's move on to the next tab, which is membership. I want it to be a membership of this PG admin here. So it says here, select the checkbox for roles to include with admin option. I want it to include admin option, so I click on that. There's parameters here. If you need to set any parameters, this is where you would set it. I'll move on to the security tab. And again, this is where you set any parameters. And if I click on SQL here, it will show me the SQL that was generated from the options I have entered. So this is the SQL so far that I've generated following the options. So it's creating a role called DB_monitor with these following privileges: no login, no super user, no create DB role, no create role, but can inherit, no replication, connection limit -1. That's the password. No expiry, and it's going to be granted the PG monitor membership so the PG monitor membership is being granted to the role called DB_monitor with admin option. And this is a comment on the role. DB_monitor is monitor database. So that has been the role created. So once you're happy with the input from the SQL, so this is the SQL that was generated from all these options you've entered. Once you're happy with that, just click on save, and that will create the role. So now if I click on this to expand it, you should see the new role that I've created called DB Monitor. If ever you want to see the SQL that was used to generate a role, all you need to do is right click and then click on create script. It will generate the SQL that was used. So you can see here, it shows you the SQL that I used to generate that role. So that is it on creating a role. Thanks for watching. Bye for now. Hello there. Backing up databases is one of the most critical tasks that a database administrator has to perform. Database backup is simply the process of copying the database data and information to a safe location to be used when required. So you may have a situation where there may be a data loss or a system failure, and you may want to restore the database back with as much information as possible. If you already have a backup in place, you can restore that information from the backup. PostgreSQL provides several tools that you can use to perform backups. So the first one is called PG_dump. This is used if you want to perform a backup from the command line or the terminal, and the PG_dump tool basically is used to back up a single database. You also have another tool called PG_dump all. Now this tool is used to back up the entire databases. So if you've got a cluster of databases, a cluster is a collection of databases, you can use the PG_dump all to back up all the databases you have in your cluster or system. The final tool is the PG admin tool, which is a graphical user tool. You can also use this to back up your database. In separate videos, I'll be showing you how to use the PG_dump tool to back up a single database. I will also be showing you how to use the PG admin tool to back up a single database. So I'll be showing you these in separate videos. So that's it for this introduction to database backup using PostgreSQL. Thanks for watching and bye for now. Hello there. In this video, we are going to back up a single database. We are going to do that using the PG_dump tool. Now, before we back up database, it's good to have a directory that you back up the database to. And then we are going to be using the terminal. So if you're on a Windows, we'll be using the command prompt. If you're on a Mac, you can use the terminal, and then we'll be using the PG_dump tool to perform the backup. So the first thing to do is to make sure you have a backup directory. I'm going to create one now in my C drive. I'm just going to right click and just go new folder. I'll just give it a name. I'll call it PG backup. PG standing for Postgres backup. So that's my backup directory. Next thing I need to do is open up my command line. So I've got my command prompt here on Windows. I'm just going to right click on it and go run as administrator because I want it to run as an administrator, and that will give me this screen here. What I like to do, I like to navigate to the root of the C. So to do that, I type in cd ... and press enter, and that takes me back. I do a cd ... again and press enter, and that takes me back. So I'm now in the root of the C. So I'm just going to type in cls to clear the screen. So all I have is just root. The next thing I want to do is to navigate to the bin directory of my Postgres installation. To navigate to your Postgres installation, it's usually in the program files directory. So I'm going to click on my programs file and look for my Postgres installation. So that's my PostgreSQL folder. Click on that, click on 10, and then click on bin, and then just copy the path, which is this one here. Right click, copy, and then you go back into your command line, type in cd to change directory, with space, and then paste that location into it. Press enter. So we now have access to the Postgres installation and the bin directory. I'm going to type in cls to clear the screen. So now that we have that, it's time to use the PG_dump command. So before I execute the command, I want to explain the command to you briefly. So this is a command I am going to execute to do the backup. So let me run through some of the switches in the command. This is the tool PG_dump. The -u basically specifies the user that is going to be used to connect to the PostgreSQL database server. In this example, I have used Postgres to connect, to make the connection to the server. The -w, this forces the PG_dump to prompt for the password before connecting to the PostgreSQL database server. So that's what the W is for. It will prompt you for a password to connect to the server before it will allow the backup to proceed. The -f specifies the output file format, the format of the output file, and the format can be anything. It could be a custom format. I'm going to be using a tar, or you can also have it in SQL, which is a plain text format. So this is the command, and we're backing up to this directory. Remember, I created a directory called PG backup, so it's going to back up to this directory, and this is going to be the name of the file. It's going to be called DVT rental. DVT rental is the database I'm backing up, and I'm going to back up using a tar format. Tar is a archived format. So this T here basically is used to represent the format of the backup, which I've represented it as a .tar. So I'm going to copy this into my command line and then execute the command. I've now copied the command here into my command line. If I press enter, I should get a prompt for a password. So I need to enter the password to make sure I have authority to do the backup, and then I press enter, and if everything goes okay, it will return back to the bin command. So that means I've got no errors, so it would have performed the backup. So now if I go back and take a look at my directory, we should see a file there, a file here called DVD rental. So you notice in a zip format, it is an archive format, which is a .tar format. Okay, so we've successfully performed the backup using the pg_dump tool. So that's it for this video. Thanks for watching. Bye for now. Hello there. In this video, we are going to be backing up a single database using pgadmin tool. I have logged into my pgadmin utility. So under the pgadmin, in the tree area here, you expand the databases by clicking on the plus sign, and the database I am going to perform a backup on is this one here called DVD rental. So you right click and there should be an option for backup. Click on backup and that will give you this dialog box. Here there is some information here. You can click on that and that will give you some information about the console. If you click on this here, it will open up a new plain text here where you can read up about using this dialog box. So feel free to do that. So I'm just going to click to X out of that. So this is what you get. You have to start by specifying the file name. You always need to have a backup directory. In the previous video, I already created a backup directory. So I'm going to navigate to the backup directory. So this is the backup directory I created called PG backup. So I'm going to click to select that. Okay, you click, and here I'm going to give the backup, give the file a name. So this is the directory is going to dump the backup into. So I'm going to give it a name. I'm going to call it DVD rental 2 because I've already got a backup there called DVD rental. So I'll make this DVD rental 2 and the format is going to be a .tar. Once I've done that, I'll click this select button and that will put that in there. So I now have a location to backup to. So the format, you have custom here. You can click on the drop down and select tar. These are the different types of format you can back up to. I've chosen tar, so I'm going to leave that selected. If you want compression, you can select compression. I'm going to skip all that. Encoding, if you want to do that. Number of jobs, you can specify the role name. I'm going to click on the drop down. I am going to select Postgres as the role that I'm going to use to backup. And then if you look here, we've got dump options. pgadmin backup tool provides various dump options. So if you click on that, you can see the different options. If you want to know what they all do, just click on this question mark here. It will give you a description. So just read through and you can see what the different options do. For simplicity, I am going to accept the default that has been specified here. So anything in green here is default. I'm just going to scroll through. Anything in green I'm going to leave as default. But if you want to know what all the options are, click on this question mark and read through them. So I'm going to accept the default. Once I've done that, I'm going to click backup. And you can see here it says backup created, and you could click here to see the details of the backup. So if I bring that up a bit, you can see here it tells me backing up an object on the server, tells you what it has done, tells you the time it started, and you can see the various files. These are all the files it has backed up and dumped into the location I have specified. So this is my backup directory. You can see this is the file I've just backed up called DVD rental 2. This was from a previous backup. So we can see that the backup has been successfully performed using the PG admin tool. So that's it for this video. Thank you so much for watching. Bye for now. Hello there. In this video, I'm going to briefly introduce you to a variety of ways that can be used to restore a PostgreSQL database from backup. You can use the PSQL tool to restore plain SQL script generated by pg_dump and pg_dump tools. You can also use the pg_restore to restore tar file and directory format created by the pgdump tool. You can also use the pgadmin tool to restore a database from backup. If you are restoring to a database with the same name, it is advisable to terminate all the connections to that database before you prepare the backup file for restore. However, if you are not restoring to the same database, if you are creating a new database, then you don't need to terminate all connections. So I would recommend, if possible, create a new database and then restore into that database. I am going to be showing you 2 ways using separate videos. I'm going to be showing you how to restore a database from backup using the pg_restore tool. And I'm also going to show you how to restore from backup using pgadmin tool. In both cases, I'm going to be creating a brand new database and will then restore from backup into those databases. Hello there. In this video, we are going to be restoring a PostgreSQL database from backup using the pg_restore tool. Before we do that, we are going to create a new database using the PSQL shell. So locate your PostgreSQL folder and then click on the SQL shell, which is a PSQL, and that will give you this screen here. So just press tab a few times to provide different answers. So the server is localhost, the database is Postgres, the port is 5432. So just keep pressing enter. The username is Postgres. Press enter again. Now you need to enter a password, which will be the password that you entered when the database was created. Once you've done that, press enter. If successful, you will get this Postgres and this hash symbol. So now I want to create a brand new database that I will restore a previous backup into. So to do that, you type in the command create, okay, space, database, space, and then you give the database a name. I'm going to call this DVD rental, and I give it a number 2 because I've already got a database called DVD rental. And then you terminate that with a semicolon. Very important, you add the semicolon to indicate the end of the statement. Once you've done that, press enter, and if everything is successful, it will return to the Postgres hash symbol, which indicates that the database would have been created. So we'll give it a few minutes to create that, and if there's any errors, it will display. You can see here it's returned create database, and it's returned the Postgres command, which means the database would have been created. So let's open up the pgadmin tool and quickly check to see if the new database is located there. This is my pgadmin. You can see here I've got a database called DVD rental. This is the new database I've just created, so I call the DVD rental 2. This is my original DVD rental. If I expand that, you will see that the database is kind of like empty. If I click on the schema, you can see there's a public schema, but if you look here, there are no tables. That's an indication that it's actually empty. So what I'm going to do, I am going to be restoring from backup. The backup I took of this DVD rental, I'm going to restore that into this new database called DVD rental 2. What you need to do is open up either your command prompt if you're on a Windows, or the terminal if you're on a Mac. So I'm on a Windows, so this is my command prompt. I'm going to right click and go run as administrator, and that will give me the command prompt logged in as an administrator. So what I need to do, first thing I need to do is change the directory to the C drive. So I just do cd ... that will change it back one directory, cd ... it will take it back another level, and I'll type in cls to clear my screen. All right, so the next thing I want to do is point this to the location of my Postgres installation. So to do that, I need to locate my Postgres installation and also the bin directory within that installation. Postgres installation is usually in your programs files. So this is my programs files. So I'm going to locate my Postgres. This is my Postgres folder. I'll click on 10, click on bin, just highlight the path. I'll copy that and open up my command prompt, type in cd to change directory, do a space, and then paste that location into it, press enter, and I now have the drive pointing to the bin directory. So now that I'm inside the PostgreSQL installation folder and the bin directory, I can now use the pg_restore tool to restore from backup into the new database I created. So this is the pg_restore statement I'm going to execute to implement the restore from backup. So I'm going to use pg_restore tool and use a dash to specify the name of the database that I am restoring the backup into. I created a new database called DVD rental 2. And notice I've got a dash capital U. Basically, this means the username I'm going to use to connect to the database. And the username I'm going to use is Postgres. I've got dash verbose. In computing, verbose basically refers to a mode or setting that displays or gets extended information. And then here is where I'm picking up the backup that was taken. This is the location of the backup folder. So I'm picking up the backup from here. I'm restoring it into this new database called DVD2 rental. So I'm just going to copy that path into this bin directory path. All right, so now you can see here it's asking me for a password. So once I enter the password, the backup should begin. So I'm just going to enter my password. And once I do that, the restore should commence. So I'm going to just, hopefully I've got my password incorrect. Okay, my password is wrong. So I need to check that again. I'll clear that and paste that path into again. Now let's try again with my password. So I'll type it in again. Okay, you can see the password is correct. Now it's doing the restore from backup into the new database I created. So let's go and check the new database, and we should see the tables have been restored. So I'm in the PG admin tool. So let's expand the database, which is this DVD rental. This is the database I've just restored into. So I'm going to see here the tables are now there. I now have 15 tables, which means the restoration was successful. So that's basically how you can use the PG_restore tool to restore a database from backup. Thanks for watching, and bye for now. Hello there. In this video, we are going to restore a PostgreSQL database from backup using the PG admin tool. Before we do that, we are going to create a brand new database using the PG admin tool and then restore a previous backup into that new database. So this is my PG admin tool. So the first thing I want to do is create a brand new database. So I've already got three databases. It tells you there. So if I click on the plus, I've got DVD rental 2. So I'm going to create another one called DVD rental 3. So I'll right click where it says databases and go create database. I'll give it a name. I'll call it DVD rental. This will be number 3. So once you've given the database a name, just click on save, and that should create the new database. You can see now it has changed to 4. So it has now created a database. So if I expand, you see I've got DVD rental 3, which is the new database I have just created. So let's quickly take a look. So if I expand the new database and take a look at the schema, which is the public schema, if I click on tables, you'll notice there are no tables. So that's an indication that the database has not been restored. So what I'm now going to do is restore from backup. So I'm going to right click on the new database, which is DVD rental 3, and click on the restore option. And here the format is going to be a custom or a tar. The file I saved the database as was a tar file. So now I need to locate the location of the database from backup. All right, so if you have the format here, you click on it, click all files so that you can see. So these are my tar files. I've got DVD rental tar. So I'm going to click on that. You can see it pops it in there. I'll click select. Okay, so now I have the location. I need to select the role name. So I'm going to select Postgres as a role name, and I just click the restore to begin the restoration. So it tells me restoring backup on the server, says successfully completed. Tells me the duration it took. So you can click here for details, and it tells you when it started and what it has done. The status successfully completed. So I'm just going to click this X to exit out. Now let's take a look at the database that has been restored. We should have some tables in there. So I'm going to expand that and then expand the schema. And within the schema, what I'm interested in really is the table. Sometimes it may not show up immediately. You may have to refresh. So I'm going to right click and click refresh. If you notice that a refresh doesn't actually repopulate the database, you can just right click and disconnect the database and go back in, and that should hopefully populate the backup that you've just restored. So I'm going to click on the schema again, and if I click on this table sync, you can see now have 15 tables showing, which means the backup has been successful. So that's basically how you can use PG admin tool to restore a PostgreSQL database from backup. That is it for this video. Thank you for watching. Bye for now. Hello there. In this video, I will introduce you to PostgreSQL PostgreSQL table space. What is a table space? A table space is a location on a disk where PostgreSQL stores data containing database objects. Database objects include indexes, tables, and so on. PostgreSQL uses a table space to map a logical name to a physical location on a disk. Postgres comes with two default table spaces. The first table space is called PG_default. This table space stores all the user related data. The second default table space is called PG_global, which stores all the global data. The table spaces allow you to control the disk layout of PostgreSQL. There are a couple of distinct advantages of using table spaces. The first advantage is that if a partition on which the cluster was initialized is running out of space, you can create a new table space on a different partition and use it until you reconfigure the system. The second distinct advantage of using table space is that you can use the statistics of database objects, the usage of the database object, to optimize the performance of the databases. For example, you can place the frequent access indexes or tables on a device or devices that performs very fast, e.g. a solid state device, SSD, and put the tables containing archive data which is not really used on slower devices. So you can use the statistics from that to organize and optimize the performance of the databases. So that's it for this quick introduction to PostgreSQL table space. Hello there. In this video, I'll be showing you how to create a PostgreSQL table space. To create a table space in PostgreSQL, you have to use the create table space statement. So something like this. So you start with a create table space followed by the name of the table space. You specify the owner and then you specify the location where the table space is going to be created in. When you are creating a new table space, the name of the table space should not begin with the PG underscore because these names are reserved for the system table spaces. By default, the user who executed the create table space is the owner of the table space. So the statement allows you to assign the ownership of the table space to another specified user. So where it's got owner, this is where you will specify a name for the table space if you don't want to be the owner of the table space. So let's create a directory for the table space. So on my local C drive, I'm just going to right click and create a new folder, and I'm going to call the folder, I'm just going to call it PG, stands for Postgres, and inside that PG I'm going to create another directory and I'm going to call that data, and then inside that data I'm going to create another directory, and I'm going to call this DVD rental. I've got a database called DVD rental. So that is this is the path. If I click on this, this is the path. This is going to be the path for my table space. When I specify to create a table space in the location, I'm going to provide this directory path for my table space. So to execute a query that will create a table space, I've opened up my pgadmin tool. So I'm going to expand the databases. I'm going to click on the DVD rental database. I'm going to click on tools and click on query tool, and that will give me my query window where I can execute my query. So this is the statement to create the table space. You use the create table space statement followed by the name for the table space. I'm calling it DVD rental. The location is this. Earlier I created a directory for the table space, which is what I've specified here. So now I'm going to click on this symbol here to execute it. It tells me error, table location must be an absolute path. So I've made an error in the path, so I need to fix that. So I forgot, should have placed a slash next to the C here, and that should create the absolute path it's complaining about. So let's try again and execute. And you can see here query returned successful. So it says query returned successful. So it has successfully created the table space. So if we take a look at the directory where I created it, you can see here this is a table space that has been created. You can see the path here that I specified, and this is what it has created. So what I'm going to do, I'm just going to create another one, but this time from the pgadmin GUI. So I'll create a folder. I'm going to call it DVD rental. All right, so I'm going to create another table space using the pgadmin GUI. So to create a table space from the GUI, so I'm just going to collapse these databases. You can see here we've got an area for table spaces. So if I expand that, you can see this is a table space I created using this create table space statement. That's the name there, and that's it appearing here. And these two are the default table spaces, pg_default, which basically is used to store user related data, and then the pg_global, which stores global related data. So to create a new table space from this table space menu, you just right click and go create table space. You give it a name. This time I'm going to call it DVD rental, and I'm going to make it number 2 and click on definition. In the definition is where you specify the path. So what I'm going to do, I'm going to paste in the path that I've specified. Okay, so I'm just going to get rid of this bit here. So I specify the path here. It's going to create it in C drive in my directory called pg data. I need to get rid of, I've got 2 slashes here, so that's how it should be. I created another directory called DVD rental 2. So this is where I expect it to create it in. So that is the path. I'll get rid of the quotes, and once you've done that, click save, and that should create the table space for you. So if I refresh this table space, actually no need to refresh, you can see it here. It's created the table space called DVD rental 2. So I've showed you a couple of ways that you can use to create a table space. So that's it for this video. Thank you for watching. Bye for now. Hello there. Once a table space has been created, you can change its definition by using the alter table space statement, just like this. The alter table space followed by the action. PostgreSQL provides some actions such as renaming a table space. So you can rename a table space. Another action that you can do is change the ownership of the table space. So these are some of the actions that you can perform to change the definition of a table space. So to change the name of a table space, you use the statement alter table space followed by the name of the table space you're trying to make the modification to, and then you use the rename word, say rename to, and then you specify a new name. You can also change the owner of a table space by using this statement here. Specify the table space name, and then you use owner to, and then you specify the new owner. So let's go ahead and make a modification to one of our table spaces. So to begin, I'm just going to click on one of these databases to get the query window up. So I go to tools, click on query tools, and in here I'm just going to paste in a query that I previously staged. So I'm using the alter table space statement on this table space called DVD rental, which is this one here, and I'm renaming it to DVD rental underscore table space. So I'm just going to execute by clicking on this icon here, and you can see here it says query returned successfully. So if I refresh the table spaces, you'll see that the name has changed. You can see here it's changed to DVD rental underscore table space. So I have successfully changed the definition of that table space. So that is it for this video. In this video, I introduced you to changing the definition of a table space. So once a table space has been created, you can change its definition. You can change the ownership of the table space, or you can also rename the table space. I showed you an example of renaming the table space. Thanks for watching. Bye for now. Hello there. Once you have created a table space, you can also remove the table space by using the drop table space statement. So this is what the statement will look like. You would need to specify the name of the table space after the drop table space clause. The if exist helps you avoid the error of removing a non-existent table space. Only table space owner or the super user can delete table spaces. Also, before deleting the table space, you need to make sure that it is empty. What that means is that there should be no database or database objects inside the table space. So let me show you how to delete a table space. So the table space I'm going to delete is this one here called DVD rental underscore table space. There are no databases or database objects inside. It's empty, so I do not expect any issues when deleting it. So I'm just going to paste in the query. This is a query. You type in drop table space followed by the name of the table space. So let me just execute by clicking on this icon here, and you can see here the query returned successfully. That means the table space would have been deleted.